Hello, 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 hello. Hello. Just to let me know, am I audible to all of you? Namaskaram, welcome, Unacademy, Suswagatam. जो बोले सो निहाल सत श्री अकाल वालेकुम सलाम अस्सलाम वालेकुम. This is your Baba HSP. Everyone, just to let me know, am I audible and visible to all of you? If yes, I want to see green hearts in the chat section along with some fire. That will let me know that you can clearly hear me. I'm perfectly audible and visible to each and everyone. That's so fantastic, my dear students. That's really fantastic. The chat section is indicating that yes, everyone can hear me, can see me. Now, this is really awesome. And just before I start this periodic table and the properties, let me tell you one thing, clearly one thing. I will teach each and everything in such a way, that you should get rank like. You should get rank like whom? Like whom? Any guess? You should get rank. If your aim is to get rank like, first name I would like to write Tanishka. I don't know whether you know about Tanishka Yadav or not. The first rank in NEET, 715 marks. First rank. Then I would like to say Mehak Arora. This AIR first. I would like to say AIR first rank with 715 marks. The second rank, I would like to say Mehak Arora. Which rank? Mehak Arora, at that time, AIMS was taking separate exam and she got third rank, AIR third. AIR third in AIMS. And the next year, Chaitanya Mittal. If you know this name, Chaitanya Mittal, AIR fourth in AIMS. And Mehak Arora's younger brother, Shuesh, he got 715 marks. That session, that year, 18 students got 715 marks and he got fifth rank. So this session particularly I would like to say is for those students, those who are aiming for such type of rank, not for everyone. Now tell me, show me green hearts if you want this type of rank, then this session is for you people, otherwise this is not for you. And I would like to complete each and everything with full explanation so that you can solve any question, because this year the paper is supposed to be on the tougher side. You know, last year, the year which has gone, how many students got 720 out of 720? Number of students. So this time definitely the paper will come a little bit tougher. So whatever the slides I prepared that time, means in the previous session, I have added some IIT and IIT advanced questions too in this session. I am going to tell you, because this session holds a hell lot of weightage for each and everyone. So I can see number of people's green hearts now. I know very well one thing, Some of you have taken sound sleep. Some of you have done exercise, but number of students, they have not even taken sound sleep. Even Baba right now coming from the class only. I have taken one class in the morning, 2 classes. Right now I was taking class. I'm right now at Jaipur. I'm teaching here for advanced students, IIT, JEE students, and continuously I'm teaching. I'm also not going to take rest. This is for you kids. I'm not saying I'm doing something different, something extra for you. If you're getting rank, the best rank, I'll be the most happiest person. Our team is going to be the happiest team, kids. And I would like to say this, you cannot get such type of ranks without the teamwork. It's not possible without teamwork. I would like to say, kids, it's not possible without teamwork. Teamwork is required, kids. Teamwork is required. I would like to say teamwork, and that's why I would like to say our team is the best team. Not only knowledge wise, but giving the content wise. You have seen Wasim sir, you have seen Yavas sir. Right now I'm going to take class, and you know very well Ambika ma'am. Am I right or not? First of all, tell me, show me fire in the chat section if I am right. I will not ask for the views, the thumbs up, the likes. If you want, you can give. Otherwise, I'm not going to say even once for the likes. Kids, I'm waiting for that day that our team will give you that white coat. I will wait for that day, kids. And I'm teaching here for that day that you are going to get that white coat for your parents, for your teachers, for your nation. I'm waiting for that time, kids. So that time needs the time. Just like Subhash Chandra Bose said, "Aap hame khoon do, hum tumko azadi denge." Like that, I need your dedication, active presence. Your active presence means a lot. If you are present over here with pure brain, the brain which is going to absorb what I'm going to tell you. Yes, I'm going to give the knowledge. And here, I'm here, kids. I'm here. Our team is over here. Which team I'm talking about? Which team? We are talking about this dedicated team. The best team in this world. I would like to say this is the best team in this world, my dear students. No team can match with this team. I'm the eldest one, but these 3 people, they are having more knowledge, better knowledge than Baba. They are more skilled than Baba. Baba HSP, salute to these 3 great teachers. Baba is so simple. These people are very, very skilled people. That's why this team is the team, the best team, known as the Team Avengers. Agreed, kids? Everyone agreed? Everyone agreed. If yes, I want to see green hearts for this team. Our Ambika madam, Bio Queen, Wasim, Thalaiva, Yavasa. And this is Baba HSP. Now, kids, anyone who wants to get enrolled, because this is valid only for few days. Just at ₹4,999, they can get enrolled for this batch, my dear students, Phoenix Pro Reloaded batch. Yes? Now, I would like to tell you each and everything. I will come one by one. This is over here what I was telling you, kids. You have to share this message to your relatives, those who are interested, your class fellows, means your friends, those who are in need of, just for ₹4,999, and tell them to apply the code HSP10. This is the code to get the fees discount and the mentorship, along with the mentorship. Okay? Now, use this code and see it is valid up to September 15. The time flies, very fast, and 50% off. To get this advantage, they have to apply code HSP10. Now, my dear students, let me make it very fast. You can see iconic mega sale week is over here. Flat 50% off. You can see apply code HSP10 kids to get this advantage. Free flashcards and QFT 100 extended till September 15. So use code HSP10, my dear students. Okay. Now, this is the team you know very well, the fantastic team. These are the centers, offline centers, what I was talking about across India. These are, you can see each and everything. The number of things are over there. And this is NEET UG flashcards I was talking about, the QFT 100, and now available just at rupees 2299. Once again, I'm telling you, apply code HSP10. HSP10 is the code. You can use this code and get huge discount, my dear students. Now see, Sachin, Neha, everyone. Now, Sachin and Neha, no need to tell you anything about it. So this trip to CERN to Switzerland, up to 90% scholarship, total scholarship worth rupees 300 crores. Register now, and this is the number, kids. Okay, UNSAT. You know very well, better than Baba, right? So, are you ready for the periodic table? So, just let me see who is there in the chat section, and then I will start. Let me see. Just give me seconds, kids. Just give me a second. Yes, Harry is there. Satvika, Pranam, Sausi, HSP, and Shivam. I can see everyone, my dear friends. Chat is running very fast. Sir, I am for J2026. Yes. Wow. Fantastic. Monica Priyadarshini is there. Everyone is over there. Now, 680. My dear students, let me tell you once again very quickly that this lecture is equally good for J students as well as NEET students. Whether you are preparing for NEET or you are preparing for J, this content is equally good. I have told you this time the NEET paper is going to be on tougher side. So this is equally good for both type of students. So one thing I'm going to tell you about, that you have to have that much of knowledge that you can see in front of you the periodic table. Then only the periodic properties you are going to get those properties: jet effective, atomic radius, ionic radius, ionization potential, negative electron gain enthalpy, oxy acids, reducing power, oxidizing agent, reduction, oxidation, von Haber cycle, Hess equation. I am going to tell you each and everything, but mark my words, kids. First, you should have a very clear visibility of periodic table in front of you. Are you ready? Some of you must be knowing some elements. Some of you are having knowledge of periodic table, but I will give you such type of questions. Let me tell you what type of questions today I have brought. Yesterday night, I have gone at 11 a.m. back to my house. I was preparing slides, although I am having number of slides, but let me tell you, let me show you how much work Baba has done for you, kids. Let me show you. And to do these questions, to excel such type of questions, to get the knowledge of such type of questions, first of all, let me show you. I will tell you this trick. Such type of slides I made for oxides. I will give you tricks also. Amphoteric oxide. Now let me come to the questions. This is the slide. Such type of slides I will show you for amphoteric oxides. And after giving you this much of knowledge, then I will give you questions like this. Let me tell you where the questions are. Number of questions I made, kids. Just give me a second, kids. Just give me a second. Let me show you one question. At least let me show you one question. See, this type of question. Can you see? To do such type of questions easily within fraction of seconds, you should have to have that much of knowledge which I'm talking about. Such type of questions, if you want to do within fraction of seconds, you should have knowledge, the knowledge which I'm going to give you. Are you ready? I want to see some fire in the chat section if you're ready for such type of questions. Later on, I will give you these questions. But before that, I would like to give you the knowledge. Then only you can do such type of questions. I'm having many questions, kids. So let me come back. This was just the trailer. This was just a trailer, my dear students. Hey, Sim, let me come back and let me start from the beginning. The journey starts from here. Periodic table, PT. Periodic table. The hero, today's hero is PT. PT. 18 by 7. Tan, tan, tan. Ding, 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 ding. What is this 18 and what is this 7? Periodic table, 18, 7. What is 18? What is 7? Anyone? Write down in the chat section. I want your equal participation in the chat section. 18, 7. What is 18, 7? UPSC says, hey, kids, do you know about 18, 7? I'm being the IUPAC. Can you decode this 18.7, 18.7, 18.7? Can you decode this 18.7? I want to see in the chat section what is the 18.7. So the answer comes over here. Long form, that is the present form of modern periodic table. And this is the base, kids. There are two bases. One is taught by Basim sir, the mole concept, and this is the another basic concept, the periodic table. These two concepts will go for the whole organic, inorganic and physical chemistry, right? These two will give you the knowledge of chemical bonding. So just see to it. This modern form of periodic table is given by Bohr-Burries. This is also known as Bohr-Burries and Rang and Werner's periodic table. What I said, just try to keep it in a hippocampus. BBRW, Bohr-Burries, Rang and Werner's periodic table. And this modern periodic law says, just like in today's world, what is most important thing? If any people is getting that thing, then he can find out all things, each and everything about you. What's that? I want to see in the chat section, what's that? If anyone is getting that number, he will reach up to your house, he will reach up to your parents. What's that? Kids, yeah, I can see kids are participating. Now today's words, that is mobile number. What is your mobile number? I want a mobile number. Yeah, what's your mobile number? The mobile number, if anyone is able to get in today's day, the mobile number, he or she can trace you. Am I right? Just like in today's world, the mobile number is very, very important in this periodic table. Atomic number is very, very important. Atomic number is very, very important. If anyone is able to get the atomic number, then he can find out to which group, to which period element belongs. What is the atomic number? The physical and chemical properties of all the elements are based on the atomic number only. Just see, they are based on the atomic number only, my dear students. Just see, the physical and chemical properties of elements are the periodic functions of their atomic number. What I'm telling you, atomic number is going to play very, very important role. Everyone, will you keep this number in your brain? Atomic number. Once any element's atomic number is in my hand, I can talk to that element. Hey, let me tell you one thing more. I always consider, you must be thinking that Baba is mad. Baba HSP, my name is HSP. I haven't told you about me. Let me tell you, I always consider atoms as human beings. Human beings. And electrons as money. Rest of the things I don't know, kids. I know only two things. In the chemistry, there is atom, there are electrons. But in this world, in this nature, what is there? Human beings and the money. With our eye, we can see human beings. We cannot see money. Everyone is having money, but we can't see with the eye. If you apply your brain, you can see money. Money is responsible for bond formation, bond breaking. Each and everything in today's world is based on money, that is electron. If you are able to get this, electron is responsible for combination or for the bond formation of each and everything, then you can find out everything. You can trace out everything. You can decode the whole chemistry, right? Everyone, I want to see thumbs up. The whole chemistry, Baba will teach you. You know, teachers are teaching so much, but students are not able to get that much. Teachers are telling you so much. Very good knowledge, vast knowledge, wide knowledge, but students are forgetting each and everything. But if you remember only one thing, that atoms are like human beings and electrons like money, and human beings and money we know very well, we understand very well. Everyone is having, but no one is going to spend money. Electronegativity will come, reducing, so everything will come. So, yeah, kids, really thanks. I can see your love. Baba, whatever talking to you, you are just reflecting those things in the chat section. Baba is saying thank you from the internal core of my heart. You are my kids. I love you. God bless you, kids. This thing I need, whatever I'm talking to you, if you're reflecting it in the chat section, Baba is going to tell you each and everything. Now see, kids, who is Baba? Whatever I'm going to tell you about myself, you will not believe, but you have to believe, kids. Baba is 52 years old, first thing. This is your HSP Baba, and I'm, what I said, HSP Baba. My name is HSP Baba. People call me Baba because I'm very consistent, very regular. I think about you people. I'm not professional. Baba is emotional but not professional. And Baba's age is, I'm 52 years old. You will not believe, but yes, Baba is 52 years old. Now, okay, this though, leave it. Baba has done MSc in 1999, MSc gold medalist. In 2004, I have completed my MTech. After doing MSc, I have qualified JRF, then GATE, and then MTech. I have started teaching from 1999 only, means after completing my MSc. So my teaching experience is 26 years, at least 26 years. Now, this was all about me. Now let me start what I was going to tell you, this periodic table. Now see, this I have told you. Now, one thing, remember one thing, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 vertical columns. This is according to IUPAC standards, 18 groups. Now, first group is also known as 1A, second is known as 2A. Remember that 1A, 2A. And then after this is S block. This is S block. S block. S block. Now, after this A, B started. B, B. Now 8th. Now, here is 13th, 3A. 13th group is 3A. This is whole total P block. P block. So what I want to say, kids, the S block is having A and the P block is having A. A. Everywhere A. Just see A. And this is 0 group. Now why I am focusing over here? In the NCERT there is misprinting. If you check out your NCERT, they have written there B. That's why people are mostly getting confused. So before letting ahead, let me tell you the S block is A and the P block is A and the D block is B. 3B, 4B, 5B, 6B, 7B, and this 8, 9, 10, it's 8. Neither A nor B. Why nor A? Neither A nor B. Because 18th group is considered as 0 group. 18th is 0, so it is only up to 7th A. And 8th group is made up of 3 subgroups. Clear? Has it gone to your brain? If you want to take a screenshot, you can have it. Remember this, in the NCERT, A and B, they have been misprinted, so you can keep it in your brain. Right, kids? Right, kids? Now, this is the periodic table. This whole colored is P block, that is S block, and the middle one, blue one, is D block, and this is lanthanoid and actinoid F block. Now, these many elements, how many of you want to keep it in your brain? Show me green hearts. I want to see the whole periodic table in your brain. You have to set whatever the time is required, Baba will give you. The first thing is that you should be able to see the elements, where they are located, where they are being placed. I want to see the chat. How many of you are ready to put these elements in your brain? Exactly the position, the location, then only I can start anything. Fantastic, fantastic, fantastic. The things were looking like to be idiyappam. Now they are looking romba sulvam, murku, arpudham. Fantastic, it's fantastic. Now, so kids, just see. First, let me tell you something, then I will start the periodic table. Everyone, you have to tell, you have to say, you have to repeat Sunday morning. Everyone say Sunday morning. Wherever you are having your place, say Sunday morning. Sip. Whatever you are having, sipping, I don't know, sip, 2 times sip. Sunday morning. Everyone say Sunday morning. Sip. 2 times sip. Then simple DP. Then 6 and 7. Say safe DP. So what I am telling you, Sunday morning. Sip, 2 times sip. sip, sip. Then simple DP, simple DP. Simple DP, simple DP. Then everyone says safe DP, safe DP, safe DP, safe DP. Is it clear? I will move step by step. No hurry. No confusion. Just go as I'm telling you. Everyone say, if you're telling, if you're repeating, then you are going to gain. Let me check it out in the chat section. Say everyone, I want to see in the chat section, you have to write down Sunday morning. Saucy HSPN is writing, rest. Sujata is writing. Everyone, you have to write Sunday morning, sip, sip, simple DP, safe DP, safe DP. Sunday morning, sip, sip, simple DP, safe DP, everyone, fast, 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 everyone, Sunday morning, sip, sip. You have to dissolve it. Kids, you have to dissolve it in your blood. Don't think like that. Hey, I know. Sunday morning, then I will show you the magic. Baba is known as magical chemistry guru. Why magical chemistry guru? If you're following me blindly, you have to follow me. Then I will make you brilliant. Sunday morning, sip, sip. You can do exercise. If you're not getting time, stand up. Sunday morning, sip, sip. Simple DP, safe DP. Sunday morning, sip, sip. Now, Sunday morning, sip, sip. Simple DP, safe DP. Now you know very well. You know from the quantum numbers. I will let you know the quantum numbers. Quantum number S contains how many electrons? Tell me. S can contain maximum 2 electrons. P can contain maximum 6 electrons. D can contain maximum 10 electrons. And F can contain maximum 14 electrons. Now see, if I write here 2 electrons, then how much it will come out, kids? Do let me know how much it will come out. 2 electrons. 2 plus 6, 8. 2 plus 6, 8. 2, 10, 6, 18. 2, 10, 6, 18. 2, 14, 10, 6. How much? Hey, Baba, very lengthy. Hey, HSP 32. Like your parastomal teats, bryophyta, pteridophyta. Your Ambika madam must be telling you bryophyta. Even we are having 32 teats. 2, 1, 2, 3. 2 incisors, then canines, premolars, molars. Am I right? 32. These are magic numbers. Now, what we are going to do with the magic numbers, I will show you the jadoo. The magic. I will show you the jadoo. See, jadoo teri nazar. Helium, neon, argon, krypton, xenon, radon, augie. You know the atomic numbers. If you don't know the atomic numbers, Baba will let you know. Everyone knows the atomic number of helium is 2, right? Now, my dear students, what you are supposed to do, you have to help me. 2 plus 8, how much? Fast calculation. I want to see in the chat section, everyone. I don't know maths. Baba doesn't know maths. You have to help me. 2 plus 8. Fast. Let's see who is fast. Everyone. I can see Saucy HSP and kids. 2 plus 8. 2 plus 8 is how much? You're not telling me. Baba is not happy. Baba will start crying. Kids. Yay, 10. I got it. Now 10 plus 10 plus 8, how much? 10 plus 8, how much? 10 plus 8, 18. Yay! Now 18 plus 18, how much? 18 plus 18. Everyone. 18 plus 18, 18 plus 18, 36. 36 plus 18 is how much? 54. Then 32, adding 32, how will you? No, I think helium, neon, and oh, I have left argon. I have left argon. Sorry, kids, argon has been left. Hey, 8, 18. Then 18. If I'm going to add to it, then 18, then 32, 86, then 32, 118. Clear? Now you are able to write down the atomic numbers. Just to let me know. Clear? These noble gas elements, whatever the atomic number is there, that is going to play very, very important role. I want to see in the chat section, everyone is able to reach up to here. I want to see in the chat section, if yes, I want to see yes, then only we can see the periodic table. Then only we can understand the periodic table. Everyone just to let me know. Everyone just to let me know. I want to see the green heart, so the fire or the yes, clear is clear, 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 clear. Now, once you are able to write down this configuration, if you are able to write down this configuration, then how it is going to help you see. You are able to write down this configuration. Helium, neon, he, ni. First of all, remember, he, say he was a person. He has thrown Yorker ball, Yorker. It was Yorker, now you have to say Yorker. If you must have watched 3 Idiot movie, all is well has turned into all is well, all is well. So, Heaney Yorker, and he has thrown Yorker ball. Augie was out on 0 run. Heaney Yorker, 0 run taken by Augie. Heaney Yorker, 0 run. Heaney Yorker, 0 run. Say everyone. Heaney Yorker, 0 run. Everyone say it out. Heaney Yorker, 0 run. Now if you remember the atomic numbers, 2, now if you remember this noble gas configuration, now how to find out the noble gas configuration? If you know above principle, I will let you know, but let me write down here. This is the second period of first period. This is the first period, second period, third period, fourth period, fifth period, sixth period, seventh period. So I will write 1s2. Here I will write 2s2. 2p6. Here I will write down what? 3s2, 3p6. I will let you know how I am writing. Here I will write down 4s2, 3d10 and 4p6. Now kids, how I am writing this? How I am writing? I will let you know. See, what I have told you right now, I have told you Sunday morning. I told you Sunday morning. Have I told you or not? Do let me know. Have I told you Sunday morning or not? Sunday morning, I have told you Sunday morning like this. And let me come to this. 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 And let me come to this. What I am telling you kids. Sunday morning I said. Then I said sip. Sip 2 times I said sip, sip. Sunday morning sip, sip. Now here what I said. For this I said simple DP. Now see, simple DP, simple DP, simple DP. Without going through above principle, Baba is telling you, because if you want to get speed, you have to follow me. I will tell you the above principle. I will tell you the Borswari principle. Each and everything Baba will tell you. But if you want to gain speed, if you want to write down the electronic configuration of lanthanoid, big, huge one, immediately you have to follow me. Yes or no? Yes. Now, one more thing I would like to tell you. If you're new, if you don't know anything, let me tell you, NS is having maximum 2, NP is having maximum 6. But if you want to fill D, n minus 1d means whatever the principal quantum number is there, you have to subtract 1 and then you are supposed to write down d. And if you want to write down f, you have to write down n minus 2f. If this point is clear, then only we can go to that page, my dear students. Whenever you are dealing with s or p, same principal quantum number, n is being principal quantum number. I tell you what is the meaning of principal quantum number. I will let you know, kids, my dear students. Whether you are writing s, it is same, p, it is same, but if you want to write for d, 1 minus n minus whatever the period you are dealing with, n minus 1d, and f, n minus 2f, right? Then come back. So Sunday morning, sip, simple dp, 4s, 4p, 4s, 4p, but d is 3d. D is 1 less, n minus 1d. Kids, are you getting it? Now, if you want to write down for the fifth, then simple dp. I would like to say simple dp. What you will write? For this, what you will write down? I want to see in the chat section. If you are able to understand, this is simple dp. Once again, what you're supposed to write down, just to let me know in the chat section. If you are able to understand, really if you are following it, write down the chat section. Let me see whether you are able to follow it or not. Let me see, kids. If you are really able to understand, do let me know that you are getting it or not. I'm sitting just in front of the chat section. I'm waiting for your answer. Kids, Baba is waiting for your answer. Write down fast. Kids, write down so fast. 5s to 4d10. Yes, Saucy has written. One kid, yeah, everyone. Kirthana has written. So it's, yeah, everyone is writing. Oh, my dear student made my day. Baba is so happy, so happy. So it will be 5s2, 4d10, and then 5p6. Da-da-dan! Dig, dash. Now, save dp, la, la, la. Save dp. So save dp, what do you write down? 6 as 2, 6p6. Now what should I will write down in the middle? My dear students, save dp, f, n minus 2f, n minus 2f, n minus 2f, 6 minus 2. 6 minus 2 will come out 4f14 and n minus 1. So 5d10. Am I right? 7s2. Now minus 2, 5f14 minus 1, 6d10 and 7p6. Without taking help of above, Pauli, Hund's rule, Borsberry's rule, nothing I have considered. I have just followed one trick given by Baba HSP. Just to let me know in the chat section, everyone, are you able to understand or not? Yes, kids, everyone, this point is clear. Is this, oh my God, Lan is writing, sir, I can't understand. No problem, I will teach you. Yes, Phoenix students, you have to make notes. Everyone, you have to make notes, kids. Take your copy and pen. Keep a note of each and every point. Each and every point given by Baba is $1 million. $1 million things. $1 million, yes. Wow. Now, super trick. Yes, keep on telling me this trick is, how is the trick? Then only I will keep on giving you tricks, kids. Then only I will keep on giving you tricks. Everyone, just to let me know how is the trick. Everything you will get. PDF you will get. Clear. Now, let's do the revision. Let's do the revision once more. Those who are unable to understand. Hey, everyone, you have to help me. Now Baba is like a person who has forgotten each and everything. There was one movie, I don't remember that name. He was forgetting something. Then everyone was helping him. Gajni. Now see, Baba has become Gajni. Tell me, help me everyone. What should I write? He, ni, Yarker zero run Augie. Am I right? He ni Yarker. Everyone say speedily and boldly speak it out. He ni Yarker zero run Augie. He ni Yorker zero run to Augie. He ni Yorker zero run to Augie. Now, I know the magic number. What's the magic number? Kids, tell me what's the magic number. Magic number was what? Magic number was what? I don't know, sir. I don't know what is the magic number. I have forgotten. About the magic number. So what you are supposed to do, just to get the magic number, what you are supposed to do? See, magic number. To get the magic number, what you're supposed to do. Everyone tell me what I'm supposed to do. If I have forgotten the magic number, what I'm supposed to do. What Baba is supposed to do to get the magic number. Sunday morning. Sunday morning. Sunday morning. Sip. Sip. Sunday morning, sip, sip. Then what I will say? Simple DP. Simple DP. 2 times simple DP, simple DP. Then what I will say? Safe DP. Safe DP. Everyone, this is clear. Sunday morning, sip, sip, simple DP, safe DP, safe DP. Say everyone, is it clear to each and everyone? Now, the magic numbers, even no need to get the magic number. Without magic number, I will let you know. I will let you know the configuration without magic number. Do you want the magic number? Without magic number, let me see, let me tell you. It belongs to the first period. You know, Hini Yarkar, the period. What is the period number? Period. What is your period number? 1, 2, 3, 4, 5, 6, 7. 7 days, 7 periods. Now see. What I'm supposed to write down this. 2 completed. 2, 6. Now which 2? 1s2, 2s2, 2p6, 3s2, 3p6. Just see, focus on my speed. 4s2, 3d10, 4p6, 5s2, 4d10, 4p6, 6s2, 4f14, 5d10, 6p6, 7s2, 4f14, 5d10, 7p6. Completed without magic numbers. Even without magic numbers. See. Not taken the help of even magic numbers. How many of you got it? How many of you got it, kids? Not taken even the help of magic numbers. 5p6, 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 5p6. Yes, my dear students, who has told me this 5p6? You are nalla iruku, romba sulbham. Those who were thinking like chemistry pidike radu customer, I would like to say, it's romba sulbham, kids. It's romba sulbham. How many of you got it for the first time? Do let me know how many of you got it for the first time. Now, with the help of this, I will reach to Hiddelina knows Rubis in France. First, Hiddelina knows Rubis in France. Rubis in France. Kids, Baba is teaching you the periodic table in different style. I have not completed S block. I have not reached to the P block. First, I have told you the zero group. Why I have told you the zero group? Because every element wants to become like noble gas. They should have noble gas configuration, because noble gas means noble gas. They are highly stable. If you reach to coordination chemistry, they want to have noble gas configuration. Effective atomic number, all the elements, whatever the electrons they are going to donate, what the oxidation state they are going to have, they all want to have noble gas configuration. So, the one in the society is being the most stable. Everyone wants to become like that. Then only you can understand ionization energy, electron affinity. won't have a cycle, each and everything. Yeah, take some time, take some time. What is the trick for this? What is the trick for this? Hidelina knows, say along with me, Hidelina knows Ruby sis in France. There is one Ruby. Ruby sis is living in France. And Lena knows very well. Hidelina knows Ruby sis in France. Hidelina knows Ruby sis in France. All the tricks I will show you. So no need to write the trick. Trick is already written. I will show you. Hidelina knows. Let me show you first. Let me show you. Let me show you. Hidelina knows Rubis is in France. Trick. Hidelina knows Rubis seized in France. Ruby seized in France. Ruby seized in France. Hidelina knows Ruby seized in. Trick already I have written. I told you that I have given 9 to 10 hours to prepare slides for you. Get see. Hidelina knows Ruby seized in France. Hidelina knows Ruby seized in France. Very, very small beryllium along with magical Sir Baba radium. Beryllium and magical Sir Baba radium. S block. Tell me, Baba has done efforts or not? Then I will go back. Gets. Last one wrong. Which one? Which one is wrong? Augie is wrong. Why? Nithishan, why Augie is wrong? Beryllium, magnesium, calcium, strontium, barium, radium. Yeah, you will get Augie. Why Augie is wrong? Why Augie is wrong? Why Augie is wrong? Let me see. Wait, let me see. How you are saying Augie is wrong? Okay, you want to say this one. You want to say this one. You want to say this one. After RN, UUO. You want to say this one. That's why you are saying that Augie is wrong. Say, tell me. You are talking about this UUO. Are you talking about this UUO? Tell me, kids. Tell me in the chat section. Are you talking about this? Configuration I have written wrong. Configuration. Let me check it out. 7s2. Oh, thank you, kids. Thank you. Now you have become my kids. Now you have become really HSPN. Oh, thank you. This should be, what should I write here? What should I write over here? For this only I have written that you are able to understand or not. Now you have become Baba HSP's HSPN army. If you haven't told me, then I must be thinking that yes. Now see, very good, kids, very good. This will be 7 minus 2, 5 or 6. 5 and this should be 6. This should be 6. Wow. You got full marks in the examination. Now you passed it. This is the way. Fantastic, kids. Fantastic. Everyone, show green hearts and fire for yourself. You passed the examination. Full on full. You got full on full. Wow. Fantastic. Wow. This was for you, kids. Wow. Great, kids. Great. Wow. You people are rocking. Now see what I was telling you. So the trick for this, hidden Linanos, Rubis is in France. Now everyone, can you tell me the atomic number of these elements? If I am able to write down these elements atomic number, how to write down the magic number? I got magic number from here. I can get magic number 2, 2, 8, 8, 18, 18, 32, 32. These are the magic numbers. Now my dear students, with the help of magic numbers, I have derived the elements atomic number, elements atomic number, elements atomic number. I got the elements atomic number with the magic number, right? Elements atomic number, elements atomic number, elements atomic number. What was the atomic number? Just do let me know. What was the atomic number, kids? Everyone do let me know. Now, after 2, this was 1. After 2, what will come? After 2, 3. After 10, 11. After 18, 19. After 36, 37. After 54, 55. After 86, 87. Am I right? Am I right? Am I right or not? Now, how to write down their electronic configuration? Suppose if I say this is 54, so cesium's electronic configuration, can I write that xenon stands for how much? Xenon stands for 54. Xenon stands for 54. So I will write this is in which period? This is in which period? This period number 1, 2, 3, 4, 5, 6, 7. So the period number of cesium is 6. So I will write 6 as 1. How many of you are able to understand? If not able to understand, let me write down for sodium. Sodium is 11. Before 11, who comes? Neon. So for sodium, I will write down neon, and it is in third period. So I will write down 3 as 1. How many of you are able to understand? For potassium, I will write down before 19, it's 18. So I will write down argon, and I will write down 4 as 1. This one. How many of you are able to understand? Do let me know. How many of you are able to understand? Kids, because your understanding means a lot for me, kids. Your understanding means a lot for me. Everyone, you are able to understand? Tell me, kids. Clear? Is it 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 clear? Is each and everything okay? Now, fantastic, kids. Fantastic. Now, whatever the thing I have told you, now let me give you the periodic table exact idea. Then I will go to above principle, and then I will come to how to identify the group number, the period number, how many elements they are having, different electronic configuration. This was the brief about the placement of this. Now I'm reaching towards periodic table. Everyone ready? This I have told you a bit of idea. Then I will come back to the same electronic configuration and how many elements they are having different electronic configuration, and how to write down their electronic configuration, whether it is gadolinium or lanthanide, actinide, whatever the thing. But before that, now the part is how to remember the periodic table. Everyone ready? I will come back once again to the periodic table, but before that I want to see that are you ready for remembering the periodic table? Will you remember with full brain? You have to apply your full energy wherever you are seated. You have to speak it out. You have to speak it out loudly. If it's that you are going to do, then only Baba is going to apply his efforts. Promise, make a promise. Ready? Okay. First of all, let me tell you the periodic table. This is your periodic table. S block, P block, D block, F block, S, P, D, F, right? Everyone say along with me. This is S block divided in two vertical columns, alkali metals and alkaline earth metals. Beryllium doesn't belongs to alkaline earth metals. Rest of all these are derived from earth, and that's why their name is alkaline earth metals. Alkaline earth metals. Alkaline earth metals. I'm talking about these are alkaline earth metals. Magical Sir Baba radium. Magical Sir Baba radium is alkaline earth metals, and leave H. This belongs to S block as well as P block, so leave it. Lina, Nos, Ruby, Cis in France, these are known as alkali metals. Alkali metals. Alkali metals. Hidden Lina, Nos, Ruby, Cis in France. Beryllium, Magical Sir Baba radium. Hidden Lina, Nos, Ruby, Cis in France. Beryllium and Magical Sir Baba radium. Right? Alkali metals are highly reactive. Alkali metals are explosive with water. If you react with water, they will put explosion, they will create explosion, and that's why they are dipped in kerosene. They are stored under kerosene. They are stored in kerosene. And lithium is so reactive. Out of these, lithium is wrapped with paraffin wax and plus than kerosene. They are going to put kerosene this. Otherwise, lithium will catch fire. They will catch fire. Otherwise, they are going to catch fire. Catch fire. Now, our target is right now to remember these elements. Reactions I will tell you later on. Reactions Baba will let you know later on. So, first target is to remember these elements. This alkali metals is clear. Everyone say hidden Lina, Nos, Ruby, Cis in France. Beryllium and Magical Sir Baba radium. Right? If you know already hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, beryllium, magnesium, calcium, strontium, barium, radium, then it's okay. No need to make trick. If you can't remember, then trick is required. If you can keep it in your brain without the trick, then it's fine. Okay. Now, after this, everyone, help me. What should I write here? What should I write over here? If you know whatever I have told you, then help me out here. What should I write? Hydrogen was over there. Hidden Lina, Nos, Rubies, Cis and France. Now leave this. What should I write down? What should? Beryllium, Magical Sir Baba radium. It's clear? Everyone, is it clear? Is it clear? Keep on showing me the sign of hearts or fires if it is clear. Hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, beryllium, magnesium. Put their cross. Don't start from there. After cross. Cross. Beryllium, magnesium, calcium, strontium, barium, radium. These two are radioactive elements. So leave them. Then I will define their properties. Everyone. 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 Okay. Fantastic. Fantastic. Now come to P block. Come to P block. Come to P block. See. Baba has created for you. Now, buying all grapes or bought all grapes in Thailand. Buy all grapes in Thailand. Now, who has done so? Buy or bought all grapes in Thailand. Buy or bought all grapes in Thailand. Let me write down. Boron, aluminium, put over the cross. Boron, aluminium, gallium, indium, thallium. Now, this is very, very important group. You should remember this, because otherwise it's going to be a problem if you're not able to remember it. Now, what I'm going to write, it's period. 1, there is cross. Second period, third period, fourth period, fifth period, sixth period, and 7, there is cross. Buy all grapes in Thailand. Boron, aluminium, gallium, indium, thallium. Remember that this is thallium. Boron, aluminium, gallium, indium, thallium. So what is the trick? Buy all grapes in Thailand. Buy all grapes in Thailand. Everyone say, buy all grapes in Thailand. Boron, aluminium, gallium, indium, thallium. Either you say boron, aluminium, gallium, indium, thallium, or you say buy all grapes in Thailand. Bal Ganesha in Telangana. Bal Ganesha in Telangana. Bal Ganesha in Telangana. Buy all grapes in Thailand. Buy all grapes in Thailand. Bal Ganesha in Thailand. Bal Ganesha in Telangana. Everyone, whichever is going to suit, you can go with that. You can go with this, or you can go with this. Bal Ganesha. Bal Ganesha. Bal Ganesha in Telangana. Bal Ganesha in Telangana, or Bal Ganesha in Thailand, or boron, aluminium, gallium, indium, thallium, or Bal Geet, whatever. It's gone. Now, just see another one. Bal Ganesha. So I will write down Bal Ganesha. Bal Ganesha in Thailand. Okay. So it's 3D. So it will start from upside, a little bit up. Bal Ganesha. Here, aluminium, gallium, indium, thallium will come out, right? But let me tell you the elements. Now see. Bal Gangadhar in Thailand, or Bal Ganesha in Thailand, or buy all grapes in Thailand. Crows. All crows are singing German song in Punjab. Buy all grapes in Thailand. It was the story of birds. Buy all grapes in Thailand. Crows are singing German song in Punjab. Crows are singing German song in Punjab. By buying all grapes in Thailand, now all crows are singing German song in Punjab. Clear? Crows are singing German song in Punjab. Kiran Pathak, welcome, welcome. My kids, crows are singing German song in Punjab. Is it clear? Crows are singing German song in Punjab. So let me write down. Okay, just a second. Just a second. Just a second. Crows. So this was boron, aluminium, gallium, indium, thallium. Now carbon, silicon, germanium, tin, lead. So what I have told you the trick for this? What I have told you the trick for this, kids? Crows Crows are singing, 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 singing. German, German song in Punjab, in Punjab. What was here? By all grapes, by all grapes, all grapes in Thailand. Crows are singing, German sing in Punjab. I think this is clear to each and everyone. Till now it's clear. Till now it's clear. So, till now it's clear to each and everyone, kids. Now, by all grapes in Thailand, crows are singing German song in Punjab. Nana Patekar, Aishwarya auntie is having biscuit. Nana Patekar and Aishwarya auntie is having biscuit. Nana Patekar, Aishwarya auntie is having biscuit. Usse tipo. Florida to Florida, bro and I. Florida to Florida, bro and I at once. Now, he, ni, yarkar, zero run. The whole P block is in your brain. The whole P block is in your brain or not? Kids, do let me know. The whole P block is in your brain or not? Now, let's come to the D block. Let's come to the D block. First of all, do let me know the whole S block and P block. You are able to remember anything you want from my side. Atoms name: boron, aluminium, gallium, indium, thallium, carbon, silicon, germanium, tin, lead, nitrogen, phosphorus, arsenic, antimony, bismuth, oxygen, sulfur, selenium, tellurium, polonium, fluorine, chlorine, bromine, iodine, astatine, helium, neon, argon, krypton, xenon, radon. Just see Baba. How Baba is going to tell you. See. Oh my God. Just wait. Am I audible and visible to all of you? First of all, do let me know. Can you hear me? Can you see me? Now, just see. Here. Hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, phos, beryllium, magnesium, calcium, strontium, barium, radium. Third A. Boron, aluminium, gallium, indium, thallium. Now, fourth A. Carbon, silicon, germanium, tin, lead, nitrogen, phosphorus, arsenic, antimony, bismuth, oxygen, sulfur, selenium, tellurium, polonium, fluorine, chlorine, bromine, iodine, astatine, helium, neon, argon, krypton, xenon, radon. Hidden knows ruby seas in France, cross, beryllium, magical sub, baba, radium. By all grapes in Thailand, crows are singing German song in Punjab. Nana Patekar, Aishwarya auntie having biscuit. Usse tipo, Florida to Florida, bro and I at once. He, ni, yarkar, zero run, ogi. Tell me, kids. Tell me. Kids, fast. I want to see your... Kids, fast. I want to see your chats. It's clear. Kids, you have become slow. Kids. I don't want to see that. Now, see, kids. See, everyone. Now, come here. D block. Sky laces in Tizori, half on roof. Trick for this. D block. Sky laces are in Tizori, half on roof. Trick. Sky laces are in Tizori, that is half on roof. Clear? For 2 3D groups, that is for this one 3 and 4. Sky, SCY, sky laces are in Tizori, that is half on roof. Kids, sky laces are in Tizori, that is half on roof. Now, everyone repeat it. Sky laces in Tizori, that is half on roof. Sky laces. Everyone say, everyone just say, Sky laces in Tizori, that is half on roof. Kids, sky laces in Tizori, that is half on roof. Now let's see this one. Victory of Nobita. Nobita, you know Nobita? First of all, you do let me know Nobita. You know Nobita? Victory of Nobita in Dubai. Nobita serial, have you seen that Nobita serial? Just do let me know. Victory of Nobita in Dubai. Crazy mole on the tongue of singer. Victory of Nobita in Dubai. Crazy mole on tongue of singer. Man is touching Revon heights. 5, 6, 7. Kids, I have done so much hard work, lot of hard efforts. Kids, I want to see in the chat section whether you are able to get it or not. Everyone just to let me know. Doraemon, yeah. So write down, everyone repeat, victory of Nobita in Dubai. Victory of Nobita in Dubai. Everyone say victory of Nobita in, okay, you are talking about Doraemon and this and that. Victory of Nobita in Dubai. Crazy mole on tongue of singer. Man is touching Revon heights. Wow, P. Lakshmi, fantastic, fantastic, fantastic. Now, kids, next one. See, next one. Ferrum is having, yes, awesome history. Ferrum, you know, iron is having, yes, that is required for hemoglobin. Ferrum is having awesome history. Ferrum is having awesome history. That's why cobalt and rhodium are irregular to market. Cobalt and rhodium are irregular to market. And see about this nickel. Nickel and Pandu are having potato dosa. Nickel and Pandu is having potato dosa. You know that dosa they are going to prepare on ferrum. Ferrum means iron sheet is there. Iron sheet is used for making dosa, potato dosa. So what is this? Ferrum is having awesome history. Ferrum is having awesome history. This you know very well from the biology only. Ferrum is having awesome history, and that's why cobalt and rhodium are irregular to market. They are not going because no one is using cobalt and rhodium. Kids, just think the story. Think about story. Ferrum, everyone is going to prepare dosa on iron plate. Iron material is there. Utensil is made of iron. So ferrum is having awesome history. Yeah, ferrum with awesome history. So everyone is eating potato, that dosa which is made up of potato, and cobalt and rhodium. No one is liking cobalt and rhodium. If you want to cook, will you use cobalt and rhodium? No. So ferrum with awesome history. Cobalt and rhodium are irregular to market. So no one is going to sell. No one is going to purchase cobalt and rhodium. Have you ever gone to the market and saying, hey, give me 1 bucket of cobalt. Give me 1 spoon of rhodium. Have you ever asked? See kids, just think about the story. You will get it automatically. Ferrum with awesome history. Cobalt and rhodium are irregular to the market. Nickel and Pandu are having potato dosa. Kids, now just see whether you are able to get it or not. If you repeat it 2 or 3 times, you will get it, my dear friends. You will get it. Now, first of all, do let me know tricks. Kids, you have to remember. Now see. Now after this, nickel, palladium, platinum. Nickel, palladium, platinum. This I already have told you. Nickel, Pandu are having potato dosa. Copper, silver, gold, UU, and Zinni, Canada. Zinni is having Canadian hex in the scene. This is also known as scene, SCN, CN, CN. Zinni is having Canadian hugs in this scene. This is clear, kids. Tell me first of all, let me know, kids. Till now, is it okay? About the D block elements, Zinni is having Canadian hugs. Zinni is having Canadian hugs in the scene. There is one scene, movie scene. In the scene, S-C-N-E, scene, Zinni is having Canadian hugs in this scene. Now, kids, first of all, do let me know. I've told you these elements. If you remember these elements, then only I can tell you these elements, they are having exceptional electronic configuration. But before telling you, I want to see in the chat section, kids, it's not easy to remember the tricks. It's not easy, but if you continuously revise it 2 or 3 times, definitely you will get it. First of all, do let me know the elements of S block, P block and D blocks. Are you going to remember it? Then only Baba can help you. I want to see in the chat section, kids. Will you able to keep these tricks in your brain, kids? Kids. Now see. You know that electronic configuration should be like, before telling you, before letting you know the exceptional electronic configuration, let me tell you why and how you will write down the electronic configuration. Electronic configuration, just see, kids. Are you ready? Electronic configuration. So, to write down electronic configuration, you should know psi NLM, Neelam, or Newton's law of motion, like that. These are 3 quantum numbers. These are 3 quantum numbers. N is known as principal quantum number. Its value is from 1, 2, 3, 4, 5, 6, 7 and so on up to infinity. This is going to tell you to which shell. It is going to tell you about the shell, how far the electron is away from the nucleus. Now L is angular quantum number. Angular quantum number, my dear students, its value is going to range from 0, 1, 2, 3 and so on up to n minus 1. Remember that. L can never be greater than L. L can never be equal to N. So what I'm saying, L can never be greater than N. Not possible. L cannot be equal to N. That's also not possible. L for Lalla and for Nanna. Nanna is grandappa, grandfather, bigger one, right? So L will always be smaller than N. Remember this point. Then only you are going to succeed. These 2 points are clear, kids. Now if L is coming 0, then the value says S, then P, then D, then F. 2 points are clear. Will you be able to keep these 2 points in your brain, kids? Do let me know. I want to see in the chat section. Will you be able to keep it in your brain? Now I am going to tell you Aubert principle. Baba will let you know about the Aubert principle. Then only I will tell you why the electronic configuration is different, kids. Fast. Do let me know. Everyone, this N and L is okay. N and L is okay or not, kids? Respond quickly. Nanna is always greater than Lalla. L for Lalla. Let me write down. Everyone remember, L is being Lalla. Lalla is a smaller kid. And N is Nanna. N is Nanna. nanna. Who is bigger? Who is bigger one? Do let me know. Nanna is bigger or lalla is bigger? Nanna is always greater things. One is Bohrs-Burry's rule. There is Bohrs-Burry's rule. What is that? Bohrs-Burry's rule. This says the one whose n plus l is coming lower value, is giving lower value, that will be filled first. Bohrs-Burry's rule says the n plus l is coming lower, that will be filled first. And if this rule is getting failed, then I will tell you the second rule. But let me tell you first this rule. If I say there is 3s, and if I say there is 2p, there is 3s and 2p, just find out their quantum numbers. So whatever is written over here, I have told you n, l, m. The first one is n, the second one is l. The first one is n and the second one is l. So the value of n is coming out 2. N is equal to 2 and l is equal to p, and l is equal to p means that when p, then it means the value of l is 1. How to get it? Get C. I've told you P, 1P, 2D. 2 stands for D, today. Remember that today. This is a trick. Today. Now see, and this is 1 for P. Can you get it? 1 for P, that means, where it's gone, kids? That means P, so the value of P is here 1, that means this is 2, N is 2, and L is 1. 2 plus 1 is coming out 3. And here 3s means 0, so 3 plus 0 is also coming out 3. Tie, there is tie. So N plus L is coming same. This is 3 and this is also coming out 3. Are you getting my point? So this rule got failed. Now which rule we have to apply? Which rule we have to apply? But sir, first tell us this point where this is going to be valid. Let me tell you, kids. If I say there is 4s and 4p. Now we know very well 4s is going to be filled first. Now see, 4 plus 0 is coming out 4. 4 plus 1 is coming out 5. Now which one is lower? This one is lower or that one is lower? This one is lower. That means it is having less energy and that is having more energy. The energy is like this. Energy is like this. Now what is to be done with the energy? The one who is having less energy will be filled first, and this is the above principle. Now once this rule is getting filled, n plus l, see here it is getting passed. So 4s will be filled first and then 4p. After 4s, 4p will be filled, means above principle states that the electrons will be filled in the increasing order of energy level starting from the lowest energy level. So this is having lower energy and that is having higher energy. So 4s will be filled first and then 4p. But here it is also coming 3 and this is also coming 3. Once n plus rule is getting filled, which rule we have to apply? Now see, kids, everyone see to it. So I'm saying once the n plus rule whose coming lower value is coming will be filled first. Lower value 1 will be filled first. If this rule is getting failed, then second rule. If n plus l is coming same, then the one with lower value of n will be filled first. If you are able to understand, then do let me know. out of 2p and 3s, which will be filled first? Definitely it is going to be filled first, and this is the energy order. The one with lower energy will be filled first. This will be filled first. So let me write down above principle, then I am going to define it. Now see kids, can you help me which country above belongs? Above belongs to which country? Which country's scientist above is? Which country's scientist above is? Above, which country's scientist? Tell me which country's scientist above is. Do let me know in the chat section to which country above belongs. I want to see kids which country above belongs. Everyone do let me know. Which country? Yeah, very good, toppers came. Fantastic answer, fantastic answer. Above is not a scientist. This question has been asked once. Not a scientist. Not a scientist. Meaning of above is building up. Building up, building up, building up. Now this rule says, this rule states that filling of electrons will take place in the increasing order of energy levels starting from the lowest energy level, lowest energy level. Now kids, either you can go with Bohr-Sbury's rule, or I am going to give you one trick. You can follow that to get it. See kids, what's the trick? Trick is just write down 1s, 2s, 3s, 4s, 5s, 6s, 7s, cross 2p, 3p, 4p, 5p, 6p, 7p, double cross. Don't forget to put double cross. My dear students, you know that when we talk about orbits, if you think about atomic structure, this is the atomic structure. The first orbit, it is having just s, 1s. The second orbit will have 2s and 2p. The third orbit will have 3s, 3p and 3d, and keep on like that. So don't forget to put cross over there. Now here 3d, because d starts from the third orbit, this is the principal quantum number. N is equal to 1, 2, 3. The principal quantum number that is giving you the number of shell to which electron belongs. This is the shell number 1, shell number 2, shell number 3, or you can say K, L, M. Then Lambert partition, you will go into the atomic structure. My dear students, are you getting it? Everyone, you are able to understand? Now see, 3D, 4D, 5D, 6D, 7D. Now I will put triple cross because from the fourth orbit F will start. 4F, 5F, 6F, 7F. Now what you are supposed to do? Do you remember your childhood when you are coming down that which game? The slope you are coming from up to downside. I don't know what the game was that, but Just we have to play that game only, kids. See, what's that? You have to come down like this. Then go up, come like this. Then once again go up, come like this. Then once again go up and come like this. Then once again go up and come like this. Then once again go up and come like this. Are you getting my point, kids? Going up and coming like this. Is it clear, kids? Go like this. The stairs, from stairs come through slope. Then stairs come like this. Then go stairs up. Then come like this. Is it clear, kids? Are you getting my point or not? Come like this. Come like this. Come like this. That trick I have told you, this is another trick. First of all, do let me know. Show me green hearts if you're getting it, kids. I want to see that. I think you are tired up. My dear students, Baba has not even taken a sip of water. Kids, everyone do let me know till now whatever I am telling you. Is it clear, kids? Either you can follow Borsberry's rule or this what I am going to tell you. Is it clear? Everyone just do let me know. Show me green hearts if you are able to understand. I want to see green hearts, my dear students. Fast, 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 fast. No need of atomic structure. There is no need of atomic structure. Okay, I will little bit slow you want. Okay, okay, okay. Kids, always keep on showing me green hearts. Very good. Now see, if you are able to understand this graph, just let me tell you, you have to follow it. Then which orbital I will fill first? Do let me know what is coming first on your way. On your way, 1s. I will write down 1s. Okay. Here the energy is increasing in this order. Energy, I will write down energy is increasing in this order. Energy is increasing. 1s. After 1s, what will come on your path? Write down what will come on your path. 2s. After 2s, go up 2p, then 3s. 2p, then 3s. Now let me know you are able to understand. After 3s, go up 3p and 4s. After 3p and 4s, what will come next? What will come next? 3p, 4s. Go up 3d, 4p. 3d, 4p. After 4p, 3d, 4p. 5s. After 5s, go up 4d, 5p. No need of atomic structure. Just follow what I am telling you. Now, you are able to understand this, what I have written right now, kids. Everyone just to let me know what I have written. You are able to understand it. My dear student, just to let me know whatever I have written, you are able to understand or not. Is it clear to each and everyone? Let me have a sip of water, kids. Let me have a sip of water. Very good, kids. Very good. Very good. Very good. Very good. Now I can see people are getting it. Now, if anyone is saying, if this point is clear to each and everyone, this much is clear. Now see how to write down any elements at electronic configuration. See, if someone is asking write down for carbon 6, what I will do? What I will do? What I will do? S1s. Now S can contain maximum 2 electrons. Then 2s. Then how many electrons? 6. 2. 2. 4 plus how much will become 6? 2. This is the electronic configuration of carbon. Electronic configuration of carbon. Is it clear? It's clear, kids? Now, if somebody is asking, write down electronic configuration of neon. Atomic number is 10. Neon. Atomic number is 10. How I will write down, kids? See. 1s2, 2s2. How much should I add to the 4? So that it should become 10. 2p6. Do you remember this? I have told you in the starting. Sunday morning sip sip. Even you can write down with the help of that. Sunday morning sip sip. Now if anyone is asking how to write down the electronic configuration of zinc. Atomic number of zinc is how much? Zinc's atomic number is 30. Now I will write down 1s2, 2s2, 2p6, after 2p 3s2 and 3p. How much? See, 2 and 2 4, 4 plus 6 10 and 2 12 and 12, then 3p 6. How much? 12 and 6 18. After this, what I will write down? I will write down 4s2. Then how much? 2 to 4, 6 10 to 12, 6 18, 2 20 and this 30. So I will write down 3d10. Now kids, if you are unable to go with this, I am having one more trick. Should I tell you? Baba is having one more trick. Should I tell you that? Show me some fire, then I will let you know. See, if you don't want to follow it, in the starting I have told you Sunday morning sip sip. Sunday morning sip sip, then simple DP, safe DP, safe DP. See, Sunday morning, just see, Sunday morning. This is Sunday morning. Then see, sip. Oh, then see, it's sip. Then once again it's sip. Then simple DP, it will come out simple DP. You can follow that rule. Sunday morning sip sip, 2 times sip sip. Just see. Let me show you, kids. Sunday morning sip, then simple DP, then simple DP, then safe DP. It is coming like, see, just correlate, kids. In the starting from where I have started, just think about it. Just feel the analogy. Sunday morning, then sip, then sip, then simple DP, then simple DP, then safe DP, then safe DP. It is coming like that. It is coming like that or not? First of all, tell me, kids, the thing I have told you, this one, just see. See, my dear students, simple Sunday morning sip, then simple DP, then simple DP, then safe DP. Just see, kids, see, I will show you. Now, let's start. 1s, then 2s, then 2p, then 3s, then 3p. After that, then 4s, after 4s, d, n minus 1d, so 3d, then 4p, then 5s, n minus 1d, 4d, then 5p, then 6f, then f is n minus 2f, 4f, then 5d, then safe DP, it should be P. It's 6P. Now see, kids, the above principle which I have shown you, it's getting matched or not. The best thing I am giving you today, no one has ever given you, kids. Just to let me know. It's getting matched or not. You can't, Shivam Mishra, you can't Kids, how many of you can correlate it? How many of you can correlate it, kids? Hey, my dear students, just to let me know how many of you are able to correlate it. Show me green hearts if yes. If you are able to correlate it, just show me green hearts, kids. Baba is doing hard work, kids. Baba is making all best efforts, kids. Baba will get demotivated, kids. Just to let me know. And those who are new, yes, everyone. Wow. Superb trick, superb notes, kids. I always need your green hearts. Then only Baba will understand, kids. Otherwise, how Baba will, kids? If only one student or two students are commenting over there, sir, I am unable to understand, and you are sitting, keep quiet, then how Baba will come to know that all my dear students, they are able to understand? Always keep on showing green hearts, fire. Now, see, any atomic number, just give me any atomic number. Baba will tell you how to write down electronic configuration with this trick. Always you have to remember this trick only. Sunday morning, sip, 2 times sip, 2 times simple DP, simple DT. You can write down any electronic configuration. You just give me any electronic number, any atomic number. I will tell you how to write down. See, hard work will convert into smart work. See, 54. Let's take 54. Atomic number 54. Let's take helium, neon, argon, krypton, xenon. Earlier I have told you its configuration. Now let's do once again. Should we do? This is very big number. Now let's do with the help of above principle. Are you ready? Everyone, are you ready, kids? Otherwise, in the starting, I have told you like this: 1 first period, 2nd period, 3rd period, 4th period, 5th period. So 5th period, I have told you 5s2, 4d10, and 5p6. This already we have done like this. Now let's cross check it. See, Sunday morning. Should I write down Sunday morning? Then 2 times I will write down what? Sip, then simple DP, then simple DP. Let's see the energy order. I will write down like this. This. I will write down like this. Okay, now see to it. Everyone just see to it. 2 electrons, 1s2, now 2s2, now 2p6, after that 3s2, then s, 3p6, after that 4s2, now 3d10, now 3p6, after that 5s2, now 4d10, now 4p6. Now let's check it out. How much? Though 2 to 4, 6, 10, 12, 18, 20, 30, 36, 38, 48, 48 and 6, 54. We have reached over there. See, last one, just see. This thing already Baba has explained without above principle. The same thing I have already proved. Just see to it, kids. Just see to it. Everyone just see. And show me fire in the chat section if you are agreed. The same thing earlier I have shown you, kids. Tell me, kids. Getting matched or not? 4p6, 5p6, where? Yeah, 5p6, right, kids? 5p6. You are getting it. 5p6, yes. So it has become easy or not? First, do let me know it has become easy or not. Yes, it has become easy. Now see, kids. If anyone is telling you write down the electronic configuration of manganese 25, what you will do? How will you write down? How will you write down? See, Sunday morning sip, simple DP. Let's see, the energy will increase in this way. Am I right? Energy will increase in this way or not? Will increase. Now, how many electrons in the S? 1s2, 2s2, 2p6, 3s2, 3p6. Am I right? 4s2. Now 3d. How many 3d? 2 to 4, 6, 10 to 12, 6, 18, 18 to 20, and 5, 25. Done and dusted. Done and dusted. Done and dusted or not? Everyone just to let me know, done and dusted. You are able to understand or not? How speedily you can write down the electronic configuration, that means a lot. That means a lot. How speedily you are able to write down the electronic configuration. Now, let me tell you, if anyone is asking how to write down the electronic configuration of chromium and copper, I will show you. Its expected electronic configuration is like this. Expected electronic configuration. Sunday morning sip, simple DP, simple simple DP. Now see, expected one is, help me, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 2 to 4, 6, 10 to 12, 6, 18, 20, up to here 20. Now 3d4, 24. This is the expected one, but this is wrong. This is wrong. Why this is being wrong, kids? The configuration says that one electron from here will transfer to D. One electron from here will get transferred to D. So the configuration, actual configuration will become like this. Actual configuration will be 1s2, 1s2, 2s2, 2p6, 3s2, 3p6, then 4s1, 3d5, 3d5. While filling electron, we will write like this. While filling we will write like this. But once we are going to eliminate out electron, if we want to eliminate out electron, so then we will write it like this during elimination. Let me tell you, during elimination, rest of the things will remain same. Rest of the things will remain same. These many things will remain same. Here it will come like 3d5, 4s1. Now the question arises, why? Pucho kyun? Now the question arises, why? How many of you want to know the reason for this? Why while elimination we will write it like this and by filling we will do like that? Tell me. How many of you want to know the reason? How many of you want to know the reason? First, why filling and elimination we will do different things, and then I will tell you exchange energy one. Now see kids, see, the God has created this element. The God has created this element, and God has created in this order that if I say this is the nucleus, chromium will have 24 protons. And if chromium is having 24 protons, first orbit, then second orbit, then third orbit, and then the fourth orbit will be like this. And God has filled it like this. See kids, 1s2, 2s2, 2p6, 3s2, 3s2, 3p6. Now God has filled over here 3d5 and 4s1. Now if anyone is going to attack on this element, who will get captured first? Suppose, hey, this is Champa. Champa is over here and Pandu is coming. Pandu is villain. Pandu is villain. Hey, I will come and will take you. I will take you away from your house. Now, who will get encountered first? Who is going to get encountered first? He will meet with Champa. There is Champa, these are Alias and blah blah blah. This is Alia, this is Ramu, this is Shamu. Everyone is free, but this Champa has to fight with this Pandu and they are going to get interacted. Am I right? The last one. So the last one is going to eliminate out first. That's why while filling there is one rule and while elimination out there is another rule. Is it clear? Is this point clear to all of you kids? Now, why the electron has been shifted? The reason for why for in the chromium 24 the electron has been shifted. It's not like this 3d4 and 4s2. This is wrong. Why the electron has been shifted? It is like 3d5 and 4s1. Now see, you know very well kids, this is the D subshell and it is having 5 orbitals, 1, 2, 3, 4 and 5. Now one electron in each orbital, 1, 2, 3, 4, 5. Now this electron is saying, hey, I want to come to your house, but Pauli is saying no, 2 electrons can lie in the same orbital. Once they are single electrons, they have to occupy, yes, just one orbital. And they should have same spin. Who says? Hund's rule says they should have same spin. Now, if this is coming to this orbital, then it has to go to this orbital, right? So it can go to this place, this orbital, it can go to this orbital, it can go to this orbital, it can go to this orbital. 4 exchanges are done by this electron. Now, this electron is saying, hey, I haven't come to your house. I'm coming. Oh, inge ba, just come, just come. It will go to 3 houses, 3 exchanges. Now this is saying, oh, I want to come to your house. Okay, come. 1, 2. It is making 2 more exchanges. Now this will say, I want to come to your house. How many total exchanges? Just count. 4 plus 3 plus 2 plus 1, 4, 3, 7, 2, 9 plus 1, 10 exchanges. Now my dear friends, just remember the COVID pandemic. Everywhere there was curfew. Everyone was localized. Localized means not able to move. Locked. Localized means locked. Was unable to move. Unable to move. What do you think? If you are localized, somebody is saying just remain at one place, sit at one place. That is good position. Or you are delocalized. You are allowed to move. You are allowed to move. That is delocalized. Delocalized means freedom. Freedom. You can exchange your place. Freedom. Exchange your place. You can go to some other place. Which condition is better? Do let me know which condition. This is first condition and that is second condition. What do you think? Which condition is better? First one or second? Do let me know in the chat section. Which condition is better, kids? Do let me know. Which condition is better? You are allowed to move or you are not allowed to move. If somebody is saying don't move, you are not getting freedom. I will give you a break, but let me teach kids. Freedom, delocalize. So you know that. You know, electron is like wave plus particle. Electron is wave plus particle. That means electrons are vehicle. Electrons are vehicle. Electrons are vehicle. Once they are vehicle, they want to occupy more space. Wanna more space, then only they are feeling good. So they are getting more space. Now total 10 exchanges. While exchanging, they will have less energy, more stability. With this exchanges, energy will decrease and stability will increase. Stability will increase. Is it clear, kids? Till now this is clear. Why the half-filled stability? Because whenever I'm going to tell you ionization energy, electron affinity, then this will come into role, that what is half-filled stability and full-filled stability. So remember that half-filled and full-filled. Half-filled stability and second one is full-filled stability. I will explain you that fully filled stability is better, even better than half-filled stability. And second thing, just see to it. Let me write down. Half-filled, this is known as half-filled stability. Whenever you see half-filled stability, that means there is going to be, yes, exceptional configuration. Now second one is fully filled stability. This is half-filled and second one is fully filled stability. Fully filled stability. Now what is that? On the basis of this, there should be different electronic configuration of element. Just see, there I have told you chromium. Here was chromium, atomic number 24. Here is copper, atomic number 29. Can you write down the electronic configuration of copper? So expected electronic configuration of copper will be expected. Just see the expected. Expected one is kids, Sunday morning, sip, simple DP. Do you remember simple DP? From the beginning I am telling you. Now see, 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2 and 3d 9 and 3d9. It should be, see, up 2 and 2 4 plus 6 10 12 6 18 20 and 9 29. So copper's atomic number is 29. This is expected, but this is declared to be wrong. This is declared to be wrong. Now why? Can you see the reason? Can you see the reason? Reason is that if it is like this, if copper's atomic number is 29 and if it is like this, 3d9, 4s1, then there are only 9 electrons here. Sorry, it was 4s2. Just see, it was 4s2. So 4s2, here it should be 4s2. But this is wrong, so it will convert into what? It will become 3d10 and 4s1. This is the correct one. This is the correct one. Now why this has happened? Just see, if I write down the subshell 3d1, 2, 3, 4 and 5. Now just see to it, kids. 1, 2, 3, 4, 5. Now 6, 7, 8, 9, 10. The green one can go to their houses. The green one can exchange their house. They can exchange their orbitals. The green one can exchange their orbitals. So green one will make how many exchanges? Do let me know. Green one will make how many exchanges? Green one will make 10 exchanges. Already I have told you how they will make 10 exchanges. 4 plus 3 plus 2 plus 1 will come out 10. And the This maroon one or reddish one will make 10 exchanges. They will also go in the same spin like 4 plus 3 plus 2 plus 1, 10 exchanges. So 10 plus 10, the 20 exchanges. 20 exchanges are there. So they are making more exchanges, but a little bit stability will get decreased because of pairing. In the one orbital there are 2 electrons. So stability will increase because of these 20 exchanges, and bit of stability will decrease also. Some stability will decrease, will get decreased because of pairing, electron repulsion, because of pairing. Now till now is it clear, kids? Till now is it clear? This is known as fully filled configuration. This is known as fully filled configuration. My dear student, just to let me know till now this is clear. If yes, everyone show me green hearts or fire in the chat section. Yes, kids, so that Baba can understand that you are able to get it, kids. My dear students, everyone just to let me know. Fast kids, fast, very fast. I want to see in the chat section. Everyone. So you are so slow, kids. Slow. Don't be so slow. Fast. Yes, kids. Very good. You are really great students. Really fantastic students, kids. Let me teach, then I will give you a break, kids. Let me teach, then I will give you a break, kids. First of all, let me teach. Let me clear this configuration part. Let me tell you each and everything about configuration, then I will give you a break. Okay, kids. First, let me complete this configuration part. Definitely, I am going to give you a break. Okay, kids. I'm promising you, kids. This is Baba HSP's promise. Baba is never going to break his promise. Now, kids, what I've told you, I was going to this part. These are the elements who are having their exceptional configuration. These are the elements. These total elements, they will have exceptional configuration. You just remember that. Once you know the periodic table, this is looking like key. Can you see? It is looking like key. And all these elements, see, copper is expected to be having D4s2, but it is having 4s1. So remember that whatever the elements I have written, they will be having exceptional configuration. And they all will be having 4s1. But there is one element who is having 4s0. These all are the exceptional electronic configuration. Only you know two. You know only two elements, those who are having exceptional configuration, chromium and copper. But these are the total elements whose configuration is not according to above principle. There is one change, that all they are having 4s1 or 5s1, whatever the s1. So let me write down ns1. They are having configuration ns1. But remember Pandu, this Pandu is having 4 or it is 5s0. So it is having s0 configuration. Remember that super special electronic configuration of Pandu. Pandu is having S0. Rest of all these exceptional, you see it is looking like key. If you see this shape, what type of shape it is looking like, just focus over here. This shape is looking like key. Can you see? It is giving appearance of key. Just see to it. It's looking like key or not? Just do let me know, it is looking like key or not. Just you can remember it easily. These are the elements with exceptional configuration, and this PD is having 0, rest all are having NS1 configuration. Clear, kids? This much is clear? If yes, once again, don't forget to show me some green symbol, kids. That is TC is having a little bit. It is there, kids. TC is there, but some ambiguity is there in the TC. One NCERT is writing, one NCERT is not writing, so leave it. It is given different in different books, so you can eliminate it out. But yes, according to NCERT, it is there. According to NCERT, it is exceptional. According to NCERT, it is exceptional. Yes, I would like to say yes. TC is there. Clear? Let me see the chat section. Yes, everyone is liking it. Everyone is able to understand. Now let me move to F block. Now see, kids, once I am going to move towards F block, just see, kids, what I am going to tell you, the important thing. Point to be noted, my lord. See, kids, before reaching towards F block, just see. I'm interested in F block, so Hiddle, Lena, Knows, Rubies, Cis, and France. Now just see, kids, if I write down the D block elements, potassium, calcium, science teacher, very crazy man, felt cold in night with cousin, felt cold in night with cousin. Just see, just focus over here, Now see, everyone, strontium, barium, radium. So this is 6th period and this is being 7th period. Now see, if I say here what elements, this, if I complete this one, scandium, actinum, and if I start from here, Tizo, Tezuri, half on roof. Now my dear student, just think about it. Lanthanum's atomic number is how much? 57 atomic number, and this is 72. How many elements are not given over here? Just think about how many elements difference is there. 57 to 72, just count 72 to 57. How many elements are there? How many elements gap is there in this area? How many elements gap is there? Do let me know how many elements gap. 14 elements gap is there. 14 elements gap, and here it is 89 and this is 104. How many elements gap is here at this place? Once again, 14 elements. So these 14 elements, I will say, after lanthanum, there are 14 elements, cerium to lutetium, 58 to 71, these 14 elements, and here after actinum, that is 89, 90 to 103, 14 elements, that is thorium to lawrencium. These are known as actinoids, and they are known as lanthanoids. No, sorry, it's reverse, it got reverse. It is known as lanthanoids. After lanthanum, lanthanoids, and after actinum, these are known as actinoids. Now I am going to reach to those elements. They are placed in the 2nd period. Remember that 2nd period, and here this is the 3rd B and that is 4th B. In between 3rd B and 4th B, there is a line, this line, these elements are placed. That's why they are known as inner transition element. Before I move towards them, let me tell you, these zinc, cadmium, mercury, these are being very soft, and you have seen that their electronic configuration was having fully filled configuration. They are not having unpaired electrons, and that's why they are not treated as transition elements, because they are very soft. You can cut with the help of knife. They are not having unpaired electron. That means they cannot do metallic bonding, and if they can't do metallic bonding, they are soft, right? Now let me reach to lanthanoid and actinoid. I have told you what actual position is of lanthanoid and actinoid. They were actually placed in between transition elements. Let me give you the picture, clear picture. Let me tell you, kids, the S block elements over here, the P block elements are over here. In between S and P block elements, these are D block elements. So D block elements are known as transition, because they lie in between these two transition. And here, if you have seen third B and fourth B, after just in between third B and fourth B, there were lanthanoid and actinoids. So F block elements are known as what? Inner transition elements. They are known as inner transition elements. Inner transition elements. This point is clear, visualization is clear, then only I am going to reach towards that inner. Why they are in between this transition, in between S and P, and they are inside this transition. That's why they are also known as inner transition elements. So let me reach to F block elements. What do you call these elements? Inner transition elements. What do you call it? Inner transition elements. All right, kids? Clear, kids? I cannot see you, kids. Only I can see your messages. They are going to give me energy. They are only going to give me energy. If anything is clear, then never forget to show me green hearts, fire in the chat section, because your green hearts and fire and green symbol, they are going to give energy to Baba, kids. Then only I will get energy. Kids, fast. Be fast. Now, F block elements. F block elements. So, what I am saying, F block elements will start from where? They will start from here. The first element is cerium, and the last element will be lutetium. Silu. Everyone says Silu. Hey Silu. 58 to 71. Silu. Now thors. Pa. Thorium. 90 to lawrencium. 103. Now how to remember these elements? Now see how to learn it. Hey, now see. Now see. Let's see. See. Let me write down the atomic number. 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71. Number of times they will ask you number of questions from here. Just see the trick. Just see the tricks. C. Prime Minister and PM. Prime Minister and PM are same. This is clear. C. Prime Minister and PM are same. C. Prime Minister and PM means same. C. Prime Minister and PM means same. This is going to your head. Uganda's things are on table. Uganda's things are on table. See, Prime Minister and PM are same. Uganda's things are on table. Deputy Home Minister will come tomorrow on YouTube from Lucknow. Kids, how much hard work Baba has done for you, kids? Do let me know. Is it clear? This trick is okay, kids? Is this trick okay, kids? Will you be able to learn it? Cerium, prosidium, nidium, promethium, samarium, europium, gadolinium, terbium, diprosium, holmium, iridium, terbium, ytterbium, lutetium. Fast, 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 kids. Will you be able to learn it? How is the trick? How are the slides? Everyone do let me know. Baba is not taking even a single. Sir, I need another trick to remember this. Oh my God. So it's bad. You can directly learn it. If you're not able to learn it, so you can directly go with this. Rani Epuri, Raisin, Lakshmi Gauri, Madhurima. Very good kids. Really awesome, really awesome. Now kids, what question will come in your exam? Movin Nazir, it's okay. Jyoti, thank you. Jyoti, thank you. Now see, kids, what type of questions will come in your exam? Wow, thank you, Vish. Thank you, kids. Your appreciation means a lot for Baba. Jyoti, thank you. Ankita, thank you. Nandini, Shivam, thank you. Thank you. Now see, kids, here also exceptions are present in the electronic configuration. Let me show it. My dear students, see God love you. See God love you. What is this? See God love you. See God love you. See God love you. God is one or two or three? God is one. Just God is one. This question has been asked number of times. God is one. God is one. So it is having D1. D1. Remember that. Lutetium will have D1. D1. D1 configuration. Now, what is the meaning of this D1? Remember that rest of all others elements, they are having D0. This is cerium is also having D1. Rest of all others, they are having D0. If I say it is having how much? It will have D0, D0. All rest of all other elements, they are having D0. Now, if you are able to remember this, they all are having D0. Then how to write down the configuration? That question will come in your examination, and that is the toughest question. That is going to be the toughest question. Now kids, if you remember the trick, you can answer easily. Just let me tell you, and before letting you know each and everything, one thing is clear. See God love you, or I will give you another trick. See this though, remembering trick, and see, this is for this one. Let me show you. See God love you. These are the three elements which are having D1 configuration. And let me show you, kids. Let me show you. So either you can remember that trick or you can remember this trick. Good cellulose. Which trick is better? See, God, gadolinium, D1 configuration. Cerium 1 or 0. In class 11th it is given D1, and class 12th it is given D0. So cerium in different NCERT, different it is given. So examiner, and lanthanum to we know it will have D1 only, so leave it. So only two elements from lanthanoid can be asked, either GD or LU. You have to remember these two elements, GD and LU, they are important. Will you be able to keep it in your brain? So if they are asking how to write down the electronic configuration of gadolinium, number of times this question has been asked. Are you getting my point? They have asked number of times this question, write down the electronic configuration of gadolinium. gadolinium's configuration you are supposed to write down. You know the atomic number is 64. How to find out the atomic number? Either the atomic number will be given or you are supposed to do this. See, Prime Minister and PM are same, and Uganda, see, 58, 59, 60, 61, 62, 63, 64. If you know this much, now see how to write down the electronic configuration. Gadolinium is 64, and we know very well that this thing, helium, neon, argon, krypton, xenon, radon, now this one is more than what? 64 is more than xenon. So can we take up to 54 xenon? Can we take up to 54 xenon? Can we take? And we know that from the periodic table, it belongs to first period, second period, third period, fourth period, fifth period. So its electronic configuration we know very well. It is being 5s2, 4d10 and 5p6 up to here. Sada Pav we have done. Now we are supposed to write down its configuration. So for 54 we can write down xenon. Xenon means it stands for 54. Now 54 to 64, how much is the difference? In between 54 and 64 the difference is of 10. So what I will write after xenon? So see, Sunday morning, sip, simple DP. Right now, what will come? Safe DP. Now it will come safe DP. Now S, F, D and P. S will be of what? Sixth period. After 5, 6 will come 6S, then 4F, then 5D, then 6P. This much is clear. Now 54. Now I filled, if I have to fill how many electrons in F? Because God is 1. I have told you, you have to remember God is 1. This was the exceptional configuration. So it is having D1. So here I will write down D1. Is it clear? I have filled D1. 6S2 is clear. Now out of 10, 2 and 1 I have filled. How much is left? 2 and 1 I have filled. 10 was the difference. 2 and 1 I have filled. 7 is left. So it will come out 7. So I have to put here 7. This is the configuration and you will get full marks, kids. You will get full marks. Do let me know you are able to understand or not. Everyone, are you able to understand it or not, kids? Yes, Hare Krishna. See, God love you. See, good luck. Whatever you write, you are able to understand or not, kids. Do let me know. Whatever I have told you, everyone is able to understand how to write down the electronic configuration. Wow, Veda, thank you. Everyone, just to let me know. It's how it is difficult. Baba is telling you each and everything, how it is difficult. Hare Krishna, thank you. Baba is telling you each and everything, how it is difficult. It's not difficult. Let me give you one more example. See, let me give you one more example. See, just wait. Let me give you one more example. You can select any element. Out of these, you can select any element. Suppose if we want to write lutetium, its atomic number is 71. Now see how to do it. Just see. Lutetium is 71. Now 71, how to write it down? You can follow two things. What are these two things? Either you can start from the very beginning. Just see, two ways are there. Sunday morning, sip, sip. Simple DP, then simple DP, then safe DP. Either you can do it like this. Now you will start from the very beginning, like 1s2, 2s2, 2p6, 3s2, 3p6, 3s2, 3p6, 4s2, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2. Now 6s2. Now lutetium, C God love you. Either we can say C God love you or C good luck. They all are having D1 configuration, D1. They all have D1. Rest of the elements, they are having 0 of lanthanoid. Rest of all elements, they are having D0. These three are having D1, right? Now, how much I have to fill in D? That 5D1. Now see, count 71. I have to make it 71. 2 to 4, 6, 10, to 12, 6, 18, 20, 30, 36, 38, 48, 54, 56, 56, 56. I have written 56. Is it okay, kids? Or something is missing? Is it okay or something is missing? Let me see. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6, 4p6, 5s2, 4d10, 5p6, 6s2. Okay. So 2 to 4 to 6, 10, 12, 6, 18, 20, 30, 36, 38, 48, 48 and 6, 54 to 56, 56. Now 71. 71, I have to reach up to 71. Up to here I have written 56, 56 and 57, 57, 57, and this is 71. 57, we have got how much? 57. If I subtract from this, how much I am getting? 4, and here I am getting 7 minus and 6 minus 4. So I will get here 14. Now you are able to understand? Got it or not? Just to let me know, got it or not? Let me check it out in the chat section. Everyone, first of all, do let me know you are able to understand or not, kids. First of all, after this I will give you a break, kids. First of all, do let me know everyone is able to understand. Yes, I am going to give you a break, but first of all, do let me know. Show me green symbol. Yeah, fully filled is more stable than half filled. Yeah, I will give you a break, but do let me know. Thank you, Vidhi. Thank you, Vidhi. Wow, very good, kids. Very good. And those who have not shown the thumbs up, smash the like button, kids. Yeah, right now it is 1941. 1941. So we will meet at 8:30. So it is okay? Should we meet at 8:30, kids? Should we meet at 8:30? That is better. Do let me know. Do let me know, kids. Should we meet at 8:30? It will be okay, kids. Thank you, kids. Thank you. Really, thanks. Just to let me know in the chat section. Just to let me know in the chat section. 8:30. Okay, okay. Have your lunch or dinner, what to say. The day is moving like this, so better to say dinner, but I have not even done my lunch, so I would like to do my lunch, kids. Okay, let's meet at 8:30. Okay, kids, come with positive energy. First, make a promise that you are going to come with positive energy. Have some snacks, don't eat too much, otherwise you will feel sleepy. Baba is not even going to do his dinner properly because I will take some salad and fruits. Okay, so remember that, don't eat too much, otherwise you will feel sleepy, right, kids? Okay, okay. Make a promise, you will come with positive energy. Make a promise, everyone, make a promise. Thank you, thank you, thank you, kids. Thank you, thank you. Kids, I'm back. Just to let me know, am I audible and visible to all of you? Can you hear me? Can you see me, everyone? I want to see in the chat section, I think, yeah, exactly, I'm in time. Or I can say on time. So kids, is everyone over here? Hey everyone, just to let me know. Monica is there, sharp 8:30, sir. Yes, Pradeep Kumar, Sausi, Sangeeta, Kiran, thank you kids. Everyone, really. Wow, that's really awesome that everyone, wow, kuch bhi. So everyone, you are active. Are you active, kids? I want to see that. Everyone active? No. Yes. Now, first of all, let me tell you some few things, and then I will go to Z effective. I will teach you Z effective, but my dear students, welcome everyone, welcome. So kids, keep your energy, actively participate, just remain cool and calm. I would like to say, my dear students, everyone, let's focus on our studies. Now just see, let me tell you these elements from the actinoids. First, let me tell you what are the actinoids, then I will tell you the elements which are having D1 configuration. Are you able to understand what I am going to tell you? First of all, let me tell you the trick for actinoids, and then I will let you know which elements are having exceptional configuration. Are you able to understand what I am telling you, kids? Now, here is the trick for actinoids. Here is the trick for actinoids. Somebody was asking, sir, in the examination whether they are going to give the atomic number or not. It's not necessary. That's their choice, whether they can give the atomic number. If they are not giving the atomic number, then this is going to be a problem. And that's why I'm telling you how to remember the element. The first element's atomic number is 90. And the last element's atomic number you can definitely find out. That is 103. If you remember the sequence, am I right or wrong? Am I right or wrong, kids? Do let me know. If they are not going to give the atomic number of these elements, then how to find out the atomic number? And that's why I'm telling you how to remember the elements. That's why I'm giving you the sequence. That's why only. Now see, Thor's PA has gone to Uranus, Neptune and Pluto. You know, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune and Pluto is not there, but it was there long back. So Thor's PA, you said right now you have seen some Thor or Thorns, whatever the movie, I don't remember, but Thor's PA has gone to Uranus, Neptune and Pluto. Thor's PA has gone to Uranus, Neptune and Pluto. This much is okay. Thor's PA has gone to Uranus, Neptune and Pluto. In the morning, in the AM, came back to California. In the AM, came back to California. This much is okay. Thor's PA has gone to Uranus, Neptune, Pluto. In the AM, came back to California. Are you getting it? Say along with me, then only you can understand. Thor's PA has gone to Uranus, Neptune, Pluto. In the AM, came back to California. And Einstein has become famous due to Mendel's noble law. Einstein has become famous due to Mendel's law, and their names are like this only. In the AM, americium, curium, berkelium, californium, einsteinium, fermium, mendelium, novelium, lawrencium. Is it okay? If yes, show me some green symbol, green hearts, whatever. Baba has made such a great slide. Thor's PA has gone to Uranus, Neptune, Pluto. In the AM, came back to California. Einstein has become famous due to Mendel's novel law. I want to see green hearts if you are able to understand. See, Thor's PA has gone to Uranus, Neptune and Pluto. In the AM, came back to California. Einstein has become famous due to Mendel's novel law, due to Mendel's novel law, due to Mendel's novel law. Now, which elements have got exceptional configuration, that is G1 configuration, I would like to say, that will help you, that is going to help you to find out the electronic configuration. See, TH, PA, U, NP, PU, AM, CM, these TH, PA, U, NP, not PU, CM, these are having D1 configuration, and Thor is having D2. I would like to say Thor is having D2 and rest are having D1, D1, D1 and D1. Now how to remember, I'm going to give you the trick to remember it. See, here is the trick, just see to it. Here is the trick, mind-blowing trick, see to it everyone. This was the trick for see God love you or see good look or good cellulose, whatever you want to see. And here, according to you, Napoleon is on similar path. See how much good is the trick. Similar, CMLR, similar path. Where is CM? CM. Similar, this is also there, similar, missing similar path, 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 according to you and Napoleon, on similar path. So 6 elements are there, those who got D1 configuration. This has got D1, 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 and I have told you this has got D2. Clear? 6 elements, 3 from here, 9, 6 and 3, 9, they all have got D1 configuration. Clear? There, see God love you or see good luck, and according to you, Napoleon is on similar path. Napoleon is on similar path. Will you be able to learn it? Everyone, now in this way you can write down the configuration. After this, I'm going to tell you one more thing which definitely come in your examination and they are going to ask it. See, the elements which are having atomic number more than 100, they are written according to IUPAC nomenclature. Now how to write down? Remember that for 0 you have to take nil. Say everyone nil, and nil is written with abbreviation N. 1 is un, u, small u. 2 by, 3 try, 4 quad, 5 pent, 6 hex, simple, 7 sept, 8 act, but 9 is N. Remember, 9 is N, E double N. Remember, E double N, N. So you have to remember 9 is N and 0 is nil. 0 is nil. These two you have to keep it in your brain. Rest are simple. Un, and this is nil, this is un. You can remember 1 is un, rest are simple. Un, 0 is nil, un, by, try, quad, pent, hex, hept, oct, N. This is to be noted, my lord. 9 is N. Now, if somebody is asking how to write down IUPAC name for 0, 101, 101, just to let me know, how will you write down for 101? Everyone do let me know. How will you write it down? Everyone, just think about how to become doctor or engineer. You have to think about that dream, kids. So 101, what you will write for 1? What you will write for 1? I have told you un. 0 is nil. Then 1, niyam, yum. You will write down em extra. Suppose if somebody is writing 103, what will you write? Nil, try, yum. Is it clear? Somebody wants to write down for 109. How will you write 109? Kids, do let me know. 1 is nil, yum. But the thing is not so simple. If they are giving you, write down the IUPAC nomenclature of Mendelevium, will you be able to write down? What's the problem is over there? If they are saying write down for Bohrium, what's the problem? Just to let me know what's the problem over here. Suppose if they are going to give the question, write down IUPAC for Mendelevium. Will you be able to write down? What problem you will feel in this question? What's the problem is there in this question? The problem is, the obstacle is, definitely the problem is, my dear students, we don't know the atomic number. We don't know the atomic number. Am I right? We don't know the atomic number. If we know the atomic number, we can write down its IUPAC. Otherwise, we cannot write down the IUPAC. This is a big problem, big challenge. Am I right, kids? Am I right? Am I making sense? So see how to remember and what type of questions they are going to give. Just see, kids. Can you see? Can you see the elements starting from 101 ending to 110? These elements name you have to learn. You're required to learn in the sequence. Can you see the elements? If you're not able to see the elements, just let me touch it and let's see what I can do for you, kids. Now, just to let me know, kids. Now, can you see, kids? Is it visible now? See, is it visible, kids? Is it visible? Just do let me know. Kids, do let me know now. Is it visible? Yes, I will give you the trick. I will give you the trick. Now is it visible? First of all, do let me know. Show me green symbol if it is visible. Now see. How many of you want the trick? If you need the trick, show me green symbol. I want to see green signal, kids. If you want to have the trick, kids, everyone just to let me know. If you want to have trick for it, now see. Mendel got Nobel law. Everyone say Mendel got Nobel law. Mendel got Nobel law. Write down Mendel got Nobel law. Mendel got Nobel law. Rutherford double setting. Because of Mendel got Nobel law, because Rutherford's double setting. Mendel got Nobel law because of Rutherford's double setting. Everyone say Mendel got Nobel law due to Rutherford's double setting. Now, Bohr has gone to market to buy dosa and rasgulla. Bohr has gone to market to buy dosa and rasgulla. They were friends. This is just story. It has nothing to do with anything, okay? Say, Mendel got Nobel law because of Bohr's double setting, and because of this Bohr has gone to market to buy dosa and rasgulla. How is it? Mendel got Nobel law due to Rutherford's double setting. Bohr has gone to market to buy dosa and rasgulla. Should I write down? What is the trick? Mendel got Nobel law because of Bohr's double setting. Now two scientists what completed? I have included two scientists, Mendel, Bohr. Now who is the third one? Bohr or Rutherford? Here will be Rutherford or Bohr. Now you have gone. Bohr or Rutherford? See, here it will be. Now you have not remember Rutherford's double setting, not Bohr's double setting. Now you will be in a problem if you are not able to understand. Here will be Bohr or Rutherford. If you are not applying brain, here it should not be Bohr. Here should be Rutherford. Now how to remember that here is Rutherford? How to remember that here is being Rutherford? Now MRB, remember that MRB, Bohr has gone to market. Bohr has gone to market to buy dosa and rasgulla. This is a trick. Will you be able to keep it in your brain, kids? Will you be able to keep it in your brain? MRB, Mendel got Nobel law because of Rutherford's double setting. Bohr has gone to market. Clear? Do let me know in the chat section. Is it clear? Is it clear, kids? I ate dosa. Oh yeah. Hero Brian. Is it clear, kids? Just to let me know. Mendel got Nobel law because of Rutherford's double setting. Bohr has gone to market to buy dosa and rasgulla. Now if they are asking the IUPAC name, now see, if they are asking any IUPAC name, suppose they have written, tell us the IUPAC name of Mendelium, or they are asking for Rutherfordium. Will you be able to write down the IUPAC name for Rutherfordium? See, Rutherfordium's atomic number you will find out 104. You can just find it out, 104. Now I have told you one is unilquadium. Unilquadium is clear. If they are asking for bohrium. So Mendel got Nobel law because of Rutherford's double setting. Bohr, so 101, 2, 3, 4, 5, 6, 7, 107. Unilseptium. Is it clear? This question has been asked twice in your NEET examination and 3 times in the IIT. 3 times in the IIT they have asked. No fear when Baba is here. Thank you, Sidhu. Thank you. Kids, everyone, just to let me know, everyone sing this song. Mendel got Nobel law. Mendel got Nobel law because Rutherford and double setting. Bohr has gone to market. Bohr has gone to market to buy dosa and rasgulla. Now, perfect. Thank you, kids. Thank you for your support. Thank you for your love and support. Now see, this question has been asked. Let me show you the question. This question has been asked in IIT JEE. Let me show you that question. Where the question has gone. Just wait for a second. I will show you that question. Question, where are you? Hey, question, where are you? Yeah. See, the IUPAC nomenclature of an element with oh my God, see. Such a tough question. See and answer it. I'm sitting over here. Let me see in the chat section who is going to answer this question. My God. Now how to find it out? I don't know. Very tough question. Let me see. Is there anyone who is going to answer it? Is there anyone? Wow, Settingham. Is there anyone? And kids, hit the like button, smash the like button. This, I want your love and support, everyone. Smash it. Who is going to answer this question? Let me see, kids. D. Everyone is going for D. How you got it? How you got it, kids? First of all, do let me know how you got the answer. How you are able to track it. How you have done it, kids. You are right, but how you have done it? How you have done it? Sim. Yes. Uniltrium. 1-0. But how you got it? First of all, do let me know. 1-0-3. How you got it? Uniltrium. How you got it? How you got it? Hey. Wow. Rocking, everyone rocking. Now kids, let me come to the Z effective. This is going to play the major role. This is going to play major role. How many of you really want to understand Z effective? How many of you really want to understand the Z effective? Baba is going to teach you Z effective. Same. Z effective. Baba is going to tell you Z effective. The rules I will tell you later on about Z effective. First, I will teach you what is the meaning of Z effective. These slides are really awesome slides, kids. But now, see, Baba is going to first of all going to give you the feel of Z effective, and then I will give you questions and number of things. First of all, let me give you the feel of Z effective. Okay, kids. Now see, kids, Z effective. What is the meaning of Z effective? If you are able to understand Z effective, then you can understand ionization energy, electron affinity, the whole predictive. That means Z effective holds a hell lot of weightage. Now what is the meaning of Z effective? Let's see. If I say, here is the nucleus. Here is the nucleus of atom. Who lives inside the nucleus? Do let me know. Who lives inside the nucleus? Proton and neutron. Protons are having positive charge, and these protons are responsible for handling electrons. Suppose if I say first orbit, the second orbit, the third orbit, the fourth orbit or third orbit. So if I say in the first orbit there are two electrons. In the second orbit there are 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And if I say in this orbit there are 1, 2 and 3 electrons. So definitely I would like to say 2, 8, 3. This is aluminium. 13 atomic number, this is aluminium. Are you able to understand? Now we know that very well. This is the king and these are queens, Rani and Raja. Raja Rani, they love each other. Raja ko Rani se pyar ho gaya. Pyar ho gaya. Ta ta ta. Oh. You are mine, you are mine, you are mine. Raja is saying you are mine. Ta ta ta. You are mine, you are mine. But as the force going to the last electron, that is going to get decreased. Why it is getting decreased, kids? Why it is getting decreased? The whole force is not able to reach up to all these electrons because kids, the rest of the electrons, they are creating repulsion. The positive and negative charge, I would like to say, they are having force of attraction, FOA, force of attraction. But negative and negative, they are having what type of repulsion or attraction? Definitely these are having force of repulsion. FOR means force of repulsion. Repulsion. Rani and Rani are repelling each other, and Raja and Rani, they are attracting. Attraction, repulsion, attraction, repulsion. And this Raja is trying its best to apply force on the outermost Rani. Suppose if I say this is Champa Rani. Champa Rani. Let us consider this to be the Champa Rani. Which color? Let me make with this color, Champa Rani. This is Champa Rani. Now just to find out how much love of this king is for Champa Rani, how much love of this king is for that Champa Rani, we are going to calculate, and that will be known as Z effective. You got the scene? There are number of other Ranis. These are Ranis. If I'm taking electrons to be Ranis, all electrons right now I'm considering to be Ranis, and these Ranis are applying force of repulsion with each other, and Raja is going to, this king is going to love all the Ranis, but intervening, these Ranis, they are cancelling out the force of Raja, this king, and that electron, the force, how much it's getting out cancelled, that is known as shielding. And whatever the force, actual force is going over there, that is Z effective. Suppose if I say there would have not been even a single electron, then the whole force would have been experienced by that Rani. But this intervening electrons, they are cancelling out some force. Are you able to understand? You are able to understand. Suppose if I say I am the king, and number of queens are there, in between that public is there. So if I am going to throw my whatever the sand or whatever the thing, others will catch it. These are acting as shield. Or let me give you another example. Suppose I am teaching you, directly you can see me. I am the shield in between your eyes and this figure. Just see, if I stand like this, so in between you and this concept, whatever is written on the board, this is acting as shield. Now if I am going away like this and my hand is coming, this is a little bit shield. If I am coming like this, more shielding in between you and the concept. Now if I am coming like this, if I show this bag also, like now more shield. Now if bring my copy like this, now more shield. Now see, in between you and the outermost electron, shield is increasing or not? Shield is increasing or not? Now if I am doing like this, more shield, so you are not able to see the concept. There is Champa, this concept is Champa. See Champa, in between. Now you can see Champa clearly, Champa. There is no one in between you and Champa. Right now you are the king and Champa, this electron. But I'm coming. Ting, ting, ting. My hand is coming. Screen is coming. Ting, ting, ting. Now I have come. Ooh. Now the biggest screen in between you and the Champa. So I'm acting as shield, screen. So you won't be able to see. Now see the screen, more electrons. These are the in between electrons. They will not allow you to see. I hope that you are able to understand. Let me see in the chat. You are able to understand. You are able to understand or not? Just to let me know. So these intervening electrons will act as screen. They are acting as screen in between you and Champa. So these electrons, and this is known as test electron. This Champa electron is known as test electron. Now let me draw another diagram. This will be known as test electron, to whom the one electron on which we are going to find out the force, and the rest of electrons, they will act as shield, and they will put screening effect. They will act as screen or shield in between the outermost electron and the nucleus. Gets clear? This point is clear. Now they will try to neutralize some effect. Let me write down over here. Suppose if I say once again, this is the nucleus, this is the nucleus, positive nucleus. Suppose protons number is 13 protons. So definitely neutral one, they will have 13 electrons, like 2 electrons over here, 8 electrons over here, and 3 electrons over here. Out of 3 electrons, 2 electrons I will take like this, and I want to calculate the force of attraction, jet effective on that electron. So this electron, Champa electron, or whatever the electron, I will say this is test electron, and rest of all electrons will be behaving as a screen. They will be acting as screen or the shield, or they will cancel out the force of attraction which is going to reach on Champa. This I have considered to be the force of attraction on Champa, and they are cutting it. They are cancelling out a little bit of force. They are cancelling out like this. Let me say how they are cancelling out. They will definitely cancel out. They will not allow the whole force to reach up to Champa. They will allow. So the screen, and whatever the value of this is coming, that is known as screening constant. Whatever the value of this is coming is known as screening constant. I would like to say screening constant. That is also known as shielding constant. And people will denote it with either with S or with sigma. So if I say these electrons would not be present, if they were not actually there, then the whole force must be applied to this electron, and the whole effective nuclear charge will be equal to the atomic number if there is no electron. If there is simply one electron, then the whole nucleus charge will be experienced by that electron, but they are cancelling out some force. Let me tell you in another way. If you are not able to understand, let me tell you in another way. Just don't worry. Those who are not actually able to understand, if I say this is sun, you know, sun is the ultimate source of energy. In place of proton, I have taken sun, and Champa is standing over here. This is the electron. Champa is the electron. Okay. Again and again I am drawing Champa. Champa is the electron. Now if I say direct sunlight is coming on Champa, then there is no screen in between the sun and the Champa. This is the nucleus, and this is the outermost electron on which we are going to talk about the test electron about which we are talking about. This is the test electron, my dear students. But if I say there is one tree, if there is one tree, then definitely this tree will act as shade, screen. If I say more trees in between sun and Champa, so they are acting as what? Definitely they are going to act as screen. The whole sunlight will not fall on Champa's screen and they will give screening constant. Some value will come out, and the value will come out that will decrease this charge or the sun's sunlight. So I will say Z is equal to Z effective, that is effective nuclear charge is equal to atomic number and minus as something I have to subtract. Are you getting my point? This thing I have to subtract, this amount what the trees are cancelling out, the trees are cancelling out the force, the sunlight's energy cancelling out, which is supposed to fall on Champa. If these trees would not be present, then the whole sunlight will be experienced by the Champa. So this thing I have to subtract, or I can say Z effective can be shown as Z minus sigma. This is screening constant. Till now, before finding out, before I let you know that what's the value of sigma, this concept is clear. First of all, show me green hearts if concept is clear. What actually I'm telling you, what is screening effect or shielding effect? If that point is clear, then only Baba will tell you how to find out the values. If the concept clarity is there, show me green hearts. Everyone, show me green hearts. Then only I will tell you how to calculate the value of sigma. Everyone, fast, fast, fast. Don't delay. Very good kids. Now see, everyone see. Now Baba is going to tell you how to calculate the values, how to calculate. Now, if I ask you one thing, that this is the king proton and this is the nearest orbit, the Rani which is nearest to the king, and this is 8 Ranis, and these Ranis over here 1, 2, and this is the test electron. I would like to say this is the test electron. Who are responsible for cancelling out the force? Definitely this is responsible, this is responsible, these are responsible. Even these are responsible. If I say there are number of more electrons on the right hand side, they will not account for anything. Why they are not going to account for anything? See, if I say the trees are here and there is one more tree. If I say here one more tree, do you think this tree, these trees, suppose this is coconut tree, these trees are going to affect the sunlight in between sun energy and Champa? Because they are not in between this. Suppose if I say that if I bring this bag in between you and this concept, then it is acting as screen. And if anything which is behind this board, is that going to affect? Suppose if I say that if I put this copy behind the board, do you think that is going to act as screen? If I put this copy over here inside it or there or just behind this board, that is going to act as screen. Behind the board, whatever the thing is lying behind the board, that will not act as a screen. Whatever is in between this and you, that now right now it is acting screen. And see, if I bring closer to you, then it will affect more, its effect will be more, it will not allow to see you the board. See, if it is here, then it is just occupying. This is near to the test electron, it is applying less effect. But if I bring near to the nucleus, its effect will be keep on increasing. See, nothing will be visible. Just see, nothing will be visible. It will be like this. Are you getting my point? If it is going away, less effect, coming near to, its effect will be more predominant. Are you getting my point? That's why the electrons which are present in between this positive charge and electron, their contribution will not be same. Their force of repulsion will not be same. Their contribution will be different. Am I right? Their contribution will have different value. Different values will be there. Different contribution will be there. Different contribution for sigma, that is latest constant. Now, the second point is that how these electrons are acting, because you must be thinking that it is going straight. How these electrons will also put some repulsion. How these electrons are also responsible. You will talk like that. Now let me tell you, sometimes these electrons their path will be like this. They will go from here, and some other time these electrons will go from that side. If they are going from that side, no contribution. But if they are going from this side, so these electrons path will lie in between this positive charge and this champa, so their contribution will be there. That means these two electrons contribution which are in the same orbit, their contribution will decrease, because sometimes they are moving from the right hand side and sometimes they are moving from the left hand side. So this will not be counted. This will not be counted because that is on the right hand side. So the right hand side will not be counted, but yes, the one which is on left hand side will be counted. This will be counted. So these in the same orbit, nth orbit, they are putting very less value, very less value, and they will have more value, and rest of will have maximum value. They will put maximum value. Am I right or wrong? Then only I will tell you what values they are going to give. Till now this much is able to understand. If yes, show me green hearts. I want to see that. Gets what Baba is telling you. Hey everyone, do let me know you are able to understand what I am talking about, why the values will be different. I have shown you the experimental thing. Kids, I'm far away from you, you are far away from me, but if you're writing, if you're showing green hearts or whatever the things, then we can understand each and everything. Sometimes distance can speak more than the words, kids. Everyone, fantastic. Nalla iruku, that's really awesome. That kids, once you are able to understand the things, always never forget to show me the green hearts. Yes, kids, that's so awesome. Fantastic. Now see, the values I have told you that. Now what I am going to tell you, kids, just see. Forget about this DNF. Right now, forget about DNF. Focus on S or P. I am HSP. Rest. Focus now S on P. In the same orbit, their contribution is 0.35. In n-1 orbit, their contribution is 0.85. And rest of all other orbits, their contribution is 1. The electrons, other than test electrons, each electron will contribute 0.35 force of repulsion, n-1 0.85, then rest of other electrons 1. I will show you during the calculation. I will tell you each and everything. I will explain, but how to remember the values. The electrons which I have selected as the test electron, the champa electron, other than that electron, rest of all other electrons in the same orbit, nth orbit, they will contribute 0.35. n minus 1 at 0.85, rest of all 1. Now how to learn these values? You learn it and again you are going to forget it. How many of you want trick? Whenever I say how many of you want trick, show me green hearts. I will get it from here that you need tricks. How to find out the value of sigma, the screening constant, Slater's rule. If you want trick, then always show me the green hearts. Baba will understand that you are in need of trick. Hey kids, everyone. See, if I say A, B, C, D, do you know A, B, C, D? A, B, C, D, E, F, G, H. Now from today, whenever you feel any doubt, if you're not able to remember this, Baba is going to give you the best trick. Baba's trick. Who is Baba? Baba HSP. Your HSP Baba. Now see, for 1 you will write A, you will write 1, 2, 3, 4, 5, 6, 7, 8. Right? Now, if I say 0.35, once I am saying 0.35, what you will write? 0.35 in place of 0.35. 3, 0 point C, and 5 is E. She. I'm not saying she, I'm saying C. C, and he. If I want to write, this is 0.35. C. And one is C and another one is he. 0.85, 0.8 is H and E. He and she, the story of he and she. How is the trick? He and she, just see he and she. This is C and this is he. She and he is one. There is no gender problem. She, according to God, she and he is one. When we want to become doctor, no problem of gender, no problem if you want to become engineer. She and he is one. Will you be able to remember it? These values you learnt, D and F, I will tell you later on. For D and F, I will tell you later on, but for this, let's calculate. Let's calculate. Are you ready? Are you ready? If you remember this, if you can remember this, now let me show you the example. Just see. Okay, tell me any element. I will tell you how to find out. Suppose we want to calculate for neon. What is the atomic number of neon? 10. So I will write this is the nucleus. 10 proton in the first orbit. How many electrons are there? First, second, third, 2, 8, 2, 8, 10. Oh, simply 2, 8, 10. So out of 10, out of this 8, I will take 1 as the test electron. So how many are left? 2, 7 and 1. 1 I have selected as the test electron. This is Champa electron, test electron, right? So other than this, how many electrons are left? 7. So I will calculate. I am trying to find out Z effective. Z effective is equal to atomic number minus sigma, that is screening constant. So how to find out sigma? In the same orbit there are 7 electrons left. So I will multiply 7 into 0.35 plus how many electrons in the inner one? There are 2 into 0.85. 2 into 0.85, how much it will come out? 2 into 0.85. Tell me how much the sum is going to come out, kids. Do let me know. It will come out. So 7, 5 सत्ते 35, 5 and 3 and 7 21 24. So 2.45 plus 0.85, that means 70, 1.70. This is coming out this and that. So how much is the sum will come out? So 2.45 1.70, the sum will come out 5 such are 11, 1 2 1 3 4, 4.15. So I will write down over here that atomic number is 10 minus 4.15. How much it will come out? 10 minus 4, definitely it is going to come 6. So it is 1.15, sorry, it's 0.15. I have written wrongly, 0.15. It is 0.15. So if I subtract, it's 10 minus 4, 6, but it is more than that. So 5.85. This is the Z effective of neon. You are able to understand? Or should I tell you some more examples? Then I am going to give you a question. Let me explain with more examples. Should I, kids? First of all, do let me know how many of you are able to understand the first example. How many of you are able to understand the first example? Then I will give you more examples. Tell me in the chat section, any element you give me, then I will tell you. Any element you give me, I will tell you. I will let you know more elements. Just tell me any element. Let's take helium, neon. Let's take which element you want to take. Tell me. Helium, neon, argon. Let's take argon. Hey, let's take argon. What is the atomic number of argon? Argon, you remember that. Helium, neon, argon. So atomic number was 18. Now see, it's 18. For making it 18, how many orbits will be required? 1, 2, 3. So I would like to say the first orbit is containing 2 electrons. The second orbit is containing 8 electrons. And this is containing 7 electrons plus 1 electron. Why I have separated out this 1 electron? This is the test electron. Let's say this is the Champa, which I have told you, which I have explained. So she is being Champa electron, the test electron, excluding it. Rest of the electrons, they are 7. So I will multiply these 7 electrons with what value, kids? Just to let me know. Everyone just to let me know. Baba is asking, I am supposed to multiply this 7 into 0.35 C plus these 8 electrons. I will multiply into 0.85, and then rest of the 2 electrons I will multiply when 1. Now my maths is not good. Everyone just do let me know what value I am going to get. 2 into 1. 2 into 1 is coming out 2, and this is the plus sign. 8 into 0.85. 2 to 64 4. 8.6.8, 6.8, and 7 into 0.35. Right now we have done calculated it to 7 into 0.35 is 2.45. So 2.45. Now add all these values. 6.8, so 8.8, 8.8 and plus 2.45. What value I am going to get? 505. अच्छा 12 carry 1 8 2 10 और 11.25. Now what formula I have told you, my dear students? Z effective is equal to atomic number minus screening constant. My dear students, Z atomic number is how much? 18, and 18 minus, I'm supposed to subtract 11.25. If I have subtracted 18 minus 12, I would have got 6, but this is extra value 6.75. So my answer is going to come out 6.75. Just check it out for the calculation. I've done the correct calculation or not. My calculation is absolutely correct or not. Just to let me know, my dear students. Oh, you have already calculated. You are better than me. Baba took time, but you are better than Baba, kids. Hey everyone, you are faster than Baba. You are faster than Baba, kids. My God, Romba Sulbham, Ayya. Oh, Mubina Nazir is unable to understand. Kids, rest of others are able to understand, not everyone. Sir, explain once again. Okay. Just let me take another example. Don't worry. Let me take another example. Let's take what? Which element? Just give me any element. Let's take magnesium. Okay? Should I take magnesium? Now let me tell you slowly. Magnesium atomic number is 12. So this is the nucleus. Nucleus will have how many protons? 12 protons. Let me write down the first orbit, the second orbit, and the third orbit. In the first orbit, how many electrons should I fill? 2 electrons. Second orbit, 8 electrons. And the third orbit, 1 electron plus 1 electron, because 1 is test electron. Leave the rest one. This is test electron. So how much force it is getting, we are supposed to calculate. These are acting as screen. In between this nucleus, and that electron, these electrons are acting as screen. They are acting as screen. So they will put a screening constant. They will repel. They will apply force of repulsion, and this is applying force of attraction. Force of attraction. Now see, other than this electron, how many electrons are left? Other than this electron, how many electrons are left? 1. So what I'm supposed to do? 1 electron multiply with 0.35. I have done that. Now 8 electrons, 8 into 0.85 plus 2 into 1. This is the value of sigma. This is the value of sigma, that is Slater's constant. I can say shielding constant. I can say screening constant. Whatever you want to say, you can say, kids. All they mean same. Now just add what the value says. 2 plus 6.8 plus 0.35. How much it is coming out? 6.8, 7.8, 8.8, 8.8 and 0.35. 8.8 plus 0.35. How much the sum will come out? 5, 8, 3, 11, 8, 9.15. Now what I'm supposed to do? Z effective will come out is equal to atomic number minus 9.15. How much the value will come out? That's 10, 2.85 will be the answer. Am I right, kids? How many of you got it now? Kids, how many of you got it? Just to let me know how many of you got it. Kids, if you're really liking my efforts. Sahana. Hey, Sahana, where were you? Sahana, where were you? Where were you, Sahana? The most dedicated student, the most regular student. Sausi, Sahana, Kiran, Jyoti, number of students are here. Jyoti, really. Now, Janvi is saying 8.5 and 3. No, it's 0.85 and 0.35. Kids, okay, let me tell you once again. It's not 8.5, it's 0. Kids, very bad. It's not 8.5. Let me tell you, if any electron is present, see, let me tell you, any electron, let's take, let me take which element? Tell me which elements. So let me take helium, neon, argon, krypton, xenon, fluorine, chlorine, bromine. Should I take bromine? Should I take bromine? Now should I take bromine? Its atomic number is 35. 35, okay? 35. Now see. Nucleus, proton, 35. Z is 35. Am I right? This is the nucleus. How many orbits I will take? 1, 2, 3, 4. I will require 4 orbits. 1, 2, 3, 4. Now how to write down the electronic configuration? I have told you. Sunday morning, sip, sip. Do you remember? Sip, sip. Then simple DP. Do you remember? Simple DP. Do you remember, kids? Now How to fill the electrons? 2, 2, 2, 1s2, 2s2, 2p, 2p6, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. Now how much? 2, 2, 4, 6, 10, 12, 6, 18, 2, 20, 30 and 36. So here it will be 35. Am I right? 35. So I got 35 means 5 only, 5. Now this is nth orbit. Now listen, this is the last time I am telling you. This is nth orbit. Nth means where the test electron is present. This electron could be taken, this one, any electron he can ask. Test electron here. This is n minus 1th and this is the rest of other electrons, right? Nth, n minus 1th. This is outermost shell, penultimate shell and rest of the other shells. This is clear. Now other than one electron, how many total electrons are there? 2, 10, 2, 12 and 5, 17. So 16 I will consider because one electron is the test electron. Other than that there are 16 electrons. Am I right? So this is the nth orbit. I will multiply 16 with what? 16 multiply by 0.35, not 3.5, 0.35 plus n minus 1th, 6 to 8, 8 into 0.85, now plus 6 to 8 to 10, 10 into 1. This is going to come out sigma. Now how much sigma is going to come? Calculate. Whose maths is good? Calculate what value of sigma we are going to get. I don't know how to calculate. You help me. 16 32 16 16 16 16 85 8 16 32 48 48 and 8 56 5.60 plus 8 64 40 6.8 plus 10 10 6.8 16.8 16.8 16.8 0 plus 5.60. It is coming out 0 8 14 4 हासिल लगा 1 1 6 दूनी 12 के 2 हासिल लगा 1 22.40. Am I right? 22.40 22.40. So I'm going to put over here Z effective is equal to Z minus latest constant. Z is 35 and minus is coming out 22.40. 22.40. How much it will come out, kids? How much it will come out? So 35.00 and 22.40. 10 में से 0 0, 10 में से 4 गया 6 और यहाँ 4 4 में से 2 गया 2 और यहाँ 3 में से 2. कुछ गड़बड़ हो गया क्या? Something is wrong, kids. I have done somewhere wrong. Anything? Have I done something wrong, kids? 35, 22. Have I done any mistake, kids? Have I done some mistake? Just see. Tell me, have I done some calculation mistake? Have I done some calculation mistake, kids? I think I must have done. Yeah, I have done. See what calculation mistake I have done. See, calculation. This is 4. 3D will come over here. 3D will come over here. Just see. The mistake I have done is 3D will not come in 4th orbit. 3rd orbit should come in this one. Na? This is the mistake done by me. Kids, are you getting my point? This will come, this 3D will come over here. This is the mistake done by me, kids. Just see. This 3rd orbit will come in 3 only, right? This 3rd orbit will come over here, 3D10. 3D10. This is the mistake point to remember, my dear students. 3rd orbit, 3rd orbit, 3rd orbit, I have added to the 4th orbit. Now, how I realized my mistake? Should I tell you? Should I tell you how I realized my mistake? How many of you want that? How I realized my mistake? Remember that never ever the Z effective will be more than 8.25. 8.25 is the maximum Z effective. And what value was coming? It was coming something more than 10. Z effective, maximum Z effective is 8.25. 8.25 is maximum one. Now see, let me calculate once again. They are not 16. How many electrons are there? Just see. So 4s2 and 4p5, 5 to 7. This is test electron. Out of 7, how many electrons are left? 6 electrons are left, because this one is test electron. So 6 into 0.35 plus 10 plus 6, 18, 20, right? 20? No, 10 plus 6, 16 to 18. 18 into 0.85 plus 6 for 10 into 1. How much it will come out, kids? It will come out 10 into 1, 10. 10 plus 0.85, 18. So tell me it will come out 18, so 18 into 0.85, kids. Yes, how much it will come out, kids? 18 into 0.85. 18 into 0.85. How much it will come out, kids? Calculate and do let me know. Everyone, do let me know. Kids, do let me know. Everyone, how much this value is coming out? 18 into 0.85. Let me see in the chat section. 15.3. Brain is not braining. Oh, 15.3. 15.3. 15.3. Okay, 15.3. Really it is coming out 15.3. Just to let me know, kids. So we could have done, if you're not able to understand, we could have done 18 into 0.85. Let me check it out. 45, 4, 5, 5, 9, 8, 8, 64, 4, 6, 8, 8, 6, 14. So 0, 9, 4, 13, 3, हासिल लगी 1, 5, 15.30. 15.30 it is coming. It is coming 15.30. Very good. It's coming 15.30. 15.30. 15.30. Now this is coming 6, 5, 30, 3, 6, 18, 19, 20, 21, 2.10. How the sum? How much is the sum coming out? 10, 15, 10, 25.30. 25.30 plus 2.10, 0.31457 and 27.40. I am getting 27.40. Am I right or wrong? 27.40. Let me know in the chat section. 27.40. 27.40. Very good. 27.40. Wow, 27.40. Now how to calculate Z effective? How to calculate the Z effective? So it will come out, Z effective will come out to Z minus screening constant. Z is 35. 35 minus 27.40. Kids, how much answer is coming out? 35, 28, 7.60, 7.60. 27, 28, 28, 7.60 is the answer, kids. Do let me know. How many of you got it? Very good. Now let me show you the whole periodic table. If you got it, kids, your calculation is very good. Salute, and thank you for helping me. Thank you for helping Baba. Kids, your calculation is very good, and thank you for helping Baba. Now see. Just see, this I made for you. See, right now we have calculated for bromine 7.60. Earlier we calculated for argon 6.75, neon 5.85. We have calculated for krypton 8.25. I have told you no element in the whole periodic table can have more than 8.25. See, this is the maximum value, 8.25. No element can have Z effective. Right now we have calculated for bromine 7.60. Now why I am showing you this periodic table, just see, and then I will tell you the tricks also. First of all, do let me know how is this. Baba made it. Baba has done lot of hard work. How is this? First see to it, everyone, and then I will let you know. Just see to it first. Everyone, yeah, you can take a screenshot of it. It's yours. Sir, one doubt for D. I will tell you, till now I haven't explained D1. Dr. Siddharth, till now I haven't explained D1. I will let you know. But first of all, let me know how much you're liking it, so that you are not going to get full information anywhere. Baba is the only one who is going to give you the full knowledge. Kids, Jyoti Jan, thank you. Lakshmi, thank you. Dikshit, thank you. Thank you, Jyoti. Duration, don't ask for duration. I will try to complete it. Just Baba, one doubt. Yes, you are good. Thank you. Now, yes, PDF I will send to you. Definitely I will give you. I will share it too. Thank you. Now, yes, I will tell you. Just wait. First, let's see to it. Now see, kids. First of all, see. If I say lithium is 1.3, after lithium, all the elements, they are having Baba. What is Baba? AC Baba. A means A, 1 point C. Baba 2.2, 2.2, 2.2, 2.2, 2.2. First it increased and then it's becoming constant. Here it is, first it increased and then it's constant. Just see. In the periodic table, wherever in the books you see, they write it increases on moving from left to right and decreases down. It's not getting decreased. See. Little bit decrease then constant. Little bit decrease then constant. Little bit decrease then constant. See, 8.25, 8.25, 8.25. This is constant. 555, this is constant. But yes, from left to right it is increasing. See, 1.3, 1.95. Now should I give you the trick? The trick is just magic number, add 0.65. Here it is written, the trick, 0.65. See, 1.30, 0.65, 1.95, add 0.65, 2.60, add 0.65, 3.25, keep on adding 0.65, no need to calculate. Now why 0.65 is being added? You see, every test electron is increasing and that is going to put repulsion of 0.35. One atomic number is increasing. For each addition of increase in atomic number, if you move from left to right, atomic number will increase. For each increase of one atomic number, one electron will also increase, and that will go to the nth orbit. And how much Slater's constant it is going to give? 0.35. So 1 minus 0.35 will come out 0.65. So keep on adding 0.65 you'll get. Now, Z effective increases on moving from left to right, and on going down the group it first decreases and then remain constant. So what I'm going to write kids about Z effective? I will write about Z effective. What thing I will write kids? Do let me know what I will write about Z effective. Baba will write about Z effective, the thing that on moving from left to right, on moving from left to right, on moving from left to right, left to right, Z effective increases. Z effective increases. Where kids? Where? On moving from left to right in the periodic table. Left to right in the periodic table. And if you go down the group, first decreases and then remains constant. Decreases a bit and then remains constant. Remains constant. Will you able to run? On moving from left to right it increases, continuously it increases, and going down the group generally remains constant, and here it increases. My dear students, will you be able to keep it in brain? Now let me show you the rules. Those who were having doubts, let me show you kids. Slater's rule to know screening constant. Number 1 rule, step number 1. Electronic configuration must be written in the following order: 1s, 2s, 2p, 3s, 3p, 3d separate, 4s, 4p, 4d. 4f in this way means D will remain separate. Grouping should be done, because now whenever the tough question is going to be asked, they will ask for D, and I will tell you how to find out for D. Till now we were finding out for S and P, but D will have different things. So remember that grouping. My name is HSP. HSP. S and P will remain together. See, SP, 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 SP. But D and F, they are separate groups. D and F like duffers. HSP is like Supreme. Supreme have group. Duffers, they remain separate. Will you be able to remember this? D and F will not be the part of any group. Kids, show me the green hearts if you are able to understand. D and F will not be the part of any group. Downward increase हो रहा है. I have told you it will downward decreases, increases. Yes, downward increases. Yes, you are right. One has written little bit increase, and then remains constant. You are right. Little bit increases, little bit increases, and then remain constant. Thank you. You are right. Little bit increases and then remains constant, right? The one who has written, it's correct. Little bit increases and then remains constant. And see, the grouping is clear. First of all, the grouping is clear. Now, for S and P electron, electron in any group to the right of the NS or NP group contribute nothing to the shielding constant. This I have explained. Now I'm giving you the notes. Already explained. All the electrons in the NS-NP group shields the electron to an extent of 0.35, except for the 1s orbit, for which the value is 0.3. If there is only 2 electrons in first orbit, if there are only 2 electrons or 1 electron means no Slater's constant will be there. If there are 2 electrons, then one will act as test electron, another one just shield 0.3. Rest of others were shielding 0.35 in the nth orbit. but 1s orbit, if there are only 2 electrons, its value will be just 0.3. All electrons in n-1s shall shield to an extent of 0.85 each, like pointer he, pointer he. This is the trick, pointer he. For DNF, this is for DNF. If I come to this, let me drink some water, and if you're ready for DNF, show me some green signal that you are ready for DNF, then I will explain. Then I will explain for DNF. Are you ready to understand for DNF? Is everyone ready? Sahana is saying yes, Sahana is ready. Now see, kids, everyone is ready. Now see. For DNF, there are only 2 things. One is 0.35 value, another one is 1. There is no he. There is no he. 0.85 is not there. See? Only 2 values. All in the ND or NF shield the value electron to the extent of 0.35. Rest of others will contribute 1. Now should I explain with the help of example? Should I explain with the help of example? Just see. If anyone is going to ask, find out, there are 2 questions. Question number 1, find out Z effective for iron. Find out Z effective for iron. A is 4s electron and B is 3d electron. Now to find out 4s, what I am supposed to do? I will write nucleus, proton, first orbit, second orbit, third orbit, fourth orbit. I know very well that this is containing 1s2, 2s2, 2p6, 3s2, 3p6, 3d6 and 4s2. So 4s1 and 1 is test electron, right? So I am going to solve this question. First I will solve this question. Now, right now I am supposed to calculate for S. The rule will apply for S1. So test electron and 1 is left. So I will multiply with 0.5. 1 electron will 0.5, right? So 1 into 0.4S1, 0.35. This is n minus 1, 6, 6, 12 and 2. 14 into 0.85, right? Plus 6, 2, 4, 10, 10 into 1. This is the value of sigma. How much sigma is coming out, kids? 10 plus 14, 14, 14, 14, 14 value 14, 14, 15, 70 का 7, 14, 14, 14, yes, tell me 14, 14, 14, 14, value 14, 56, 14, 75, 14, 84, 14, 97, 98, 14, 112, 112, 112 and 14, 14, value 14, 56, 14, 70, 70, 7, 119, 119, 119. So kids, how much it is coming? It is coming out how much? 11.9? 11.9? It is coming out 11.9, kids. Do let me know how much it is coming. Hey kids, how much the value is coming? Do let me know how much the value is coming, kids. Hey, not the full value. I'm not asking the full value, kids. I'm not asking the full value, kids. Do let me know. It is coming out 11.9. Yes, 11.9. So it is coming out 11.9. It is coming out 11.9. And this one is coming out to 0.35. If you add it, how much it's coming out? 10.00, 11.90, 0.35. So it is coming out 0.5. So 5, not in 12, carry 1, 2, 12.25. So its atomic number was 26. So first of all, let me calculate. Z effective is coming out atomic number minus screening constant 26 minus 12.25. Something we have done wrong, kids. Somewhere we have done something wrong, kids. Where we have done something wrong, kids. Some calculation mistake or somewhere we have done something wrong. Kids, we have done some mistake. Once see, 2, 2, 4, 6, 10, 2, 12, 6, 18, 24, so 26 is correct. 0.35, 0.85, 14, thus. Oh, see here is the mistake, kids. This is the big mistake. So 5, 9, 3, 12, 1, 2, so 22.25, 22.25, so 22.25, how much it will come out, kids? 26 minus 22.25, 23, 3.75, am I right? So its answer is coming 3.75. This is clear, kids? Do let me know in the chat section. This is clear? This is clear, kids? Is this clear, kids? 3.75, 3.75, yes. Now let me tell you the another one. This one, how to calculate this one. Just see this one, 3D electron. Now see, for 3D electron in iron, whose atomic number Z is 26. Let's see. Once again, I will say this is the nucleus, proton, the first orbit, the second orbit, or let me write down like this grouping. I told you the grouping 1s2, 2s2, 2p6, 3s2, 3p6. Now 3D, this is separate. 3D, 6 out of 6, I will take 5 plus 1. 1 is the test electron. So they are groups, kids. They are groups. This is one group, this is another group, this is another group, and this is the last group. Now see, if you want to calculate for D, so whatever that electrons, 5 into 0.35, and now rest of other multiply by 1. So 5 into 0.35, this, and rest of electrons you are supposed to multiply by 1. Now see, 2 to 4, 6, 10 to 12, and 18. 18 into 1. How much it will come out? So 18 plus, this is 25, 5, 2, 15, 17, 1.75, 1.75, am I right? So this will come out, Z effective will come out, how much, gets 19.75, and it was 26 minus 19.75. How much it will come out, kids? 20, that means 6.25. Am I right? 6.25. This is right or wrong? Just to let me know, kids. 6.25. Is it correct? Yes, is it correct, kids? 19.75 out. After that, 6.25. Yes. This time Baba has done it fast. Baba has done it fast. Now kids, after right now no break kids, let's do questions. Now for single electron entity, see, all these are isoelectronic species. Isoelectronic, do you know, they all are having one electron. Now there is no middle Rani, no Slater's constant, no screen. The whole force will be experienced by only one Rani. For single electron entities like hydrogen, helium plus, Na10 plus, magnesium L plus, screening constant will be 0. So Z effective will be equal to Z. Z effective is equal to Z minus screening constant, that is 0. So Z effective. Now, are you ready for doing questions, everyone? We will do number of questions on Z effective. Are you ready? Show me green hearts along with fire. Everyone, show me some fire along with. Then I will start giving questions. Kids, everyone, show me some fire along with green hearts. Baba is going to start some questions, giving you questions, my dear students. Hey, everyone, I want to see some fire along with green hearts. Everyone, kids, everyone. Now, what's the answer of this question? First of all, do let me know. The question is written in a better way. Everyone, so answer this question. Screening effect is not observed in D. Yeah, correct. Answer is absolutely correct. Absolutely correct. Now let me show you the answer. Let me show you the answer of that question. Here is the answer. All of these. You are right. Absolutely correct. You are absolutely correct. Now, another question. Calculate Z effective for electron in 4s subshell of iron. Oh my God, this though we have calculated right now. You can answer it immediately. This though we have calculated right now. Right now we have calculated it, kids. Right now we have done it, kids. We have done it right now, kids. What's the answer of this question? See, let's see to it. Yeah, where is the answer? 3.75. Same. Here is the answer, kids. Baba has explained it, and see, brilliant way I have explained. See, kids, do you think that anyone is going to give you such a great handwritten slides? Great handwritten slides, kids. Just see. These slides are really looking very good or not? Very good slides or not, kids? Can you see the efforts made by Baba? Now, another question. Calculate Z effective in 3D subshell of iron. Oh my God, even this one I have explained. Even this one Baba has explained. Sahana, thank you. Now this one, even this one I have explained. See to it. Everyone just see to it. Jyoti, thank you. Killer Science. Now, what's the answer of this question? This one I have explained. Now, this one already we have done. So 6.25 is the answer. C. Yes, C. Now another question. Oh, here is another question. See, another question. Another question, kids. This is another question. Just see to it. Just see to it. Yes, Baba is waiting for your answer. Screening effective of D electron is screening effect of D electron is Yes. Less than p electrons. Yes, you are right. Absolutely correct. Absolutely correct. Absolutely. Damn good. Now another electron. Formula of Z effective. Formula of Z effective. Formula of Z effective. Just seek it and do let me know. Formula of Z effective. What answer? It's very simple. This is the simplest one. This is the simplest one. You can easily do it. So, right, all right, all right, all right. Now, this one, this one, this one. What is the answer of this question, kids? Formula of effective nuclear charge. This is also simple one. This is also simple one. Now, according to Slater's rule, Z effective in group generally. Generally, this is tricky question. This is tricky question. Generally, they are asking generally. Yes, remains constant. Oh, answer is not written. Remains constant. So in group, what should be the answer? In groups generally, according to Slater's rule, Z effective in group generally remains constant. We will go for D. So generally remains constant. D is the correct answer. D is the correct answer. Now another question. In sodium screening is due to. Sodium screening is due to. What answer you will go for? In sodium screening is due to. I would like to see the answer. In sodium screening is due to. So generally it was remaining constant. So D is the best option. D was the best option. In sodium screening is due to. The question is in sodium screening is due to. So sodium's atomic number is how much? You should remember that sodium's atomic number is what? Then only you can do that. So 1s2 2s2 2p1 or 1s2 2s2 2p6. D. Yes, my dear students. Why this is the answer? D is being the answer because sodium's atomic number is 11. So 11 we will say sodium is 11. So the first orbit 1s2 2s2 2p6 and there is 3s1. This is the test electron and these are acting for force of repulsion. This is correct. Absolutely correct. Now, element having maximum number of low shielding electron. Very good question. Very good. Awesome question. Let me check it out in the on the screen who is going to give the correct answer. Who is really replying, kids? That we are able to find it out. Who's taking participation? Whose participation is there, my dear friends? Who's really taking part? That's element having maximum number of low shielding, which are not giving good shield. Good shield, those who are not giving good shield. Whose shielding is poor, kids? Whose shielding is very poor? That is the question. Now remember that shielding, poor shielding. So the answer is this one. So how this one is the answer? Let me tell you, kids. Let me tell you. If I talk about, if this is S, if S subshell is like this, if S subshell is like this, then P subshell is like this, then D subshell is like this, and then F subshell is like this. Now this is G, this is P, I would like to say this is P, and this is being S. So if I say these are the clothes, S, P, D, F, and there is winter, there is being winter, which cloth is going to protect you? Best protection will be done by which cloth? S. Then the shielding of S is better than P, D is poor, and F is very, very poor. If I say you want to put a screen to protect yourself from the sun rays, if you want to get protected from heat, sun rays, then what type of curtain you will put at the window or at the door? This is very good curtain. This is not that good, but these two are poorest. So they have very, very poor shielding effect. Very, very poor shielding effect. Remember that their shielding effect is like duffer, just like name. They are DNF. Their shielding is also like duffer. They are not able to protect. Suppose if I say that if I put my fingers like this, they are able to act as good shield or bad shield? Bad shield. Now this will act as good shield because it's like this, but this will not act as good shield. Are you getting my point, everyone? So D and F are highly diffused, highly diffused, highly diffused. So they are poor shielding effect. If this concept is clear, kids, show me green signal. Show me green signal if this one is clear, that shielding, because this will help you to understand lengthenoid contraction, actinoid contraction. If this point is clear, I want to see the green hearts, green symbol, along with some fire in the chat section. Then only, kids, everyone, show me some green hearts. Everyone. Kids. Yes. Okay. So this is clear. Wow, this is clear. You are very good, kids. Very good, kids. No more. My God, one more question. See, according to Slater's rule, order of Z effective for the last electron in case of lithium, sodium, potassium. I think you will easily answer it. You will easily you are going to kill it. It's going to be easy kill question. It's going to be easy kill, kids. This is going to be easy kill question. I want to see the answer. Just 5-minute break. Okay, I will give you break. Let me complete these questions. Then I will give you break. I have to complete the syllabus. I can't see up to what time class will go on, but yeah, definitely it is going to take too much time. Third question, Mehendo. Now C. Ruby is giving C. Even everyone can give the answer that lithium, sodium. Lithium was no, not the D. Kids, AC Baba. Do you remember AC Baba? AC Baba. What was that? Lithium was having AC 1.3 and Baba, this is Baba. AC Baba means 2.2. So it was increased from lithium to sodium, and then it has become constant. So lithium to sodium increased, and then I will go for C option. Best option is looking C1. Yeah, C is the correct answer. Everyone able to understand? I've shown you. Let me show you. Let me show you once again. Just see. First of all, see this. In a period, Z effective increases mostly. Top to bottom remains constant generally. This is the nice line I have written over there. This is the best line. Now see what question Baba has given. Just see what question Baba has given. Let me explain it. So lithium 1.3, then 2.2. That increase and then remaining constant. So generally it is remaining constant, but lithium to sodium, it has been increased. Got it? It has been increased. Now question. Now what on this trick? 2.2 Baba 2.30. So it has represent abrupt values, not uniformity is here. This you see in the D for D electrons, there is no uniformity is there, abrupt values are there. So don't apply here that 0.61 don't apply. Now which statement is false? Tell me in the chat section which statement is false. Number of questions Baba has given you, kids. Nijat Majid is writing lithium is having more than, oh my God, one kid is asking that how lithium is having more. See, Nijat, lithium is having less. See, lithium is having less, then they are having more. Okay, let me come back to the question. Let's see any doubt is there in that question. See, this was the C answer. Lithium is having less than sodium and potassium. It was 1.3 and they were having 2.2. So this is correct. Right or not? Lithium 1.3. So more than lithium is sodium and potassium. This option is correct or not? First of all, do let me know. How this is wrong? This is absolutely correct. Absolutely correct. Lithium is just 1.3. They are having 2.2, 2.2. So they are having more than that of lithium. Agreed? Who has asked this question? This is absolutely correct. Absolutely correct. So, what answer you have written for this question? What answer? B. Everyone. Okay, you got it. Night. Nigat Mazid. Okay, thank you. Nigat, thank you. You got it. Very good. Well done. Now, let's see where answer is right. B. Very good. Z effective increases down there. Which statement is false? Yeah, this is false. I was thinking about which is true. They are asking for the false statement. Absolutely correct. Now see. Oh, now see kids. Z effective is directly. Now agreed or not? For this you are agreed or not? More the positive charge. If more is the positive charge, that means atomic number is constant but electrons are less. More positive charge means what? Means less electrons for repulsion. Less electron for repulsion. What do you mean by this? If I say earlier I was acting between you and the screen, we all were acting as screen. These are the electrons. Now if I subtract electron, I have removed this bag. Now the electrons removed. Now I have removed this also. Now can you see more clarity of the screen is available? Now even I have gone, my hand is there. So one by one everyone is getting removed. So more force of attraction, more visibility will be there. So the nucleus, the electron, the protons which are present inside the nucleus, they will pull more. The Raja will be able to apply more force of attraction on the outermost Rani, because in between Ranis got decreased. So jet effective will be more. Now if more and more electrons are coming in the orbit, so this nucleus will not be able to apply the full force on the outermost electron. So repulsion will increase. Here, let me tell you, here the force of attraction increased and the force of repulsion decreased in the positive one. But in the negative one, if I say about the negative one, that force of repulsion increased and force of attraction decreased, and that's why jet effective is directly proportional to positive and inversely proportional to negative. Now jet effective for different ions of an element, positive will have maximum Z effective than neutral and the negative one. This point is clear. I hope that this point is very much clear. Now Z effective for isoelectronic entities. What do you mean by isoelectronic entities? Those entities which are having same number of electrons. If same number of electrons are there, who will have maximum Z effective? Definitely the one having positive charge. More the positive charge, more will be Z effective, because less will be the intervening electrons. The intermediate electrons will be less. So see, hydrogen, lithium, positive, beryllium. Oh my God, how to get it? 2 electrons, 2 electrons, 2 electrons, 2 electrons. They all are having same electrons, but Z effective will be maximum for this because its Z atomic number is maximum. Now see, negative, say positive. More the positive charge, more will be Z effective. Z effective was directly proportional to positive charge and inversely proportional to the negative charge. More the positive charge, more will be the Z effective. All they are having same number of what? Electrons. They all are having 10 electrons, but its atomic number is maximum. Means the force of the nucleus is maximum, that it will pull. Electron, come. So Z effective will increase. Kids, are you getting my point? First of all, I want to see your reaction, whether you are able to understand or not. Hey, my God, I am applying my best effort, but kids need a little break. Ankita, you are there. Okay. I will give you a break at 22:30, just after 10 minutes. After 10 minutes, I will give you one break. Let me complete this effective nuclear charge, kids. Kids, after 10 minutes, Baba will give you break. Definitely, I will give you break after 10 minutes. Everyone, kids, first of all, do let me know. If I'm not teaching good, tell me, Baba, you're not teaching good. If I'm really teaching good, my slides are really good, then please do let me know. Whatever is there, do let me know. Clear, I want transparent your feedback. My slides, my homework. See who is going to give you handwritten slide. Have you ever seen? South Sea, thank you. Explain isoelectronic entities. Okay. Thank you, Dharun Raj. How long? Don't ask me that how long this is going to take. Baba is trying his best efforts just to... Yes. Now seek it. See. What do you mean by isoelectronic entities? Now let me tell you. See. If I say that I am having sodium 11 atomic number, that means there are total electrons 281. Now if I say that I am having Na plus, that means it has lost one electron and right now it is 28. So how many electrons Na plus is having? Na plus is having total 10 electrons, because one Rani has gone somewhere. Sodium was having 11 Ranis. These electrons are like 11 Ranis. And sodium plus has donated one Rani to anyone else. Now it is having 10 Ranis. Now if I say, just see, isoelectronic entities. Let me enclose it in a box. Now if I say I am having chlorine. Don't take chlorine. Let's take oxygen. Oxygen's atomic number is 826. Oxygen was having 8 Ranis. But oxygen has taken 2 Ranis more. Gained 2 more Ranis. Now oxygen has converted to O2 negative. Now it will be 282. Total 10 Ranis. 10 Ranis. Now if I talk about magnesium, one more electron, let's say magnesium. Magnesium's atomic number is 12. So it was like 282. 12 Ranis, it has donated 2 Ranis, so it has become Mg2 plus. So right now it is having 10 Ranis. So if I say, if I account for sodium plus, if I ask sodium plus, Mg2 plus and O2 negative, how many electrons they are having? Each they are having how many electrons? Just see, it is having 10 electrons. It is having 10 electrons and it is also having 10 electrons. They all are having 10 electrons. So same number of electrons means iso means same. Isoelectronic entities, that means same number of electrons. Gets clear? Isoelectronic, is it clear? Is it clear? Clear to each and everyone? Isoelectronic kits. Now okay, now after the break Baba will tell you this one, amphoteric oxides. Baba will let you know amphoteric oxides, right? Just after the short break. Let's keep a short break, everyone. Sir, mistake in O2. Let me check it out. O2. Why O2 mistake is there? Let me check it out. How? O is 8. Atomic number is 8. 2, 6 taken 2 electrons. So will become 2, 8 Oh, mistake. Yeah. It's not 2 is not there, right? Thank you. You kids are really awesome. Thank you. Really thank you. So 2, 6, gain 2. So 2, 8 it will become. So 10 electrons. Everything is okay. That 2 was extra. Thank you. Really thank you, kids. You are really genius, kids. Really genius. Now, right now it is 22.24. So let's meet at 11, kids. Boss is writing, sir, 3S, 3P, 3D. Yeah, this is very good question, kids. Boss is writing one question. Let me answer that. Boss is writing that, sir, 3S, 3P, 3D, they are belong to the same orbit, same shell, right? Then why you have separated them? This is very good question. When I was teaching in my starting days, even this question I have asked to my seniors. The same question I asked to my seniors. Remember that if you want to calculate for 4s, 4p, these ones, if you are taking test electron from here, then you can consider them to be the same shell. But remember that if anyone is going to say that take test electron from D and then find out Z effective, then the rule will get separated. For D calculation, you have to make a group. So group will come like 3s, 3p together, and they will put D in different category because D is filled after 4s. 4s, after 4s, 3D is filled. 3D is in 3D, but it is getting filled after 4s. So this is a little bit different. So once they are asking to calculate for D, then the grouping should be done, and that should be treated as different group. This will be treated as different group, my dear friends. It will be treated as different group, and they are one group. Boss, is it clear? If they are asking to calculate test electron from 4s, 4p, then they are same shell. But if the test electron is this one, then they will be treated as different group. You got it? I think, boss. Is it clear? Just do let me know, boss. Is it clear? How many concepts are left? Let me tell you, kids, before giving you a break. Let me tell you, kids. After this, I will tell you amphoteric oxides. Amphoteric oxides I will teach. Amphoteric. I have to cover this amphoteric. Then I will tell you size, covalent radii, metal radii, everyone radii. Then I will tell you ionization energy. Then I will tell you electron affinity. After that I will tell you electronegativity, and after that I will let you know the, what to say, a very important thing is there, that Born-Haber cycle I will tell you. Then according to that Hess law I will tell you, and then I will tell you lattice energy, and then hydration energy. This much, and this is the order in which I am going to tell you, kids. This somebody asked for that how much is left. This much is left, and this holds a hell lot of weightage along with the questions, kids. Okay, let me tell you one thing, kids. If you are tired, then you can take sound sleep. Don't worry, I will not say stay. I never want, Baba is never in need of views. Baba is never thinking of more viewers. Let me tell you one thing. If you're tired, you can take sound sleep. But Baba will complete each and everything, because I will not get another chance to complete it, kids. Baba will complete it, and Baba will try to tell you each and everything. Baba is not going to cut short, not going to give you cut short thing. Baba will explain each and everything, kids. And definitely, I'm telling you one thing, if you're not having that much of energy, better to take sound sleep, kids. Don't worry. Even if there are 100 students, 50 students, 200 students, 300 students, even one student, Baba will teach. Am I right or wrong? I want to see in the comment chat section. Am I right or wrong, kids? Because Baba will not get time. Kids, we have to take break, otherwise we won't be able to re-energize, to get recharge. Kids, without recharge we won't be able to understand anything. So to get recharge, yeah, have you ever seen, kids, have you ever seen that any teacher, while the teacher is teaching on YouTube and he's saying, kids, if you're not feeling energetic, go and take a sound sleep. Take a sound sleep. Have you ever seen any teachers talking like this? No teacher will say. But kids, for me, you kids are more important than anything else. Baba will think about you first. Then Baba will think about himself. You are more important for Baba, kids. Okay? Let's meet at 11. Okay, kids? Thank you. Kids, this is for you. This is for you. This is for you. This is for you. Okay, let's meet at 11, kids. So break. Let's meet at 11. Come with full on energy. That's why break is there. Even Baba will get re-energized. Okay? Full energy. Come with full energy, kids. Namaskaram. Once again, welcome back, my dear students. Baba is in time. So, how was the break? Once we are going to take the break, kids, really, we feel once again energetic that it's look like just we are going to start this session. This is a very good thing about the break, that all the breaks, they are giving us that great energy that it's looking like that, yes, once again we got the same energy level. Hey, my dear students, lovely students, really, I salute to your hard work. This hard work I have never seen anywhere, kids. Really, I want to tell you this thing that I've never seen such a great hard work. I'm teaching offline. Number of students I have seen just for 1 hour, 1.5 hours, 2 hours, they are getting bored or they're getting tired, feeling anxiety level high. But you kids, you are telling me this Baba is always thinking himself to be having the great energy level. Baba's energy level is over here. But when I see you people, I have taken one marathon which has been started with, means at 5 p.m. and up to 6:30 or 5 a.m. I don't know that what time it got ended, but you were present all the time actively, I would like to say. Now, my dear friends, I think everyone has come. Now, let's start with full on Josh, full on energy. Are you ready? I want to see that Josh in the chat section. Everyone, जिंदा है तो जिंदा दिखने चाहिए. If we are with full on energy, we should look like that. I want to see the fire in the chat section. And we have to study with full on Josh, not like, hey, what I am doing. Just think that you are going to get your aim, that goal. Whether you are preparing for IIT or for NEET, Baba is giving that content that is equally good for both the IIT as well as NEET, kids. Baba is not going to get compromised, not giving means a bit of, what to say, bad content, poor content. No, Baba is giving you full 100%, 100 karat gold content, kids. Wow, that I can see. Wow, that's really great. Now let's start. Let's it go. Now, after completing Z effective, let's see the new topic, amphoteric oxide. If you see questions of IIT, if you see questions of NEET, whatever the questions, they will definitely based on this. Now see, amphoteric oxide, if you are able to understand the amphoteric oxides, just more the oxidation state than amphoteric oxide, they will become acidic, and less the oxidation state with compared to the amphoteric oxide, they will become basic. The boundary line, we can say on the boundary line, whatever the element oxides are there, they are amphoteric. So let's try to find out amphoteric oxide, then everything will get sorted. Now, Ashurya auntie Cariminati. Where is Ashurya auntie? Ashurya auntie Cariminati. Everyone, just say along with me. Ashurya auntie Cariminati. Ashurya auntie Cariminati. Everyone just say Ashurya auntie Cariminati. But remember the oxidation state. Ashurya +3, auntie +3, Cari +3, up to Ashurya auntie Cari is +3, Minati is going to be +4 and 4. Focus on the oxidation state. These oxidation state oxides are only amphoteric. If I say As2O3 is amphoteric, I would like to say AS2O3 is amphoteric. AS2O3 is amphoteric. Sb2O3 is amphoteric. I'm not saying AS2O5 is amphoteric. Cr2O3 is amphoteric. MnO2 is amphoteric. TeO2 is amphoteric. Are you getting my point, everyone? Ashore anti-Cariminati got irony victory. Ashore anti-Cariminati got fever, or irony victory, or you can say fever. Gets made fever. Which one is better? Fever. Now 3, 3, 3, 4, 4, 3 and 5. So 1, 2, 3, 3. 4 elements with 3 oxidation state, but vanadium is with 5. That V2O5 is amphoteric. So 1, 2, 3, 4, 5, 6, 7. These 6 are clear. Fe2O3. Fe2O3 is also amphoteric. Once these are clear, now I will come to the lower one. But everyone just repeat. Ashore anti-Cariminati got fever. Which one is better? Irony victory or fever? Which one should I repeat? Ashore anti-Cariminati got fever or irony victory? What should I say, kids? Wow, great. Wow, this is what? Hey, everyone, just do let me know. Baba is just asking to you, kids. Everyone, along with me, you have to say wherever you are present, kids. If you're not with full on energy, you can't do anything in this world. Ashore anti-Cariminati got fever because they have applied Jungle's best son is Prabhu. Jungle's best son is Prabhu. 1, 2, 3, 4, 5, 6. 1 aranda monunale anchiare 1, 2, 3, 4, 5, 6. Now all the oxidation state. These elements, all the oxidation states are amphoteric. Whatever. If I say Sanu O2, PbO2, all they are having, yes, amphoteric nature. Are you getting my point? These 6. Jungle's best son is Prabhu. Not able to understand. You're not getting it. Not getting it. You're not getting. Ashore anti-Cariminati got fever there. This particular oxidation states, they are amphoteric. But these 6 elements, any oxidation state, they are going to be amphoteric. If I say Al2O3, definitely Al2O3, BeO, all they are going to be amphoteric. Gallium, zinc, ZnO, all they are. Now you got it how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. These elements, oxides are basic. Now if anyone is going to ask one question, that if As2O3 is being amphoteric, this is going to be amphoteric. Now kids, do let me know what should be the nature of Sb, or let me take As2O5. This will be basic or acidic. Do let me know if you are able to understand. Let me tell you one thing. As the oxidation state increases, remember that what Baba is telling you, as the oxidation state increases, acidic character also increases. Acidic nature increases. My dear students, acidic nature increases. Now, on the behalf of this thing, Baba is asking one question. What should be the nature of arsenic pentaoxide? Now, do let me know in the chat section. Acidic, yes, it is going to be acidic. It is going to be acidic because here the arsenic's Ashore's oxidation state is +5. So it will be definitely acidic. My dear students, really, you are perfect. Now, if I say Jungle's best son is Prabhu, jangles was sinus prabhu. That means if I'm saying all the oxidation state, but if I talk about here chromium or manganese, let's take manganese plus 4 is amphoteric. Now let me ask, if manganese, they are giving you MnO, Mn2O3, they are writing MnO2, and they are writing Mn2O7. Now they are asking what is the nature of these oxides. So what you're supposed to do, kids, find out oxidation state. X minus 2 is equal to 0, so X will come out plus 2. So manganese is in plus 2 oxidation state. What is the nature? Tell me what is the nature. Basic, sir, basic. Mn2O3. Now I will ask Mn2O3 what you will say about the Mn2O3. I want to know, my dear friends, Mn2O3. Mn2O3 you will say 2x. Here it's written 2 Mn2, so 2x. And you know that one oxygen is always in need of 2 electrons. One oxygen is always in need of 2 electrons. So now 3 into minus 2, and no compound is not having any charge, so 0. So 2x minus 6 is equal to 0. So 2x is equal to 6. So x is equal to 3. So 3, this is also basic. This is also basic. That is also basic. Now this is plus 4. So definitely this is being amphoteric, right? And this is being 2x minus 14 is equal to 0. So 2x is equal to 14. So x is equal to coming out 7. So this is being acidic. I hope that it's done and dusted. Easy peasy lemon squeezy. I want to see in the chat section, everyone got it or not, just to let me know. First of all, I want to see in the chat section, this is clear to each and everyone. Are you able to understand or not? Bill Lorani, what is this? Everyone, just to let me know. Everyone, is it clear to each and everyone or not? I want to see in the chat section. If yes, I want to see the green signal. Green hearts, green leaves, whatever you can show. Just show me that. Everyone. Wow, that's so nice of you, so nice of you. Now kids, let me tell you, those who are unable to understand, Kushiga, Jyoti Jain, Kushiga, okay, Jyoti Jain, Kushiga, okay, fine, fantastic. Now see kids. So let me show you something more, that if I talk about acidic oxides, those who are unable to understand, acidic oxides, metal oxides, metalloids oxides, and non-metal oxide, just see, then we will solve questions based on this. See, metal oxide with oxidation state 5, 6 and 7, they are acidic, means higher oxidation state. Elements with higher oxidation state, they are going to be acidic. Everyone, are you able to understand what I am telling you? Kids, do let me know. Are you getting an idea about it? What I am telling you? Higher oxidation state metal oxides, they are going to be 5, 6, 7, they are going to be acidic. 5 oxidation state, 6 oxidation state, 7 oxidation state, they are going to be acidic. Okay. Now remember, one element was there, one metal was there who was amphoteric. If you remember vanadium, just see over here, vanadium was having oxidation state of plus 5. So this was amphoteric, but it is likely to be more on the acidic side. It is amphoteric as well as having some tendency of, yes, acidic oxide. Now let's come back. So metals with plus 5, plus 6, plus 7 oxidation state, they are going to be acidic. Now metalloids, you know, metalloid, arsenic, antimony, these are the metalloids. How will you remember metalloids, kids? Now how will you remember? How will you remember the metalloids? The elements which are having properties of metal as well as non-metals are known as metalloids. Ashurya anti, G cete, G cete. Remember Ashurya anti, G cete, or Will you be able to remember it? Ashurya anti GC. Now As2O5 Sp2O5, because arsenic oxide plus 3 oxidation state was amphoteric. So metal oxides other than amphoteric, all metal oxides other than amphoteric, they will be treated as acidic oxide. Non-metal oxides, these are acidic oxides with higher oxidation state. But remember, there are 3 metal oxides which are neither acidic nor amphoteric nor basic. Just remember 3. Cono laughing gas. I will show you cono laughing gas. Remember these. Cono laughing gas, because neutral oxide have no acidic or basic properties. CONO, N2O, these are neutral oxide. Will you be able to learn it? Will you be able to keep it in your brain? CONO laughing gas. Cono, oh no, cono laughing gas. These are neutral oxides. Neither reacts with acids nor react with base. Remember my point. Mark my words, kids. Now see, this is NCERT. See, kids. CONO and N2O are neutral. See, this point is written neutral. Just see over here. And show by a chemical reaction with water, these are like this. So I have zoomed it. See, neutral oxide. See how much efforts I made, how much efforts Baba has made. See, amphoteric oxides behave as acidic with base and basic with acids, whereas neutral oxide have no acidic or basic properties. Will you say that Baba has done lot of hard work? Everyone, will you say that really Baba has done? Thank you, Monica, Priyadarshini. Kids, will you really say that Baba has done lot of hard work for you, kids? Yes? Yes. Now, let's move ahead. Let's move here. Metals. Basic oxide, lower oxidation state, basic oxides. Now, amphoteric oxide we know very well, and 5, 6, 7 acidic oxide. Higher oxidation state acidic, middle amphoteric, lower basic. Now, basic oxide chart, amphoteric oxide charts, acidic oxide, neutral oxide. Everything at one single place. I have given everything at one single place. You can take a screenshot of it, and whenever I'm going to ask questions, you can easily answer those questions. So this is the basic chart for each and everything at one place. Now see left hand side, Na2O, MgO, LTO, from left hand side to right hand side, acidic character is increasing. Now remember that for oxides of same element, acidic strength is directly proportional to number of atoms of what? Oxygen, number of central atom and number of atoms of oxygen. Just see what is this? Number of atoms of oxygen atoms should be written over here. So definitely, simply it means as the number of oxygen atoms increasing, oxidation state will increase. This is having +2, this is having 2, 3, 6, so +3, and this is having +4. As the oxidation state is increasing, definitely if any element is attached with more number of oxygens, then definitely its oxidation state is going to be more, and it is going to be more acidic. Now see, so in the given molecules total number, see, this is a question of IIT. Answer it. I want to see your answer. Good question. Expected for top 100 rank. This is a question of IIT. I want to see. Sagar Mitra, Baba, your explanation is best. Thank you, Baba. Thank you. Really, thanks, kids. I want to know the answer of this question. Who is going to answer it, kids? Yes, everyone. Wow, Anusha. One guns. Anusha, thank you. Kiran A. Hashni, thank you. Now let me see who is going to give the correct answer. Monica Priyadarshini. Now kids, now let's see. If Baba is going to give the answer, what is going to be the answer? If Baba would have been at your place, just see, Baba knows very well that which oxides are neutral. Neutral oxide, CO is neutral, CO is neutral, and which one is neutral? CO is neutral, N2O is neutral, and okay, these many are neutral. Now how many are amphoteric? They have asked amphoteric. Let's see the amphoteric one. Amphoteric, V2O5 is amphoteric, AS2O3 is amphoteric, Al2O3 is amphoteric, Cr2O3 is amphoteric, and ZNO is amphoteric, and I don't know. Lead is amphoteric and beryllium is amphoteric. So how many are amphoteric? 1, 2, 3, 4, 5, 6, 7. Rest are acidic, so leave them. So 7 is going to be the correct answer. Baba is going for 7. Let's see what is the correct answer. Baba has gone for 7, and 7 is found to be the correct answer. Now, the options. See, I have told you, I have taken questions from J 2017 Advanced. This question is taken from Advanced J. Now see to it. The options with only amphoteric oxide is R. Already this question has been asked in IITJ in 2017. Let's see who is going to give the correct answer. Who is going to give the correct answer for this question, kids? Let's see. I'm waiting for your answer. I'm waiting for your answer. Thank you, Sai Pravalika. Thank you. Now I'm going. Yes, Baba is asking for the answer, kids. Everyone, D. Everyone is going for D. Let's see whether D is the correct answer. Computer G. Oh no, galat jawab. Now see why this is the correct answer. See the first one. This is basic. Cr2O3 is amphoteric. If this is amphoteric, so it is +3 oxidation state. So this is going to be what? +2. +2 is going to be basic. So this can't be the answer. Can't be the answer. Now NO is neutral gas. This can't be the answer. This can't be the answer. Now see ZNO, L2O3, PbO and PbO2 ZNO. Yeah, this is the answer. Aluminium. Yeah, this is the answer. Cr2O3. This is also the answer. The options with only amphoteric oxide. ZNO, right? Jungle's best son is Prabhu. This is also the correct answer. You are right, kids. Both are correct answer. Yes. Jungle's best son is Prabhu. Both are correct. Kids, you are right. Both the options are being correct. But if we are going to ask for one question, one answer, then Jungle's best son is Prabhu. No, we cannot differentiate. Both are the correct answer, kids. Both of them are being correct. Absolutely. C and D. C and D both are correct. Both of them are correct, kids. Great job. Congratulations. Now, the amphoteric. This is J mains 2019. J mains 2019. Try to answer this question. Let's see who is going to give the correct answer. Who will give the correct answer? South C, yes, is R. Two options are correct. Actually, this was IIT question, so both are correct. B, yes, correct answer, kids. Now, can you find out that you can do any question? You can do any question. B is the correct answer. Now, do you think that these questions are tough or easy? Now, the questions have become tough or easy? Definitely easy. Definitely your answer will be that now they are easy kill questions. Now, let me tell you oxyacids. Oxyacids. What are oxyacids? This. left to right, if you move, the oxidation state is increasing. So left to right, acidic strength will increase, and going down, the acidic strength will decrease, right? Or going up, acidic strength will increase. So see here, HClO4, the chlorine's oxidation state is +7, sulfur is +6, phosphorus is definitely 3 +3. As the oxidation state is increasing, acidic strength is increasing. Now see kids, oxyacid of same central atom, acidic strength is directly proportional to number of oxygen atoms, or you can say this thing, we can say that oxidation state is directly proportional to what? Directly proportional to oxidation state. That means only oxidation state. More the number of oxygen atoms, more will be the oxidation state. Now see, HClO, we will say this is 1 plus x and -2. So x will come out how much? +1, here +3, here +5, here +7. As the oxidation state is increasing, acidic strength is increasing. Here also you see this question is very tough question, kids. See this, here the oxidation state is how much? +3. Here it is how much? 2 दूनी 4 3. No, it's not +3, it is +1. Here it is +3, and here it is +5. But then also it is more acidic. Should I tell you, here it's written exception and resonance. Should I explain? How many of you want to have the explanation for this? Here more the oxidation state, more acidic strength. Here less the oxidation state, more is acidic strength. How many of you want to understand these two are, there is ambiguity? You will see here that as the oxidation state was increasing, acidic strength kept on increasing, +3, +5, +7. So the acidic strength is increasing. But here as the oxidation state is decreasing, the acidic strength is increasing. How many of you want to know the reason? Just write down in the chat section. Now see, let me explain. Let me explain it. First, HClO, Cl double bond O, double bond O, double bond O, and O negative. Negative charge one is the patient. You take because he is suffering. He is the patient, and these are the doctors. How many doctors, kids? Doctor, pi bond is doctor, and doctor. They will do resonance. They will do resonance. So negative charge will come to all four. And if charge is distributed, that means it is doing resonance. That means, my dear student, the charge will get divided among 4 on this, the fifth atom. So it will come 1/4, 1/4, 1/4 will get divided, and divided means decrease. The charge got decreased. Charge got decreased. More the number of resonating structures. So this is more stable. If I draw another one, just see, if I draw another one, this was the condition of HClO4 that I have drawn. Once it has lost H plus, it is like that. Now suppose if I say there is HClO, so I will say Cl double bond O, O negative. One patient, one doctor. One patient, one doctor. What do you think? This A1 is more stable or the B1 is more stable? One patient, 3 doctors. One patient, one doctor. Which one is more stable, A or B? Do let me know in the chat section who is more stable, A or B. One doctor, one patient, or one doctor, 3 patients. Oxidation state, I will let you know. Okay, don't worry. Mariam Hassan, let me tell you how to find out the oxidation state. Baba will let you know. Don't worry. Brain is not processing. C. South C is writing B. B is more stable. B is more stable. More stable means this conjugate base is more stable. Conjugate base is more stable. And we know that acidic strength is directly proportional to acidic strength is directly proportional to stability of conjugate base. Stability of conjugate base. Now kids, on the other hand, if I draw the second thing, just see to it carefully. If I say this is H3PO4 versus H3PO2, so I want to say after losing H plus, it will become P double bond O, O negative, O negative, O negative, all the three protons have been lost. It has become phosphate. Let's say this is X and it is going to lose. So it will become P double bond O, H, H, O negative. Now see, in this case, this is one patient and one patient and one more patient. How many patients are there? 3 patients, 1 doctor. 1 doctor, 3 patients. Now here, 1 doctor, 1 patient. First of all, do let me know which form is more stable. The X1 is more stable or the Y1 is more stable. Which one is more stable? 3 patients, 1 doctor, and at one place there are 1 doctor and 1 patient. Do let me know kids. Everyone just do let me know. Y1, very good. Y1 is more stable, very good. Now let me tell you, this is more stable. Now if I am not going to talk about doctor and patient, let me tell you, if you know a little bit about resonance, just see that this electron will do resonance full time on this pi bond. This will do resonance with this, stabilized by resonance. Now just see that charge will get divided equally 1 by 2. Let me write down its resonating structure. Its resonating structure will be like this: O negative, and dotted. So 1 by 2 and 1 by 2, and this is H, this is H. Now if I say over here, once it is doing resonance with this pi bond, they will remain localized. They will get less chance to do resonance with this, because at a time only 1 pi electron can do resonance with this double bond. So less resonance. Here is less resonance. So less stability, my dear students. Less resonance, so less stability, and there is more chances of resonance, more resonance, so more stability. I hope that everyone got it. So it is not anything like exception. People call it exception. There is no exception, my dear students. Each and everything is having logical reason. Have you seen? They are not exceptions. Nothing to be called as exception. You got it? Everyone, just do let me know in the chat section. Everyone got it? Is it clear? I want to see green hearts, green symbol, if it is clear to each and everyone, my dear students. Everyone, is this point clear? Everyone, just do let me know each and everything is clear. Wow, that's really awesome. It's really awesome that everyone is able to understand. Now let's move on. Let's move here. Wow. Now, one kid was asking how to find out the oxidation state. Now let me tell you, my kid, Suppose somebody has given you this compound Cr2O7. Now how to find out? Remember that oxygen's atomic number is 826. How many electrons oxygen is in need of to complete its octet? How many electrons it need to complete its octet? So it will gain 2 electrons and this will become O2 negative. So it will become 2, 8. So what is the demand of oxygen? Oxygen is always in demand of 2 electrons. It would try to gain 2 electrons. So see, the oxidation state of oxygen is 2. So there are 2 atoms of chromium. 2 atoms of chromium. So I'm supposed to find out the oxidation state of this. So I will write 2x plus 7 and the charge on oxygen is going to be -2 and this compound is neutral. Once the compound is neutral, I will write here 0. Now there is maths. Solve it. 2x minus 14 is equal to 0. So 2x is equal to 14. So x is equal to 7. I hope this point is clear. Somebody asked for it. I have told you, I have explained, right? Now see kids. Kids, I'm giving you each and everything. Acidic strength in hydrides. If they are hydrides, then how will you find out acidic strength? Remember that negative charge is more stable on the biggest atom. Everyone will tell you that negative charge is more stable on most electronegative atom, but I am telling you negative charge is more stable on the biggest atom. But if the size is same, almost same, then negative charge is more stable on most electronegative atom. So see, in the period, same period, size is approximately same. In the same period, size is same. So the negative charge stability will keep on increasing. So the acidic strength is also increasing. But on going down the group, the size increases, and size is increasing, then negative charge is most stable on the biggest atom. So this is most acidic. So the acidic strength is increasing in this order. So if you want to see the pK value, I can even write the pK value. It is approximately 50. Less is the pK, more is the acidic strength. Less pKa, more acidic strength. More acidic strength. Remember that its pK is very high. This is approximately 35. This is 15.7 at 25 degrees Celsius. This is +3. This is -7. This is -9. And this is -10. Least pK, most acidic strength. Gets. Now see, acidic strength in hydrides is already have shown you kids everything. Now this already have told you negative size, that size factor is number 1 and electronegativity factor is number 2. That negative charge is most stable on the most electronegative atom and the size is same, then the stability of conjugate base will be like this. Baba has shown you. Now atomic radius. Now we are going to deal with atomic radius. So how is the Josh? Let me see. How is the Josh, kids? Show me green hearts if the Josh is high, kids. Kids, Baba is going to start with atomic radii. Now let me check it out that everyone is ready with full on Josh or not, kids. I want to see the Josh, the greens. Wow, see, one kid is there and he is in GMC. Wow, that's really awesome. That's really awesome. Hi. Sir, you are moving fast. Okay, let me a little bit slow. Let me a little bit slow. Sausi, thank you. Jyoti Jan, thank you. Okay, now, so everyone is ready. Ready. Now see, let me move a little bit slow. So atomic radius, if radius is going to be more, then definitely size is going to be more. Agreed? Now see what's written. The distance of valence shell electron from the nucleus is called its radius. Means if I say that there is an atom, and if I say how far its outermost electron, the boundary, outermost electron is going to get the boundary of the circle. The outermost electron is going to get the boundary of the circle like this. If I say here is the nucleus, this is being the nucleus, and there are number of electrons, this electron, this electron, this electron, this electron, this electron, this electron, and some electrons are present at this place. This is the outermost electron. So this electron will move like this, move like this, move like this. So it will occupy this much of a space. So we will say what's the radii? So its radii is going to be from here to here. This is going to be the radii. This is going to be the radius. Are you getting my point, kids? Everyone, this boundary we will select from the center to the outermost where the electron is lying. That is going to give the idea about its radii. Now see, so where were we? Let me come back to the slide. Now the distance of the valence shell electron from the nucleus is called radius, and it is very difficult to measure the atomic radius. Why it is so difficult? Why it is difficult? See, electron is a wave. Electron is not a particle. Electron is not a particle. Electron is a wave. Wavicle, wave plus particle, dual nature, and wave never have sharp boundary. This electron will sometimes will go here, sometime will come over here, sometime will go over here. It will move like this, sometime it will go like that, and it will come like here and then there. So it is not having sharp boundary. It's like a ghost. It's like a tornado. Electron is wavicle. It is not having sharp boundary, and that's why they are saying that it's very difficult to measure the atomic radius, because the isolation of single atom is very difficult. Whenever the thing is very, very unstable, very, very small, they never exist in one, counting, or we can say they are not isolated. They are not existing in solitary form, alone form. They will occur in one big bundle, one big group. You cannot isolate them. So there is no well-defined boundary for the atom. These are the problems. These are the problems. So individual atom you will never get. You will never get individual atom. Have you seen very, very small ant, fish? You can find individual ant, individual fish. Not possible, because they are very, very small, unstable. Now what we are going to do to measure atomic radius? What we are going to do? Atomic radius, hence the internuclear distance of associated species is used, and this is internuclear distance, is also known as bond length. Internuclear axis. There is one word, internuclear axis. What is this internuclear axis? Let me tell you, kids. What is the meaning of internuclear axis? If I say that this is atom, and if I draw another atom like this, so just see to it that if I say this is the nucleus of this atom and this is the nucleus of this atom, so the bond length, this length is internuclear distance. From nucleus to nucleus, this distance is internuclear distance. From one atom to another atom, let me draw a big circle so that everyone can understand. Let me draw a big circle so that everyone can understand. If I say this is one atom, and if I say that let me draw one more atom, this one more atom. So if I say that this is the nucleus of this atom, this is the nucleus of this atom, so this distance From nucleus to nucleus distance, this will be known as internuclear distance. Kids, are you getting my point? Everyone. This is known as bond length also. You can call it bond length, or you can call it internuclear distance. But my dear students, number of times we are studying it and we are forgetting it. We are studying it and we are forgetting it. It happens with how many of you? That number of times you are studying it and forgetting it, studying it and forgetting it. What is internuclear distance? What is bond length? What is internuclear distance? What is bond length? And half of this is known as radii. Just let me tell you how much is radii. Radii is half of bond length or internuclear distance. Internuclear distance. Now, number of times we are forgetting it. So, let me give you one trick. Let me give you one trick. Let me give you one trick. How many of you want to get the trick? Whenever we are going to get ready, whenever we want to go to some function, any place, when we are going, where we are not having time and we want to move there very fast, we are colliding with something, with the table, with the bed. Oh my God, we are not able to fix the things. So we become half blind. When we are going to get ready, we becomes half blind. Am I right? Whenever we are going to get ready, we becomes half blind, half blind, half blind. Now, what is the meaning of this half blind? Radii is equal to half of bond length or internuclear distance. Radii is half of bond length or internuclear distance. How is it, kids? Oh, how is the trick? Do let me know how is the trick. During getting ready, we becomes half blind or half of bond length or internuclear distance. How's the trick? Let me see, kids. Hey, kids, how is the trick? During getting ready, we are becoming half blind, half of bond length, that is internuclear distance. Wow, kids are liking it. Wow, 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 wow. Now, let me move ahead, kids. Now, atomic radii, half of the internuclear distance between the two atoms in homoatomic diatomic molecules. Now, see, covalent radii, homoatomic means both the size are same. So, this is internuclear distance or bond length. If you divide it into two parts, then the radii. Radii is distance in between A and A, half blind. I have told you radii is half blind. Radii means half of blind, either bond length or internuclear distance, whatever you want to say. It has become very simple. Now, covalent radius for heteroatomic molecule, my dear friends. When there is homoatomic, let me tell you homoatomic and what's the difference between heteroatomic. Let me tell you. If I say this is Pandu, this is Pandu, this is also Pandu, both are Pandu, these are Pandu, Pandu. They are this much near to each other. One Pandu, another Pandu, two Pandus. Hey Pandu, how are you? Hey Pandu, how are you? So this is the distance in between two Pandus. This much distance, this much distance. So radii will be half of it. But if I say there is Pandu, one is Pandu, another one is Champa. This is Pandu and this one is Champa. See, if I say this is Champa, now the bonding will be more stronger. The bonding will be more stronger and these are heteroatomic. One is big, one is smaller, one is big, one is smaller, heteroatomic. Here, same atom. If I say this is chlorine, then definitely that is also chlorine. If I say this is chlorine, if I say that is hydrogen, so this is smaller, this is bigger, but whose bonding is better? These are same, that homo, they are different, so hetero. But you see, this is delta positive and this is delta negative, so this bonding is looking stronger. This bonding is this much of bonding has taken place. They have come closer by and closer by, so the distance in between these two will increase or decreased? Distance will increase or decrease, kids? Decrease. Distance will decrease, definitely distance is going to get decrease. Only this much of difference. Whose bonding is better? That bonding is better. The size will get decreased, the bond length will get decreased. In homoatomic molecule, it's very simple to find out the radii. This is the distance, so half of this, but in hetero, it's tough because the bonding and the electronegativity difference is there. Its electronegativity is 2.2 and its electronegativity is 3.0. So electronegativity difference is how much? Electronegativity difference is 3 minus 2.2. So it is going to come out 0.8. This is the difference. Here electronegativity difference 3 and 3. The electronegativity difference is 0. Electronegativity difference is 3 minus 3. That is coming out 0. So it's not easy to calculate the size of heteroatomic covalent bonding. Now see who has given for the Shoemaker and Stevenson. Remember this formula. Whatever the size is expected for heteroatomic, that comes a little bit less than that because they come more nearer to each other, because there was one Pandu, another one was Champa. This is Pandu, this is Pandu, and that is Champa. So the size will decrease. Pandu and Champa story. This is Pandu and that is Champa. And there was either I can say Pandu or Champa or Pandu. They will lie a little bit more far away. My point is clear. Now see, Shoemaker and Stevenson had find out that radii of A plus radii of B, and something to be subtracted. Now no need to cram it, what to be subtracted or added, because they have come a little bit more closer, so the distance will get decreased and the sign is of decreasing. Just you have to remember this value, 0.09 into delta x. This delta x I have told you the electronegativity difference in between two atoms in angstroms. So DAV is equal to RA plus RB, and this is in picometer, that is angstrom. You know that picometer 10 raised to the power minus 12, deci centimilli micro nano pico femto auto. So this is clear to all of you kids. Is it clear? Till now is it clear? I hope that I am not moving fast. First of all, any doubt? Let me see in the chat section. Any doubt, kids? Any doubt to anyone till now? Till now, any doubt to anyone? Everyone just to let me know. Everyone. Baba is in front of chat section. Numerical I am going to give you, but first of all do let me know, is it clear? Is it clear to each and everyone kids? Shoemaker, scientist. Shoemaker is Stevenson and Shoemaker is scientist. Baba is always sitting in front of the chat section, so to check it out whether any doubt is there or not. Shoemaker is the name of scientist. This value you have to remember. Kiran Pathak ji, this, thank you Jyoti Jain. Are Mariam Hassan. Which one? No need to divide. Radii is given, so why to divide? Already radii they have given. Kiran ji, just remember 0.09. You have to subtract. Thank you, Pavitra. Thank you. Thank you. Just you have to subtract. Now see, kids. This value only have to remember. This is experimentally determined. Experimentally determined. Experimentally determined. So you have to learn it. You have to cram it. Okay. This is being experimentally determined. So just cram it. Now see, this is the numerical. Some kids were asking for the numerical. Now see, if RH, radii of hydrogen, is this much, distance of Cl2 is this much, electronegativity of hydrogen is 2.21, and electronegativity of chlorine is this, then find out distance of HCl. Now what you are supposed to do? How to find out distance of HCl? Just see the formula I have told you. Distance of HCl, distance of HCl, radii of anion, radii of cation, means 2 radii minus 0.09 into electronegativity difference. Will you be able to apply? Just see, radii of one atom, distance is given, half of this is homoatomic, so half of this will be the radii. Suppose this is the radii of A, this is being the radii of A. Then this, how to find out the radii? This is given the bond length, so the radii of half of this, half blind, so 198, half of 198 is how much? Half of 198 is how much, kids? Do let me know. Definitely it is going to be 99. So Ra plus Rv you will get, this is in picometer, but remember this is in picometer and that is in angstrom. So convert that picometer into angstrom. 99 picometer means 0.99 angstrom. Divide by 100. So it will come out 0.99 angstrom. Am I right, kids? Now you can add both of them, both of that too, and you can apply the formula. See that you see electronegativity difference is coming out 0.9, distance D divided by 2, 99 picometers, so 0.99 angstrom. You got it. Now put it in the formula, 0.74, 0.99 minus 0.09, and this electron difference, you will get the answer. First of all, do let me know in the chat section how much efforts Baba is making for you. Baba is explaining as well as giving notes. Gets clear or not? Everyone just do let me know. Baba is, wow, Wasim sir is there, kids. Wow, kids. Welcome, bro. Welcome. How are you, bro? Welcome. So, Wasim bro is there. Veera. Hey bro. How are you? कैसे हैं आप? Welcome. No, it's not fake ID. I don't think it's fake ID. Sir is there. I don't think it's fake ID, kids. No, it's not fake ID. Let me see what Wasim sir is writing. I will tell you whether it's fake ID or not. Okay, no problem at all. Now everyone, you are able to understand this question or not? First of all, do let me know. If not, then I will explain it. First of all, do let me know, kids. Kids, are you able to understand this question? Then show me green hearts. Now kids, Lafia, what happened? Lafia. Kids, first of all, Baba, you left original Baba. What? I am unable to understand. Kids, do let me know you are able to understand this question. If yes, show me the green hearts so that I can move ahead. Everyone, if you are able to understand this question, show me green hearts. Fire. Very good. Very good. Very good. Sahana, once again, welcome. Now see kids. Van der Waals radii. My dear students, Van der Waals radii, let me tell you what I call it. I call Van der Waals radii as Van der Waals radii. Let me tell you what I call it. Van der Waals radii I call it humanity, being human. I call this relation as being human, humanity. Suppose if there is one, what's the name? His name is Ravi. And Ravi don't know, this is Mania. This is Mania. Ravi don't know who is Mania. Ravi and Mania, they don't know. Ravi is Indian and Mania is Canadian. And Ravi is Indian. Ravi is being Indian. Now kids, they don't know each other. They don't know. They are neither friends nor brother, sister, nothing. Now do you think any type of relation is there? What type of relation they are having? They are human beings. They are human beings. The relation, when there is no relation, we will say humanity relation is there. Humanity. So humanity is always there. If I say this is Pandu, this is Pandu, and this is Alia. If I say Pandu and Champa, they are Pandu and Champa, they are husband and wife. Husband and wife. Then husband and wife relation is there, but still the humanity relation is there. Humanity is relation will be there. If I say kids, there is Mania. This is Mania and Mania's sister Tanya. Mania's sister Tanya. Then Mania and Tanya being sisters, the relation is sister, but still one relation is there, that is of humanity. That means humanity relation is always there. Whatever the type of bond is there, the ionic bond, covalent bond, hydrogen bond, any type of bond is there, humanity relation will always be there. Being human, humanity relation will always be there. So what I want to say kids, whenever I talk about Van der Waals radii, so always we are going to show this atom and that atom, neon and neon. We are always going to say, we will talk about noble gas elements, helium, neon, argon, krypton. So everyone is feeding in our brain that only these elements, they are having that Van der Waals forces. No, my dear friends, if I talk about, see, if I say this is chlorine, they are bonded, they are having covalent bond. And if I say there is one more chlorine and chlorine, they are having covalent bond. Now, if I take this is one family and this is another family, what the relation in between these two families are there, then we will say they are having Van der Waals forces. Van der Waals forces of attraction. Kids, one point is clear, that in neon and neon, in between neon and neon, there is no other bond present. There is only Van der Waals forces of attraction. But if I say chlorine 2 and chlorine 2, chlorine molecule and chlorine molecule, that they are having covalent bond. Along with the covalent bond, they are also having van der Waals forces of attraction. Van der Waals forces of attraction are always there, whether any type of force of attraction is being present or absent, but van der Waals forces is always present. Remember that, keep in your brain, mark my words, I'm categorically telling you this particular point. I hope that this point is very much clear to all of you. Now neon and neon, they will lie far away, and see the distance is too much. So van der Waals defined for noble gases and gaseous molecule in solid state, this is very big, very big. So in the examination, what type of question will come? That before moving towards question, this is metallic radii. So what is the difference between metallic radii and covalent? Metal, they will remain, they will touch, just touch, they will not overlap, but covalent bond was overlapping. Let me tell you the difference. That metal, they will remain like this, they will touch, but they will not overlap. So this will be the internuclear distance. But if I talk about covalent bond, they will overlap, so this distance will decrease. Whose radii is more? This is metallic radii and this is covalent radii. Definitely this radii will be lesser and this metallic will be more, because they can't overlap, but this space got decreased. So see to it. Maximum radii is van der Waals radii, then metallic radii, and then covalent radii. This is maximum radii kids, and this is least radii. Am I right, kids? So the examiner will ask whose radii is being maximum, then van der Waals, VMC. Remember that, VMC. Now size of isoelectronic species, till now is clear, everything is clear. Do let me know, then I am going to start, then I am going to move ahead. Kids, do let me know, till now everything is crystal clear. Oh, it's good morning, that's why you are saying, that's why everyone was saying good morning. It's 12. My God. Now it depends on where they are present. We cannot say which bond is more stronger and like this. Now kids, just focus on the studies. Don't talk, don't ask how much time. Even Baba don't know how much time I am going to take. I'm focusing on teaching you, telling you each and everything. You are asking for time. Baba can't. Baba is unable to tell you the time, my dear students. Class duration, I can't tell you, kids. Wow. Now that's really fantastic. Now come back. Let's move ahead. Now what we are going to deal with, just see to it. Kids, now we will move a little bit fast. Atomic radii is inversely proportional to Z effective. By Z effective, see, I am saying, hey, my electron, where are you going? I am just pulling my electron, outermost electron. Raja is asking to Rani, hey Rani, where are you going? Too far, just come near to me. Then the outermost Rani will come, shing, outermost Rani, so that will come nearest, so the distance will be less. More the force of attraction of the Raja, that is proton, electron will be more nearest to the nucleus. So Z effective, it is inversely proportional to Z effective, and Z effective was directly proportional to the positive charge. I have told you Z effective was directly proportional to the positive charge, inversely proportional to the negative charge. So see, these all are having how many electrons? 10 electrons. All they are having 10 electrons. This is having 10 electrons. All they are having 10 electrons. All they are with 10 electrons. Now, who's having maximum proton, maximum atomic number? It's Z is 13. Z is 13. So its effective nuclear charge, Z effective, will be maximum. maximum Z effective, so least size, and see its atomic number is just 7. So number of electrons are same, shielding is same, but Z is less. So we know that Z effective is equal to Z minus this. So this is same. The one who is having maximum Z will have maximum Z effective, least size. So least Z effective, it's least Z effective, so maximum size. I hope that everyone is able to understand. Do let me know this point. This is really very important. This holds a whole lot of weightage, and I hope that this point is very much clear to all of you. Once if it is clear, don't forget to show me green hearts, the fire, the thumbs ups, everyone. Now kids, do let me know. Everyone just do let me know. Kids, I'm asking to you only, kids. Do let me know that the concept. Saucy, thank you. Thank you, kids. Thank you. Thank you too much. Very much. Now, let me move ahead. Wow. Very good, kids. Now, factors affecting atomic radius in a period, kids. I'm saving your time. I'm not saying to write it down. Baba has made great slides. See, kids. Now, atomic radius is inversely proportional to Z effective. So, see, Z effective is, this is having maximum Z effective, so least size, and this is having maximum size. You can see very clearly. Now, see to it, kids. This one, see, lithium, sodium, potassium, rubidium, cesium, atomic radius is directly proportional to number of cells. This is having 7 shells, 7 orbits. So its outermost electron will be far away, and it is having just lithium 3. So 2 shells only, so its nucleus is like this, 1 shell, 1 more shell. It is having 7 shells, so its nucleus 1, 2, 3, 4, 5, 6, 7. The outermost electron will be far away, so maximum size, so least size. I hope that it's clear. Now, in the group, if you go down, the size is increasing. When you move down, the number of orbits are increasing, so the outermost electron will go far away, so the size will increase. Just see, size is getting increased. Now see, lithium, beryllium, boron, carbon, nitrogen, oxygen, you see, and the neon, noble gas is that much big. See, kids, what a representation. Just see, size was of lithium this much, beryllium less, because Z effective is increasing. From here to here, Z effective is increasing or not? Z effective is increasing. Z effective is continuously increasing. Size decreasing, size decreases, size decreases. Oh, van der Waals radii, that much bigger, zero group. So big, even bigger than that. Just see the visualization, kids. See what Baba's representation. See Baba's representation. See, kids. So big balloon, no Baba re, Baba, such a bigger size, biggest one. Everyone, kids, let's move here, move here side, let's move here. Now let's move. I hope that you got it. Now this is indicating that noble gases is having biggest size. Noble gases, the biggest one. Now, oh, now for this, to understand this, just try to understand. Baba will let you know. Baba will teach you this one. See the size, the representation. Science teach you very crazy man. Decreasing, the size is decreasing. Science teach you very crazy man. Up to here it is decreasing. Why decreasing? See, Z effective is increasing. Up to here to here, Z effective is increasing. Z effective is increasing. Z effective increasing up to here. Z effective is responsible. Z effective increases, size decreases continuously. Now what happened to iron, cobalt, nickel? Now see, iron's atomic number is 26, this is 27 and this is 28. Now if I write down the filling of electrons over here in 26, let me write down only one. You just try to understand what I want to tell you. Now, D. So, how I will write 26? I will write 4s2, 3d6, 3d7, 3d8. 1, 2, 3, 4, 5. Now the pairing of electron is taking place in these pairing of the electron, and the pairing, due to pairing there will be repulsion. So Z effective increases. Increase of Z effective is saying, increase of Z effective is saying the size has to get decreased. But electronic repulsion at the same time, electronic repulsion at the same time is saying that size has to increase. Now what is happening, kids? One factor is saying size should decrease, another factor is saying size should increase. What is going to happen then? Who will decide then? One factor is saying decrease, another factor is saying that it has to increase. Now what will happen, kids? It will become constant. They will neutralize, nullify each other, and that's why the size is remaining constant. Can you see? Now more and more electrons are getting filled. It's 28, 29, 30. So the repulsion, electronic repulsion will dominate over here. Electronic repulsion will dominate. Repulsion will dominate. Electronic repulsion will dominate, kids. So the size increased. Here Z effective was dominating factor. Are you getting my point? Z effective was dominating, so the size was decreasing. This was dominating, so the size was decreasing. Here both were dominating, so constant. Here electronic repulsion is dominating, so size once again increased. So remember the ship, Titanic ship. This Titanic ship, the atomic number is increasing and atomic size. Good representation. First of all, do let me know this representation is a really good one or not, kids. I want to see in the chat section this is a really good representation or not. And kids, those who are new, hit the like button, smash. Oh no, I'm not going to say hit the like button. That's your choice whether you want to hit it, otherwise not. But I want to see the green hearts, kids. Saucy, thank you. Saucy is really very active. I'm loving this. Shivam, Linon, Shivam. Yes, chat is slow. You can make it fast. Kiran, very good. Jyoti, wow, Jyoti, thank you. Pavitra, wow. Rajam, Chandrika, Nighat, Mazid, wow, thank you. Now let's move here, kids. Now move here style. Oh my God. This one once again will require lengthenoid contraction. How many of you want to understand lengthenoid contraction, my dear students? What is this lanthanoid contraction? Let me teach you. First of all, kids, let me tell you about this. Is if I say that this is S, this is P, this is D, and this is F. Now I would like to say, kids, one thing, that the S is like this. The S is like this, very much dense, very much dense. The P like this, P is like this, not that much dense. P is like this. Suppose these are the curtains. Now if I say this is D, then D are like this. Now if I say this is F, then the F is like this. Now you see, this screen, these are screen, these S and P screen is good, so their screening effect is good, or shielding is good. Shield, you know shield? That if you're going to fight, in one hand you are having sword, another hand you are having shield to protect. These are having good protection power, these are good shielding effect, these are having good screening effect. But these are duffers, D and F. These are having very, very poor shielding effect. Now you're getting my point. Very, very poor shielding effect. Very, very poor shielding effect. Now my dear students, they can't stop the force of nucleus, or I would like to say they are not able to cancel that much the force of nucleus. They are cancelling out more effect of nucleus. They are having good screen. Good screen means will not allow the nucleus force, will not allow that much nucleus force to be applicable on the outermost electron. That outermost electron will feel less force of attraction, But if there is a nucleus, and if it is passing through D or F, then the force will pass too much. They won't be able to stop this force that much. They won't be able to stop that force too much. So the force will go on the outermost electron. This force of attraction will be more. And this force of attraction is very less. Are you getting my point? That means I would like to say that D and F, their screening is not good. Are you getting my point? And let me tell you, my dear students, F is having even burst screening effect, shielding effect. Are you getting my point? Now see what I'm going to tell you. Where it's gone? It is over here. These size, this is though definitely increasing, but see here, this is 3D, this is 4D, and this is 5D. If you see 4D and 5D, they are having approximately same size, but from 3D to 4D it is being increasing. It's increasing, but here it's remaining constant. Why? Who is responsible for that? If I talk about scandium, biterbium, lanthanum to hafnium, its atomic number I have told you it was 57. It is 57 and it's 722. In between these there are 14 elements, and here there are also 14 elements, right? 14. So lanthanoids are there, and in the lanthanoids lanthanoids, the filling of electrons is taking place in which subshell? F. For each increase in atomic number, the electron is getting filled in F, and where F is located, let me tell you where F is located. Just see. If I say any element, take cerium 258 to 71, you can take any element. This is a lutetium. If you select, suppose if I say its atomic number is 60, so protons are 60 positive, and I will say that the first orbit, the second orbit, the third orbit, the fourth orbit, the fifth orbit, and the sixth orbit. In the sixth orbit, 6s2 electron is there. Now, the outermost electron is coming in F. Which F? N minus 2f. So it will come in 4f. Now the electrons, if I say that its atomic number is increasing by 1, suppose if I 61, it is increasing by 161, then the electron will get filled in this one. Now its shielding is very, very poor. Once its shielding is very, very poor, now this will allow this electron to come near. For each addition of electron, the shell will come 1 point closer or 0.7 point closer. It will keep on coming like this, it will keep on coming like that, and on the addition of 14 electron, once the F4F is getting 14 electrons, this will come over here. Now its position will get shifted from there to there, and this much a decrease in the size. This much a decrease in the size is known as lanthanoid contraction. This decrease in the size is known as lanthanoid contraction. Lanthanoid contraction, my dear students, are you able to understand that the continuous decrease in the size of atom because of the poor shielding of F is known as lanthanoid contraction? First of all, do let me know in the chat section. How many of you got it? What is the meaning of lanthanoid? For each increase in atomic number, there is decrease in the size of atom. That is known as lanthanoid contraction, kids. I want to understand that how many of you got it, kids. First of all, do let me know. Kids, do let me know. Show me green hearts. Everyone, I want to see in the chat section that lanthanoid, continuous decrease in the size of atom, continuous decrease. I would like to write down over here that what do you mean by this, that continuous decrease in size of atom for each addition of atomic number, electron is added to 4f having very poor shielding, so it can't shield or can't cancel out the effect of this force. So this nuclear force of attraction is increasing. Nuclear force of attraction is increasing. That means Z effective is increasing, and once the Z effective is increasing, size has to decrease. This is known as lanthanoid contraction, and lanthanoids are coming in the picture after this element only. So see, before this they are not having lanthanides. Lanthanides are over here, the size is equal to, but here if you talk about this is third B, the continuous increase in the size is there. Sky laces, sky laces, continuous increase in the size, but rest of other elements of D block, these 4D and 5D, they will have same radii, same, approximately same radii. Are you getting my point? They will have approximately same radii, approximately same radii. They are having approximately same radii, but only there is one, that is 3B, that scandium, ytterbium, lanthanum, actinium, their size is increasing because lanthanides will start from here and actinides will start from here. Even this scandide contraction was there, the size was decreasing. So if I talk about whose effect is that, then actinoid contraction is maximum value, actinoid contraction, this is going to give maximum effect. After that there is a lanthanoid contraction, and after that, my dear students, there is in D subshell is also not that good because these are due to F, and F, you know that 5F is even more diffused than 4F. So 5S even more diffused, and after this I would like to say this is scandide. Scandide means d orbital contraction, scandide contraction. This is having the least one, and its contraction will affect definitely who is going to get affected, the, what to say, the boron, aluminium, gallium and thallium. Boron, aluminium, gallium and thallium, they are going to get affected. They are going to get affected. Now let me tell you, this I have written about the extent of contraction. Extent of contraction. I have written extent of contraction. Now my dear students, this is due to F, and this is due to D subshells. Poor shielding. They have got poor shieldings, right? Now, how they are going to affect the boron family? Just see where boron lies. Let me show you the position. If I talk about 4th orbit, see, this is the 4th orbit, 5th orbit, 6th orbit, then 7th orbit. How they will get affected? Just see. You should have knowledge of periodic table. Chaube kakka. Science teacher very crazy man. Science teacher very crazy man. I felt cold. In night with cousin. Felt cold in night with cousin. Gage asse burker. Gage asse worker. Now gallium is coming. So definitely if you move over here, gallium is going to get affected. Gully. Hey gully boys, this will get affected. Now if I say from where the lanthanoid contraction has been started, that was 6th kaswa. This one chota hai kaswa. Kesiba kaswa. What is this kaswa? Si kasba. Chota hai kaswa. No. So which element will lie over here? Cesium. Chota hai kasba. La. Now La silu half. Half is over here. Now how many elements? C to Lu, 58 to 71, 14 elements. So they are going to affect. So which after this 5th, there is boron, gallium, indium is okay, but thallium will come over here. So thallium will get affected, gallium will get affected, and thallium is going to get affected maximum effect, and that is known as inert electron pair effect. And I would like to say ionization potential as well as the size. So definitely whose size is going to get affected? This gallium will become smaller as expected to size, and thallium will become smaller as expected to the calculated size. These two of the 3rd A boron, aluminum, gallium, indium, thallium are going to get affected. Maximum effect on these two. Maximum effect will be there on these two. Maximum effect on the size, and definitely that size is going to get decreased. Size is going to get decreased. I will show you. Now, are you ready? Are you able to understand? First of all, do let me know. The concept clarity is there, then only we are going to move towards the question. First of all, do let me know, kids. Hey everyone, I want to see in the chat section that you are able to understand. Everyone just do let me know what I'm talking about. Gallium is going to affected because scandide, and thallium is going to get affected because of this lanthanoid contraction. The two animals are going to affect their size. Here, this is known as scandide, because starting with the scandide contraction, scandized contraction, I would like to say this is going to get because of scandide contraction is there, and simply you can say D subshells and this after this is going to be lanthanoid contraction. I would like to say this is going to affect because of lanthanoid contraction, or simply I can say F subshell, poor shielding of F cell. Now see what type of question will be asked. See, exceptions in third group. See, boron, gallium, aluminum, indium, thallium. The expected size was expected. Let me write down expected. Expectation is this. Expected size. Boron, then aluminum, then gallium, then indium, then thallium, because just after this point we have studied as we go down the group, the number of shells increases, so the size is supposed to increase. So everyone was expecting this should be the size. This one be the least one, and this one be the maximum one. The least size, the maximum size. This was just the expectation, and you know the expectation is not going to meet with the reality. Reality is being something else, my dear friends. Reality is not this. This is wrong. It has been found to be wrong. Now what is correct? Bengal in Thali. Now see, boron, then gallium. Gallium is C, aluminum, and gallium. Gallium size is over here, even less than that of aluminum. Gallium is even. Now how to remember Gully Boys. Have you seen that movie, Gully Boys? So Gully is always smaller. Gully Boys, Gully is always smaller. Gully is always smaller. So what is the trick? Bengal in Thali or Bengal in Thailand. Remember that. Now see, thallium, indium, and thallium. It's like that. Okay, you got it? Bengal in Thali. This is the trick. Bengal or Bengal in Thali. Bengal in Thali. This is the trick for this. Now, actinoid, lanthanoid, and scandinite. I have told you exceptions, overall reasons. These are the reasons already explained. Ionization enthalpy. So now we have finally reached to the ionization enthalpy, then electron affinity, and then some more things, and then it will get over. I will tell you bone have a cycle also and electronegativity also, but let me have some water, kids. Even you can have some water. What's the time now? Let's see. What's the time? Yeah. Thank you, Shubh. Thank you, Shubh. Thank you. Now, can we take a small break, kids? Then we can start ionization enthalpy. Can we take, or after teaching you enthalpy, okay, so this time we will take a small break. Small break. Let's meet at 1. Okay. 15 minutes break. Yeah, slides I will. Thank you everyone for your love and support, kids. Okay. Let's take a very small break. So 10 minutes break. Let's take 10 minutes break. Then we are going to start 10 minutes break. Okay. ATP breaks. ATP. Get ATP. Get ATP. Okay. ATP break. Welcome back again, my dear students. Just to let me know, everyone, the units, ionization energy. How many of you find it difficult to understand what is being ionization potential, ionization energy, and always your questions, you're getting negative marks? How many of you are there? But first of all, welcome back again. This is your Baba HSP standing in front of you, and this class is all about going to be about ionization energy, ionization potential, because this holds a hell lot of weightage. And if you want to write it down, you can make a note of it, because Baba HSP is going to explain it in the best way. I will tell you each and every point in the simplest way. Don't think like that how much time has been passed. You can consider like that. Even I'm telling you, I'm going to consider like that. I'm going to start this class. This is right now, I'm going just to start the class. I will take it like that on way. Even you can think like that. I'm going to start it. Our class is right now is going to get started. We have not been studying for long back. You can consider like that. Right now, we are going to start this class. Hey everyone, how are you? Good morning. Hey Champa, Alia, Ramu, Pandu, everyone, how is everyone? Let's start the class. Hey, have a good morning, very, very good morning. So, we have taken sound sleep. You just try to imagine in this way. You will feel that yes, it's happening. It all happens with your thought process. The hormones will get released in that way. Whatever you're thinking, the things will start moving in that direction. I'm thinking like, hey everyone, I'm the park. How? What's up? Say, dear friends, everyone fit and fine? Yeah, yes. So let's start with ionization energy. You must be thinking that Baba has gone mad, but no, Baba today has not done the dinner. Today, I have eaten salad. Whenever I am giving a break, I was having cucumber, apples, tomatoes, sopta, chiku. So all I was having in this box, just see, this box, the ice cream box, and now it's empty. In every break, I have enjoyed that. Now, see kids. Ionization enthalpy. So, what do you mean by ionization enthalpy? Before I give you the definition, ionization enthalpy means that somebody is trying to snatch electron. I have considered that electron is like Rani, and inside the nucleus there is Raja. Raja ko Rani se pyar ho gaya. This is Raja. And in the outermost electron, there is a Rani, number of Ranis, but anyone is going to snatch this Rani outermost orbit. Someone will come. This Rani belongs to this, and someone will come. I'm coming to snatch your Rani. So he's in need of this electron. He will supply some energy. He will throw some energy, he will supply some energy, and he is trying to take out this electron. Let me tell you what actually is ionization energy, then you can better understand. See, let me tell you. Suppose one day, sodium was moving. I'm sodium. My atomic number is 11. 281. I'm always searching. I'm being sodium. Let's suppose I'm being sodium. I'm always searching someone to whom I can donate my 1 electron. So from other side, chlorine chilled champa has come. Chalu champati, chilled champa. Chloride has come. Atomic number 17. She was in need of electrons. Champa has seen this sodium. Champa said, hey, sodium, how are you? Sodium said, I'm good. Just tell me about you. How do you do? How do you do? Champa said, I'm also good. Champa said, I'm in love with the shape of you and thinking of attacking too. I'm being highly electronegative. Champa said, hey, do you know about me? I'm being highly electronegative and I'm in love with the shape of you and thinking of attacking too. So Champa has supplied some energy on sodium. Zoom, chakalaka, zoom, zoom, zoom. Done the black magic. And sodium has donated 1 electron. I have donated 1 electron. Take Champa. Live happily. So by getting energy, by getting some energy, sodium has thrown out electron. Now sodium has become Na plus and Champa has become Cl negative. Now my dear students, energy he has taken, energy she has given. That has released energy. Champa has released energy, released. And if I talk about release, so I will say exothermic process. Delta H is negative and he has gained energy. So gained energy, so endothermic, gained energy, so endothermic. Delta H is positive. So at the same time, there we are studying electron affinity and here ionization energy is going on. So now they will live together. Happy marriage. Congratulations, you have made salt. So here I was talking about ionization energy and here I was taking about electron affinity or negative electron gain enthalpy. But I will tell you these things in detail one by one. But in this way, happy marriage has taken place. The ionization energy and electron affinity, because this is the complete reaction. Always we are talking about just ionization energy, that is better half. The better half of ionization potential is electron affinity and better half of electron affinity is ionization potential. They are better half because whatever the energy is released, the same energy is gained. Energy can neither be created nor be released. It can just transfer from one form to another form. First law of thermodynamics. Am I right, kids? Let me see in the chat section what's going on. What's going on, kids? What's going on? Then I will tell you in detail. Whatever I am talking about, you are able to understand. Have you got it? Have you got it, kids? The way Baba was trying to tell you. The way Baba was trying to tell you, kids. Got it? Now I will tell you in detail. I will move one by one. Yes, you can. You can. Manahil, yes, you can. Now, see to it. See to it. Now, let me tell you one by one. One by one. Okay. So, let me first of all define ionization energy. Let me give you the definition. Definition of ionization energy. What do you mean by ionization energy? Let me define it. Ionization energy is defined as the minimum amount of energy. What do you mean by minimum amount of energy? Before completing this definition, if I say in the society number of pens are available, but the pen which is having lowest cost is of 10 rupees. So if you want to purchase, if you want to buy one pen, what amount of money you will ask to your mother or father? Mama, please give me at least 10 rupees, at least 10 rupees. That is the minimum amount before, because less than that you won't be able to buy the pen. If you go to some restaurant and suppose the pizza that is of, means minimum amount of that is, smallest one is of 100 rupees, 1000 rupees, 5000, number of things, number of types of pizzas are there. But if you want to eat pizza, at least one pizza, then you should have bare minimum of 100 rupees. You will ask to mother, Mama, please give me at least 100 rupees so that I can enjoy pizza. So ionization energy is defined as the minimum amount of energy required to remove one electron from the outermost orbit of an isolated gaseous atom in its ground state, This ionization energy is also known as the first ionization energy. So remember where the points to be noted, my lord. Just focus the minimum. This is important point to be noted in your brain. Energy required, it is endothermic from the outermost orbit, and isolated means alone, it should be solitary, and in gaseous atom in its ground state. These are the points to be noted, my lord. Everyone, you have to keep this. Is not so simple, and this is not tough also. If you're applying your brain, you can understand each and everything, kids. Now let me explain with the help of one equation. Suppose if I talk about sodium, this is sodium. It should not be solid, it should be gaseous. First of all, gaseous atom is required. It should not be bonded with anyone, it should be alone, and we know that its atomic number is 281. So whatever the energy we are going to apply, this energy, applied energy, will make it Na positive gaseous. Now it is having just 28. Now it is not sodium, it will be known as sodium cation. Its name will be sodium cation, and this electron will be out. Now I will say this is being sodium cation. Now another way of writing this equation is like this. I can have written this equation like even like this also. Sodium has given Na plus gaseous and delta H is positive. This is indicating that is being endothermic reaction. It is being endothermic reaction. So delta H is positive. The change in enthalpy, it is energy is required. Always energy is required. Energy will be required. Definitely energy will be required. So always it's like this, my dear students. Now this element has converted into cation, and it has acquired a noble gas configuration, and you know that noble gas configuration is highly stable. Now if I say, if you want to remove one more electron from Na plus, because it has got noble gas configuration, so if I say that during this conversion Na gaseous to Na plus gaseous, it has got converted. If I say that delta H was X kilojoule per mole, if I say like this, then remember that, my dear students, if you want to remove one more electron from this, already it is stable configuration, noble configuration, and if you want to remove one electron from this to make Na double plus, then my dear students, this will be known as delta H is equal to Y kilojoule per mole. But my dear students, remember that Y will be too much greater than X. The amount of Y will be very, very higher than X magnitude wise. Why? Because here you have removed one electron to get noble gas configuration, and once the noble gas configuration is acquired, it has become highly stable. Now you are going to remove one electron from the highly stable form, then definitely you have to spend too much amount of energy, then only you can remove one electron. So this jump will be very, very high, that in between this and this will be very, very high, this amount will be very high. So remember that if the amount of ionization energy gap is given too much, these are known as successive ionization energy, that this one is known as IE1. I would like to say this is known as IE1, ionization energy 1, and this is known as IE2. In place of ionization energy, you can use ionization potential also, ionization potential. Then I will say IP1, and this is known as IP2. And IP2 will always be higher than IP2 will always be higher than IP1, that is ionization energy 1. But this highest jump is indicating that some electron is getting eliminated from noble gas configuration. Whenever the jump is too much jump is there, too much difference always means too much difference, always indicating that this type of configuration. I hope that everyone got it. Just to let me know in the chat section, this point is clear to each and everyone. If yes, then you can solve all type of questions. I want to see kids in the chat section that you are able to understand. I need green symbol, green hearts, whatever. Then my dear students, now kids, let me tell you something more about this. So how to find out the ionization energy, my dear students? Now see to it, which elements are going to give highest difference and each and everything. Let's see, my dear students, who is going to affect the ionization energy? See, Baba is going to tell you. See, factors affecting ionization potential, factors affecting. Baba is going to tell you the factors, and the trick also Baba is going to give you. Factors affecting ionization energy. So remember that Jeff, somebody is Jeff, name is Jeff. Hey Jeff is having HSP, Hussy Puppy. Remember this code. Let me write down. It's not looking good. Hey Jeff. Jeff is a girl. Its name is Jeff. Hey Jeff. Jeff. Somebody is there, Jeff. Hey, you are Jeff. This is Jeff. Name is Jeff. Your name is Jeff. And Jeff is having what? Jeff is having Hussy Puppy. Hussy HS Puppy. This is the trick. It's Hussy Puppy. HSPP. Jeff is having HSPP. HSSPP. The trick will work. Everyone say Jeff is having Jeff. Jeff is having which Jeff? To calculate IP. Jeff is having HSSPP. Baba is HSP. Baba is HSP. So doubling of S and P, HSP. Jaf is having HSP. Now, if trick has been dissolved in your blood, just do let me know. Once the trick has been dissolved in your blood, then I will tell you. Jaf has HSSPP. Everyone say Jaf is having. To calculate IP, Jaf is having HSSPP. Okay, now once this has been dissolved in your blood, let me tell you what is the full form's meaning, the meaning of this HSSPP. Let me decode it. Z effective is, effective nuclear charge. This is effective nuclear charge. H for, just think about what is the H. What do you mean by H? H will be standing for ionization energy. What is the meaning of H? Just to let me know. What do you think? Yes. What should be the meaning of this? It is half-filled stability. Half-filled stability. S, size. S, screening effect. P, penetration power. Now another P. What should be the meaning of last P? Who is going to tell me what should be the meaning of principal quantum number? Principal quantum number. That is N. Okay, now let me tell you the first role of Z effective, then half filled, fully filled, penetration power, size and screening. All these things are going to define ionization potential. Now let me tell you kids one by one. Let me tell you one by one. Just see. If I talk about that when you were in class 9th or 10th, everyone must have told you that the ionization energy order is lithium, then beryllium, then boron, then carbon, then nitrogen, then oxygen, then fluorine, then neon. What you have studied in your class 10th, that on moving from left to right, ionization energy increases. You must have studied this thing only, kids. But let me tell you, my dear students, if this is 1A, this is 2A, this is 3A, 4A, 5A, 6A, 7A, 0 group. The ionization potential of this element, this is the boss. Hey boss, his ionization energy is more than both of these two elements. Please don't ask me why, but I would like to say yes, it is more than these two. Now this element, the nitrogen, its ionization energy is more than these two, the adjacent members. Remember that, adjacent members. Otherwise it will keep on increasing. Otherwise their trend is like that, it will keep on increasing, no problem is there. Now can you see the order? Generally it is increasing on moving from left to right. Generally, as the Z effective is increasing, generally it is increasing. I would not say that permanently it is increasing. So Z effective increases, the ionization energy increases. You can see from this, as we go from this, it is having least and that is having maximum. So Z effective increases, ionization energy increases. Then why these are having exceptional order? Which these two are having exceptional order, kids, remember that. But question arises, why these two are having exceptional order? This is having these two are having exceptional order, but question arises why these two are having exceptional order. What's responsible for that? Then that one thing will come into role. But before that, let me write down, as Z effective increases, ionization energy increases, and for this you can see least Z effective, least ionization energy, maximum Z effective, maximum ionization energy. Now, which thing is coming in these three elements? Now see, if I talk about electronic configuration, its electronic configuration is 1s2. How much atomic number? Otherwise you won't be able to understand. So let me tell you how much atomic number first. How much atomic number? Its atomic number is 3, its atomic number is 4, 5, 6, 7, 8, 9, 10. If you don't know the electronic configuration, you won't be able to do. It's 1s2, 2s2, 1s2, 2s2, 1s2, 2s2. So this is 2s2, fully filled configuration. Fully filled configuration. And fully filled configuration is always going to give more stability, more stability. Now it is having 7. So 1s2, 2s2, 2p3. You can see half filled, half filled. Now you will say, sir, half filled and fully filled, half filled is better than that fully filled. Then why it is having more ionization energy? Hey kids, just wait, Baba will tell you. Baba will definitely explain each and everything. There's nothing like exceptional cases. Half filled stability. Then how come half filled stability is more? I will let you know. Then another factor, half filled stability. Now definitely 10. 10 means 1s2, 2s2 and 2p6. So this is going 2s2 and 2p6. That means both are being completely filled. Both are being completely filled. This is being completely filled, and definitely this is also completely filled, my dear students. Both are being completely filled. Once both are being completely filled, then see to it gets 2 electrons, 2, 2, 2, 2, completely filled, fully completely filled. Everyone is with him. Now the question arises then, why this is more stable than this? Why this is having more ionization energy? This question arises or not? This question definitely arises. Who is along with that and who is along with this? So definitely out of this and that, the role of Z effective, its Z effective is very high and this Z effective is less. Gets everyone is able to understand Z effective, not only half filled, fully filled. Its Z effective is maximum. It's fully filled configuration. So this is having maximum ionization energy. It is having more Z effective but half filled stability, but Z effective is too much. 1, 2, 3, 4, 4 elements difference. Its Z effective is low but fully filled configuration. So this will be the order, and once you are able to understand this order, the element lying below this will have the same order. If I say the element lying below this, lithium, sodium, then magnesium will have more than that of aluminium, then silicon, then phosphorus will have more than that of sulfur, then chlorine, and then maximum of argon. The same order will be followed. This will have more than these two and this will have more than these two. Right kids? This point is clear to all of you. Is this point clear? Let me see in the chat section, my dear students. Everyone, is this point clear? I want to see that, kids. Is this point clear to each and everyone? Then I can move ahead. Everyone, do let me know. Wow, Niranjan, that's the good spirit. This is known as positive vibes. Kids, hit the like button. For the last number of minutes, it's at constant at 1k. I don't want to say 1k. Let it make it 1.1k, 1.2k. Why it is stuck at 1.1k only? Very good, very good. Thank you, Pavitra. Thank you. Swastik Patnaik. Okay. 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 Now let's see. Let's move ahead. Let's move here. Let's move here. In move here style, move here. Let's move here. Now see, kids. Now tell me, kids, tell me, if I write down elements, like if I write down, just see, if I write down one question, if I give you one question, let's see, let me check your knowledge. But before checking your knowledge, let me tell you the principal quantum number, that it was n. So n, how it is based on n? If I say that there is lithium, sodium, potassium, rubidium, cesium. So who will have maximum ionization energy? So the answer will come out. Definitely, this will have maximum ionization energy. As we are going down, the value of n is increasing. Its n is 2, its n is 3, its n is 4, its n is 5, its n is 6. What do you mean by this? Its n is 2, that means this is the nucleus. The electron is this much distance, outermost electron here. This is the nucleus. The electron will be this much away from the nucleus. Its n is 6, n is 6, that means its electron will be far away from the nucleus. This is the nucleus. 1, 2, 3, 4, 5, 6. Now once the kid is away from mother, this is the mother, parent, and the kid is away. Now which kid will be stolen easily? This kid or that kid, kids? Now definitely that kid is away, far away, can be stolen easily. It's easy catch, easy kill, easy kill. Somebody will come and easy kill, easy kill. Means less energy will be required, less energy needed. And here, not, it's a tough job will require more energy, will require high energy. Am I right, kids? Now, let me tell you S, what was that? That is penetration power. Penetration was penetration power. What do you mean by penetration power? Remember that. Have you ever eaten, what to say, castanut? What to call it? Groundnut or whatever the thing. If it is highly penetrated or something, some fruit to say, vegetable or whatever, which is going inside the earth. Now if you want to dig it out, if you want to put it out, if you want to make it out, then if it is more inside the earth, then it will require more force to bring it out. It's not easy job to bring it out. That the thing which is highly penetrated inside the earth, the tree whose roots have gone deep inside the earth, it is not easily going to go along with water during the flood time. That is highly penetrated. So who lies more nearest to the nucleus? I would like to say the maximum penetrated is S, then P, then D, and then F. This is the penetration power. This is known as penetration power. It's very tough to remove one electron from S, then P. So penetration power in this order. This is the order. Now let me tell you each and everything I've told you, kids. Now let me give you one question. If I give you one question, factors already I have told you. Factors, what were the factors I have already told you. Now let me give you one question and let's see whether you are able to apply that factor which I have told you, Z effective. The factor was Z effective, HSSPP. This thing I have told you, HSSPP. Let's see whether you are able to apply. Now arrange, question is arrange in decreasing order of ionization energy. Then I will give you one question of IIT. First you do this one. One is yeah, Al3 plus. Second one is Mg2 plus, or let me give you sodium, and then let me give you C, that what to say, Na plus. Now who is going to have maximum? Who is going to have maximum ionization? You just see this is having 10 electrons and this is having 10 electrons. So definitely they are having 10 electrons and they are having positive charge. So it's very easy to remove one electron from the sodium atom. So this is going to have least and this is having maximum atomic number. So maximum atomic number, that is 13. Electrons are same. So its Z effective is going to be maximum, and maximum Z effective says ionization energy will be maximum for Al3 plus, then for Na plus, and then the sodium will have least ionization potential. Now you are agreed with this order or not? Tell me. I want to see in the chat section. Everyone, are you agreed or not? Everyone, just to let me know. Very few topics are left. Don't worry, kids. Very few topics. Don't worry, kids. ACD. Yeah, absolutely correct. Wow. HSP and Sahana. Very good. Sausi. Kids, if your battery is getting discharged, do let me know. I will give you a break after telling you this ionization. After ionization energy, kids, after ionization energy, electron affinity is there, electronegativity is there, and bond-Haber cycle. This much only. Not too much, kids. Not too much. Kids, have water. Just say to yourself, kids, we never decide the duration. We decide one thing, the aim, the manjil, the goal, when it is going to get achieved. Don't see the time, kids. Don't think about the time, kids. Just see when you are going to complete it. See whether Baba is in hurry or Baba is teaching with the same pace. First of all, do let me know. The pace I have started with, is Baba telling you each and everything with the same pace, or the Baba's energy has gone down? Even Baba has not done the dinner, only have taken some cucumber, some apple. Same pace. Okay. You can take 15 minutes break after this ionization energy. I will give you. Or you need break right now. If you want, okay, let's do one question. Then I will give you one break, okay? First, let me teach you Z effective. See, factors affecting. I have told you about Z effective. Z effective is more, then the ionization energy will be more. Have I told you this? The trick I have told you, Z effective. Now see, in a period stability of half filled and fully filled, this also I have explained. Now see, stability of half filled, and see, nitrogen is better than oxygen, and IE2. This one just try to understand how this is more and how this is more. See, once nitrogen has donated one electron, then the nitrogen IE2, I2 means this will become N, this will become what? This will become N plus, this will become N plus, and this will become O plus. Now it will be having how many electrons? It will be having 7 electrons, and that will be having 6 electrons. So it will behave as carbon and that will behave as nitrogen. Are you getting my point? Now it will have half filled stability. It will get half filled stability. Are you getting my point? Half filled stability, then it will gain. It is going to attain half filled stability. Not able to understand. Are you able to understand this point? Everyone, you are able to understand this point? No, I don't think. Let me tell you. Suppose if I am having Na plus and I am having Mg plus, who will have more ionization energy? Either I will say its ionization energy is more. This statement I can use, its ionization energy is more. Its ionization energy is more. Or I can simply say that, second ionization energy of sodium is more than that of magnesium. Both mean same. You are able to understand or not? If not, then do let me know. Baba will explain once again. These 2 points mean same, because already they have lost one electron and this has acquired noble gas configuration. That means it's NS2, NP6 is there, but it's NS2, NP6, and then NS1 is there, and the same thing is here. Here you will use second ionization energy, and here you will say simply ionization energy. These two things mean same. If you say like that, you have to come at to this point only, my dear students. Are you getting my point? I hope yes. Now, next point. See, factors affecting penetration power of subshell. SPDF. Beryllium is having S and that is having P. Just see, its atomic number is 4, its atomic number is 5, and this is decided by C, 1s2, 2s2. It is having 2s2 electron. This is having just 1s2, 2s2, and it is having in 2p1. So just if the atomic number difference is 1, this penetration power will work only for the adjacent element, not for everyone. Just see, the S is having more penetration power than P1, and this was same thing was working in that nitrogen was having more than that of oxygen and more than that of what? On that carbon also. So this the penetration power. This is the role of penetration power. Now see what I am going to see, SPDF, and here also same thing. Now, ionization energy is inversely proportional to atomic size. Baba has already told you the trick that ZAF is having what? HSPP. So where is HSPP? Atomic size. So this is size only, size. So already I have explained it. Now see, comparison of ion across the period. This already I have explained. See, due to penetration power, due to half filled. See the slides, kids. Can you appreciate Baba's efforts? So much efforts Baba has added, kids. Will you appreciate, really appreciate, kids? How much, kids? The trick HSPP, IP. To find out IP, HSPP. To find out IP, JFAB, HSPP. Kids. HSP. Sachin. Sachin, Neha, Neha, HSP, 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 HSP. Now see kids. Now see kids. Now, each and everything Baba has already explained. Now see the ionization energy. Just see kids. Wow. Baba has taken NCERT pick. NCERT pick kids. NCERT. See. Libe, lithium wave. So see, beryllium is having 899 kilojoule per mole. Kilojoule per mole. So beryllium is having 899, but boron having 800. Now see, it's rising 1402, and neon is having 2080. So it's going up, coming down, going up, coming down. Here penetration power, due to penetration power, and this is NCERT. It's written in NCERT only. You are enjoying it, kids? Really enjoying it? Sausi is thinking about Baba. Sausi is thinking about Baba. Thank you, Sausi, Sahana, Jyoti, Kushiga. Baba gets energy from you people. Once you are, yeah. That I will tell you later on. Right now, I don't know what I will teach. Whatever Basim sir will say, I will teach. After teaching you ionization energy, Baba will give you break. Okay? Okay, kids? Now, kids, but why the likes got stuck at 1K? I can't understand. Everyone just try giving me, smash the like button. Let's see whether it's going to become 1.1K or not. Just see kids. Smash the like button. No need to remember. No need to remember delta H. No need to remember. Just I have told you the order. The order should be there. Order. No need to remember the values. Now see kids. This one is really the most expected question. As we know that it's the number of N is increasing, then the ionization energy is supposed to decrease. But see, this is expected order. But this is the reality. Reality versus expectation. Bottle garden all India. Remember that. And why the change is there? How thallium is there? Reason is lengthenoid contraction. I have told you that time that lengthenoid contraction will make history. Lengthenoid contraction will make history, and history has been made. And see, the gallium and indium is there, thallium is there, everything. So remember the trick. Bottle garden all India. The trick is bottle garden all India. Bottle garden all India. Bottle garden all India. This is the trick. Baba HSP trick. This is most frequently asked question. Remember that. This is the most frequently. And now this 3D is more than 4D, but 5D. See the size I have told you. Tizer, half rough, Tizori, half on roof, and Tizer, half rough. Hafnium is having maximum because of lengthenoid contraction. Once again, lengthenoid contraction is the reason. Lengthenoid contraction is the reason. Lengthenoid contraction. Now, So see, 3D is also having more than 4D and 5D is also having more than that. Now, application of ionization energy, metallic and non-metallic. Non-metal was Champa. Champa want to snatch electron, and metals are donor. Metals are rich. So remember that in this world, somebody is electron donor and somebody is electron acceptor. Non-metals, they always are need of, they are stingy, they are kanjam. Non-metals are kanjam. You know kanjam? Non-metals are kanjam. What do you mean by kanjam? In Tamil, kanjam means stingy. Stingy means conjuice. Stingy, kanjam means conjuice. In Hindi, this is known as conjuice. They always want to snatch electrons, and metals, they are donor. They want to donate electrons. So they are donor of electron, and they are being gainer of electron. So metallic character is inversely proportional to ionization energy. Less is the ionization energy, more easily it can donate electron. Definitely less is the ionization energy, more easily, Sana, thank you, more easily it can. And this word I have come to know through Sahana only. Sahana only told me this word. Now, reactivity of metals is directly proportional. Means if less efforts are applied to take out electron, easily the electron can be donated. Now see, this is very, very important. Stability of oxidation state. No one will tell you this thing. No one will tell you. This point holds a hell lot of weightage. Now how to remember it? Let's see kids how to do it. Just see. Remember that stability of oxidation state. Which oxidation state is more stable? You will study in redox, D block, coordination chemistry, everywhere. Remember that if the difference between two successive ionization energy of element is equal to or greater than 16 eV, you know how the ionization energy is measured. First of all, let me tell you the measuring of ionization energy. Kajol, remember that kajol, what is kajol? Kajol's urge with EB. Kajol urge with EB. What do you mean by this? Kajol's urge with EB. This means kids, this is bigger unit, and the meaning of this is kajol, you know, heroine, calorie. This is calorie, and this is joule. This is being joule, and this is ERG, and this is 1 EV. How to interconvert? 1 calorie is equal to how many joules? 1 calorie is equal to 4.18 joules. Am I right, kids? And 1 joule is equal to 10 raised to power 7 ERGs. Am I right, kids? And 1 EV is equal to 1.6 into 10 raised to power minus 19 joules. Is everything also okay? So you can calculate the ionization energy in these energies. You should know. You should know, kids. Is it clear, kids? Is it clear? Is it clear? Is it clear to each and everyone, kids? Do let me know. Is it clear? Are you able to understand this point, my dear students? Just to let me know. Everyone is able to understand. Wow, kids, that's really fantastic. Really fantastic. It's really awesome. It's really awesome. Now see, kids. Now, yeah. This is the bigger unit, and this is being the smallest. This is being the smallest one. This is being the smallest, and that is being the biggest one. This is being the biggest one, right? Biggest, smallest, and biggest. Now what Baba was telling you, kids. Now Baba was telling you something. Yes. if the difference between two successive ionization energies of an element is equal to or greater than 16 eV, then definitely somebody will come and say, oh, please, I don't want to take your extra electron, you keep with yourself. Then its lower oxidation state is stable. Why? If you are going to do something, then you will say, oh my God, this is requiring more time, more energy, then let's leave it. I don't want to do that. I don't want to do that. Then what will happen? Then he will say, okay, whatever the lower oxidation state was there, it's okay. Now see, sodium and sodium plus, right now I have explained, now sodium wants to convert into sodium plus easily. This has happened easily. Now sodium plus to sodium 2 plus, the difference in the whatever, suppose its ionization energy is X and its ionization energy is Y, and the difference is 42.7 EV. 42.7 EV is greater than 16 EV or not? Yes, too much greater than. Then you will say, okay, your +1 oxidation state is stable. You will never form Na2 plus. You will never form 2 plus. You will remain in this form. Suppose if this would have been a smaller difference, then he must have taken out the second electron also. Now see, kids. If the difference between two successive ionization energies of element is less than 11 eV. Now, before going to 11 eV, you will say, sir, what happened from 11 to 16? That is LOC. No idea. No one is having idea whose boundary is that, what he is going to do. Uncertain brain. More than 16 eV, then the first one is stable. If this much energy is required, he will say, okay, 11, so I will give 11. Now, do you know anything you want to buy with 11 and 16? Anything? Chocolate or whatever the thing? Can you correlate it with? Okay, so it's now see, magnesium can easily donate 1 electron, and the second electron, the difference is just 7.4. Then he will say, okay, let's take your this oxidation state, let's catch your second electron also, let's take out your second electron also. Now its magnesium 2 plus oxidation state is stable. Now see, here is the question, here is the question, just try to answer it. Let's check it out, who is going to answer it. Now let's see to it. Who is going to answer this question? Who is going to answer it? Let me check it out, who will answer it. Kids, who is going to answer it? Baba is waiting for your answer. Everyone, just to let me know, kids. I want to see the answer. Everyone, Shivam is giving A. Shivam has given the answer as A. Now let me check it out. Others. Everyone is giving answer as A. Saucy is going for B. A and B, kids. A and B. What is going on, kids? What's going on? Now let's see. Kids, even Baba wants to do this question. Let's see what the answer will come. What's the answer is going to come. See, kids, see. IP1, ionization potential 1, 2, 3, 4, 5. Where is the gap? Where is the large gap? Can you tell me where is the maximum gap? 7, 14, 34, 46, 162. This is the highest gap. This is being the highest gap. Can you see, kids? That means here the noble gas configuration has come. Noble gas configuration has come. Noble gas configuration is. Then this must be alkali, this must be alkaline, this must be third, fourth, Who is lying in the fourth? Definitely B is going to be the answer, silicon. Now, how many of you are not able to understand? How many of you are not able to understand? Let me tell you. This gap, too much gap is indicating what? Too much gap is indicating that this is noble gas configuration. Noble gas configuration. Before noble gas configuration, this must be alkali configuration. This must be alkaline configuration. And before that, this must be third A element configuration. And this must be fourth A. Now, in fourth A, which elements are there? Carbon, silicon. In the fourth A, there are carbon, silicon, germanium, tin, lead. So the fourth A, this only one element is getting matched. I hope that everyone is able to understand. Now, this one. Let's see who is going to answer it. Who is going to answer it correctly? Kids, see. Answer it. Let me check it out. Who is going to give the correct answer? Baba is waiting for your answer, kids. Baba is waiting for your answer. Everyone do let me know who is going to answer it. Everyone call your friends. I think now they must have taken a sound sleep. They must have taken a sound sleep, kids. At 2 I will give one break, kids. At 2 I will give one break, kids. Small break I will give, but don't sleep. Okay. B. Maximum kids are going for B. Which of the following has second IP less than the first IP? Second IP less than the first IP? How is it possible? How is it possible? It's not possible. Hey Baba, Hudi Baba. Second IP can never be less than, can't be less than. Hey Baba. Can't be less than, can't be less than, can't be possible. Second IP can't be less than. So none of this is not possible. Can't be less. Can't be less means second IP can't be less than first IP. First IP. This already I have told you, successive IP. So this is the correct answer. Whatever the ionization potentials are there, they will always be more than. For example, if I say IP4 will always be greater than IP3, will always be greater than IP2, always greater than IP1. But my dear friends, some people are getting confused. Should I tell you where you will get confused, where you will do mistake? Let me tell you. Suppose if anyone is saying there is magnesium. Magnesium is 12 atomic number, 282. One electron has been eliminated out. Now you will say, okay, it is 281. Now you will say, okay, sir, that now it can easily donate one electron. It will easily donate one electron. And this IP, this is going to get noble gas configuration. Hip, hip, hooray. So you will think like that. To get noble gas configuration, this is less. No, never. Whatever the configuration is there, IP2 will always be greater than IP1. Ask me why. The IP2 will always be greater than, this will always be greater than, this will always be more, because Z effective increases here. 12 proton, 12 electrons. Here 12 protons but only 11 electrons. Z effective increases. Mg plus Z effective will be more than Mg. So definitely successive ionization energies are always more. Successive will always be more. Will always be more. Will always be more. Are you getting my point? Will always be more. This point is clear. That's example is clear to all of you. Everyone, are you getting my point? Everyone, just to let me know. Let me check it out in the chat section that everyone is able to understand. My dear friends, show me the green hearts, green hearts, green hearts. If everyone is able to understand, I want to see in the chat section, my dear friends, everyone. If everyone is able to understand, just to let me know. Just let me know. Just let me know. Just let me know. Just let me know. La 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 la. Just let. Right now. Just after 6 minutes, I will give you a break. Just after 6 minutes. Wow, Sausi, Nighat, Niranjan, wow, Vikas, SKS, Tamil Gaming, wow, my dear students, really awesome, really awesome, really awesome. Now, kids, now everyone is able to understand. Now, let's see. One question was, oh, yeah. AIPMT 2009. Let's see what answer you are going to, what answer you are going to give, kids. Let's see. Let me check it out. What answer you are going to give for this question, bro? Amongst the elements, which of the following electron configuration will have highest ionization energy? Hey everyone. Shivam Mishra, wow. That's really fantastic. That's really fantastic, kids. Do let me know. HSP. What's the correct answer? Do let me know what's the correct answer, kids. I want to see what's the correct answer. Some are going for C, some are going for A. I want to check it out. South C is saying C or D. C or D. Let me know. Let me check it out. Everyone is going for C. Most maximum students are going for C. Let me check it out. What's the correct answer? Why this is the correct answer? Just see. Just see. This is to having how many shells? Argon. Argon, where is argon? Helium, neon, argon. And argon, that means first, second, third period, and whatever the element is there, that is belonging to fourth period. This is in fourth period. Definitely N is 4. Can't be the answer. More the value of N, less will be the ionization potential. Neon 2, so it is N is 3. N is 3. Neon, so it is N is 3. Now it is having half filled stability. It is having half filled stability benefit. It is having half filled stability benefit, and that's why it is the winner. That's why it is being winner. Now, applications of ionization energy. Yeah, this question I was talking about, this question, and this is of IIT question, and there are the options. Let's see. Who is going to do this question? After this question, I will give you one break. I will give you one break. This is the question for which I was waiting, kids. This is that question. This is that question, kids. I was talking about. Let's see who will answer it. Z effective. More the Z effective, more is the ionization energy. Half is directly proportional. Half is Z effective is being directly proportional to ionization potential. Yes, kids. Tell me, what is the answer? What is this, Baba? This is question. This is question. This is the question. Very good question. Okay, let's solve. We will solve this question after this break. Okay. Okay. 15 minutes break. 15 minutes. Just 15 minutes break, kids. Okay. 1-5. Okay. 15 minutes break, kids. We will solve this question after 15 minutes break. Okay, kids? Okay? Okay? But come with fresh mood, fresh mind. Till now, you have shown your really good energy. Baba is over here only, but I have given this break for you, kids, right? Just energize yourself. Even Baba is going to do that, right, kids? Okay? Okay? Will you come with the full on energy, kids? Make a promise that you will come with full on energy. Hey everyone, Baba is here. Just to let me know. Are you back with the full on Josh? With full on energy, kids? Now, if yes, then do let me know what is the answer of this question. I want to see. Your Baba want to see what is the answer of this question. Who is going to tell me the answer of this question? I want to see the answer of this question in the chat section. Are you with full on Josh? Are you feeling fresh with full on energy, kids? Welcome, welcome, welcome once again. Very, very good morning. Baba want to say once again the good morning. Welcome, Unacademy, Chowale Sunayal, Sastrikal, Walaikum Salam. This is your Baba HSP. Once again with the full on energy, I want to see the answer. Now, should I explain it or you are going to give me the answer of this question? Yes. Kids, do let me know. Should I explain C? Okay, C. Most of the students are going for the C. Even let me check it out. Why you want to say C? Okay. There is some element, value of n, and n is less than 10. That means less than 10. So you see, the first ionization energy is like this, second, third. Which one you can see the highest jump? If I talk about this one, 738, 1451 and 7738. This is very high jump. Can you see? Very high jump. This is very less, very high jump. So can I say that noble gas, before noble gas, alkali, and before alkali, alkaline earth metal, but it can't be alkaline earth metals. Okay, can it be? This jump, what to do? I am unable to understand. Okay, let's see. What to say, kids? How to do this? Baba is unable to understand. N plus 1, N plus 2, N plus 3. Oh my God, unable to do it, kids. Oh yes, it is having maximum ionization energy. Then also I am unable to do it. Now, what should be the value of n we should take so that the work should become comfortable and easy job? Now see, here is too much jumps. That means this, if I say this is a noble gas configuration, and noble gas configuration before that, this is alkali. Oh my God, Baba is unable to understand. Kids, I am unable to do. Are you able to do it? Baba can't do this question. Let's see what answer you people are going to give. Baba is unable to do this. Kids, you are not giving the answer. Baba don't know how to do this. Kids, how to do this question? Baba is unable to understand. Kids, no clue. I am getting this clue. This is noble gas configuration. So this is alkali metal. This is alkali metal. So this will be the alkaline earth metal. Alkaline earth metal, that means plus 3. Alkaline earth metal plus 3 and plus 3. So what that element should be? Alkaline earth metal means its atomic number must be what 3. Alkaline earth metals, beryllium. No, it's not beryllium. So what it could be, kids? No idea. It's looking very tough. Is there anyone who has done this question? Let me check it out. Is there anyone? Leod Naflon can't understand the question. Oh my God. Let's see, kids. Do let me know. No one, Baba, I can't understand. No one is able to understand this question, kids. This question is looking very tough then. Then let's see who is going to solve it. Baba, as in case of n plus 2 is very less, means it's removed from first. N plus 2 is very less. Yes, you are right. Who is this kid Who is this kid who has told me the very good one? Wow, that's really fantastic. Kids, who has given this answer? Very good. Somebody has given this answer that it is very less. It is the least one. It is the least one. It is the least one. And the least one is indicating that he is alkali metal. Now, alkali metal, if it is being alkali metal, N plus 2. What is the meaning of N plus 2? They are asking for N plus 2. That means 9 plus 2 will come out 11. If I take N to be 9, then 9 plus 2 will come 11, and then this will become alkali. Okay, let's see if this is going to become alkali. If I say N is 9, let's see. If N is 9, then N plus 3 will become 12. 12, that means 12 will be the magnesium. Magnesium, one electron removed, then it will become alkali, and then this will become 0 group, and then 0 group is going to be the maximum one. So it's working. What do you think it's? I think it's 9, C1. I think. What do you say? That is 9. I will say 9. Then 9 is fluorine. Fluorine, 1 electron taken out. Why this jump will be there? If this is fluorine, this is going to be fluorine. So Baba is thinking for C. It's what do you say? Baba is going for the C1. What do you say? Let's see. The answer, yay! Yeah, 9 is the correct answer. Have you got it, or should I explain? Kids, let me see in the chat. 9 is the correct answer. You got it, or should I explain it? Just to let me know. Everyone, just to let me know. You got it, or should I explain it? You got it, or should I explain? Everyone, just to let me know in the chat section. You got it, or should I explain? I want to see in the chat section. Everyone, just to let me know. Wow, Sahana, thank you. Now, just to let me know. Lafia, oh my God, I got it, Baba. Please explain, Baba. Okay, see. If I say that atomic number 9 means what? 9 means what? Who is having atomic number 9? Fluorine is having atomic number 9. So if I say that Z is 9, now 9 plus 2 will become 11. This will become sodium. Now sodiums belongs to one group, 11 atomic number 1A, that it is having least ionization potential. So this value is indicating that this is least IP, right? And now once, 9 plus 11, yeah. So you will require less. Something is looking. 9 plus 2 will become 11. Yeah, 11, that is okay. 11 will have least ionization energy. You have removed one electron, then the jump will be this much. Okay, jump will be this much. Yeah, this is too much gap. You see here, this is too much gap. That means Na plus is having noble gas configuration, and that's why it is requiring this much of energy. Now see, 9 plus 3 is magnesium. Magnesium atomic number is 12. Once you have removed one electron, it will become Mg plus. Mg plus, now if you remove one more electron, it will become Mg2 plus. Now it's noble gas configuration, and noble gas configuration means it will require too much amount of energy. Now see, if I write 9 plus 1, 10, so it will be neon, and neon is already having noble gas configuration, and noble gas configuration means high ionization energy, very high ionization energy, and this is 9 itself. So you can see very clearly. And one more thing I would like to say, this is 9 and after 8 and like that. Simple question. Everyone, I hope that everyone got it. If yes, is it clear? Show me the green hearts. Let me see the chat section if it is clear to each and everyone. Everyone, just to let me know. If is it clear to each and everyone, show me green hearts. I want to see kids that everyone is able to understand it or not. Everyone, just to let me know. If not, then Baba will explain once again. Definitely Baba is going to explain once again. Everyone, just to let me know. If yes, show me green hearts so that I can understand that everyone got it. Yes, everyone understood. Now, kids, let's move. Let's move to yes. One more question. You will enjoy, kids. Today you will enjoy. Just see to it. Just see to it. Another question. Baba means Baba, kids. Quality, content questions are there. Baba cannot compromise. Okay, Sri, definitely. But see to it, kids. This question, just try to understand. Are you able to understand this question? Just see. Let me read it out. There is table that you can see clearly. First read the table, then I will explain what's written below the table. Shivam Misra, okay. Now read out, kids, read it out. Then I will explain the A, B, C and D. First you see the table. What is written in the table? Okay. Oh, Vasundhara Bose is going for even for options C or D. Wow. C or D, my God. Rest of others, while they are reading it out, some people are going to give answer of this question. Now kids, Baba is going to explain it. I don't think that you people are able to answer it. Oh, I am getting Medico is giving D. Some are going for C, D. Let's see what should be the correct answer. Just see. Element A and B, ionization enthalpy 1, 2, 3. Now there is a large gap. So definitely this is having noble gas configuration. This large gap is indicating that this is an indication of noble gas configuration, noble gas, then alkali, and then alkaline earth metal. So definitely this is going to be alkaline earth metal. And here large gap once again, but not that much, kids, not that much. So what it can be possible, this gap is okay. So what to say? Not able to understand which element it is going to be. This ionization energy is more and their gap is more, A and B, and they're talking about belongs to group 2 or belongs to group B. A and B belonging to group 2. Group 2 means beryllium, magnesium, calcium, strontium everywhere, or belonging to group 1. So group 2, group 1, group 2, they are talking like this only. So A and B definitely one electron. If they are in one, then after leaving this electron they should have electronic configuration. So A and B both belongs to second group. One point is clear, they cannot belong to first group. Why? if they would have been belonging to the first group, after the first ionization potential, the jump for the second will have been, that would have been the maximum one, but they are having the third jump maximum one. So both of them, they are belonging to second group. This point is very clear that both of these, because this jump here and this jump here, this is maximum. These two jumps are indicating that definitely after releasing two electrons, they are going to get this. So this one second and this one, this is having more, that means this is the upper one, this is the upper one, and this is the lower one. This is the lower one, definitely upper one, lower one. So which answer? These two answers not possible. B cannot be, C cannot be. Now C, both and B belongs to group 2, where B comes below A, where B comes below A, right? So I would like to go with D, because where A comes below B, if A would have been below B, then it should be lesser. That even that cannot be the answer. I will go for D. Agreed? Are you agreed for D? Let's see. Baba is going for D, whether D is correct answer. D is correct. Solved it. How was the question, kids? Do let me know how was the question. This is also question of IIT JEE Advanced. Why Baba is giving you such type of questions? Because this time the paper, definitely that will come on the tougher side. You are enjoying it. First of all, if you are liking it, kids, do let me know. Baba has solved this question easily. You can do it, kids. Everyone, just do let me know. Are you really enjoying it, kids? This question is really awesome, kids. Okay, now let's move here. Electronegativity. First of all, let me give you trick of electronegativity. Electronegativity trick, HSP Baba's trick. Now only half an hour we are going to bind it up, because it is going to get completed, kids. Definitely it will get completed. Now see, Fox chilled NBRI, Fox chilled NBRI with Supreme Court's horsepower. Fox chilled NBRI with Supreme Court's horsepower. How is the trick? Fox chilled NBRI with Supreme Court's horsepower. Now, this is Fox chilled NBRI, National Botanical Research Institute, with Supreme Court's horsepower. Now kids, the electronegativity of fluorine is 4. F for fluorine. Oxygen is 3.5. This is 3.19. This is 3.00. Bromine is 2.6. Iodine 2.8. Bromine is 2.8. Iodine is 2.6. Sulfur and carbon, they are having 6, 2.5, and they are having 2.1. Now, one more thing, how to find out the electronegativity. Let me tell you, kids. Here only, if I tell you that carbon, nitrogen, oxygen, fluorine, and below fluorine it's chlorine, then here oxygen, sulfur, and here phosphorus, then carbon, below carbon is silicon, right? So we know very well The electronegativity of carbon is 2.5. Just keep on adding 3. Just keep on adding 3.5. Just keep on adding 0.5. Add 0.5, 4.0. And this is 3. You can consider 3 minus 0.5, 2.5. Now a difference of 0.3, 2.5, 2.1. Then subtract 0.3. So it will come out 1.8, and then keep on moving. This is the way to remember the electronegativity. In this way you can easily remember the electronegativity, no problem. Now see kids, this scale, electronegativity scale, Mulliken scale, this point to be noted, my lord, that X is indicating electronegativity, M is standing for Mulliken. He has given that ionization energy plus electron affinity. I will explain electron gain enthalpy. That keeps really, it holds a hell lot of weightage. Without that, the periodic table is not going to get completed. Now, ionization energy plus electron affinity divided by 2. And remember that Mulliken scale and Pauling scale relation is that multiplied by 2.8. It's 2.8 times more than Mulli, Pau. Mulli and Pau. Mulli is always better than Pau. Now, kids, do you know anything to eat with M? M, so that we can make one trick. Anything starting with M, so that mango, yeah, mango is always better than Pau. Mango will give you more energy. So electronegativity of Mulliken is always winner than Pauling. Pau, 2.8 times more. Now remember that in EV, if you are going to calculate, you have to divide by 5.6 and kilocalorie per mole. Then you have to multiply 2 into 64.5. Generally, they are not going to ask, but by chance if they are going to ask, you should remember it. You should remember it. Now, another one, Allred Rocco. Allred Rocco said, I want to calculate electronegativity on different scale. They have used effective, Z effective. Now see, he said Allred, AR, electronegativity of Allred Rocco. See what type of names, Allred. So I have kept over there red mark, red box. Baba has designed red box, Allred Rocco, Allred Rocco. So Z effective square upon R square. Remember this, sometimes they are going to ask this one, 0.359 Z effective upon R square. So this formula is there. And one more, Shoemaker and Stephenson's. I have told you Shoemaker and Stephenson's, DAB, RAB plus RB minus 0.09 into electronic difference. We have done one question also on this. So this we know very well. Now, my dear students, let me tell you about electron affinity. So let me tell you about electron affinity, so that we can complete electron affinity. Let me teach you electron affinity. Electron affinity. This is very, very important because you will lose your marks in this only. So electron affinity. Electron affinity. Electron affinity. And I would like to say, kids, this electron affinity, better word than electron affinity. People are using this electron affinity, but this is not good word. Why it's not good word, I will let you know. I will let you know. Just wait for some time. Baba is going to explain it, but better word than this electron affinity, Baba will tell you. What is that? Better word than electron affinity is Negi. Just remember Negi. What is Negi? Negi is negative electron gain enthalpy. Negative electron gain enthalpy. It's a better word than that, negative electron gain enthalpy, and I call it Negi. In shortcut, Baba call it Negi. Negi. This is thermodynamically most important word. Thermodynamically, this is the correct word. Thermodynamically It is the correct word, correct one. Negative electron gain enthalpy. And kids, let me tell you, number of people they are going to give negative electron gain enthalpy. Negi is negi E. Negi. It's negi, negative electron. Negative electron gain enthalpy. Now see, what is that? Suppose if I say there is chlorine gaseous, its electronic configuration is 287, 17, atomic number Z is 17, so it is in need of one electron, and it has gained one electron, and once it has gained one electron, it will turn out to be Cl negative gaseous, and it has acquired noble gas configuration. Now see, whenever the bonding is going to take place, whenever something is getting bonded, energy will always release. Remember that energy is required to break the bond, but whenever the bond is getting formed, always energy will get released, and that is going to be exothermic process. So either I can write that energy over here, either I can write it like this, or the second way of representation of this equation can be like this. Chlorine gaseous, one electron has been taken by this, and I can write down Cl negative gas, and it will form 288, and the best way is to write down at delta H negative. This energy which has been released is known as electron gain enthalpy, and people call it electron affinity. But electron affinity and electron gain enthalpy, they are not the same. I will let you know later on, but this is what I am going to tell you. Now, my dear student, just see to it. There is one fluorine atom. There is what, first of all, this chlorine, let me complete the story, otherwise you will get confused. This chlorine has absorbed one electron. This was gassium. After taking one electron, it has become Cl negative, and I said the energy released is being electron gain enthalpy, that negative electron gain enthalpy, and this reaction is totally exothermic, right kids? This reaction is what I would like to say, it is being totally exothermic reaction. Exothermic means delta H is negative. Now, my dear students, once it has gained electron and its configuration has turned out to be 8 noble gas configuration. Now, once you were hungry, you were starving, you have taken too much amount of food. Now you're full on stomach. Now if anyone is saying, hey Champa, eat this chapati. Champa, have this chapati. Now tell me, Champa is going to have that chapati or not? Stomach, full on stomach. Champa is having noble gas configuration. Now do you have any idea that Champa is going to eat this extra chapati? Do you think that Champa is going to eat this extra chapati? The answer is no. Champa don't want. Now, remember that if you want to do that, the extra electron will repel this electron. The extra electron which is already present, this extra electron will apply force of repulsion. Too much repulsive force of repulsion will be there, and this will not allow to take this place. And if you want to do this, you have to supply energy, and the supplied energy will be more than the released one, whatever the energy has been released. Suppose if I say this energy was equal to X kilojoule per mole. If I don't consider the sign, only magnitude, then whatever the energy allowed to spend, this is endothermic. I will say this is endothermic. This, if I just consider the magnitude, don't care for the negative sign or positive sign, then this supplied energy will be more in amount than released. This is endothermic. This is being endothermic. You have to supply energy, and this supplied energy will be higher than, will always be higher than released one. So what sense you are getting from this? What type of sense you are getting from this? That if I add these two energies, then who is going to be the winner? The plus sign will be the winner, or negative sign is going to win? Do let me know. Whose magnitude is more? The plus sign's magnitude is more, or the negative signs? Which magnitude is more? Definitely this is more. So the positive energy is more than the negative energy. So if I add these two, and if I write down like this, Cl gas, and I'm going to give 2 electrons to make Cl double negative, so the delta H will always be positive. Why positive? Because the required energy was more than, so it will always be, second electron affinity will always be endothermic. Remember that whatever the element is there, second electron affinity will always be endothermic, endothermic. So the overall process will become endothermic. Are you getting my point? Let me check it out in the chat section. Kids, are you able to understand? If yes, show me green hearts in the chat section so that I can understand that you are able to understand it, kids. Everyone show me the green hearts, what I'm going to tell you. Then I will tell you the fluorine and chlorine case, each and everything Baba will tell you. Second electron affinity will always be endothermic. What Baba has written. Now let me tell you, my dear students, one thing. Let me compare very important point. Very important points. Let's suppose that fluorine is ant. Let's suppose fluorine is ant. Let me draw ant, how it will look like, how the ant will look like. Let me try to draw ant. I don't know how to draw it, but let me try. This is the ant. And if I say chlorine is elephant. Now, ant was hungry for the last 4 days. Ant was hungry for last 4 days. Elephant has done breakfast. Now, what do you mean by this? Is this story fake story, or is it having some relation? Now, my dear students, there is one thing, electronegativity, and another thing is electron affinity. Let me tell you the basic difference in between these 2 points. Electronegativity means the temptation towards electron. Electronegativity means what's first? Let me write down over here. Electronegativity means temptation towards electron. Electronegativity means affection. Electronegativity means love for electron. And electron affinity means, I will define electron affinity after some time. Electron affinity means the energy released when extra electron is gained. Extra electron has been gained. This is the energy release, and that is just the love for electrons. That now, who is, suppose here the electron is like pizza. If I say this is pizza, one kg pizza, just to let me know who is more hungry, because its hunger is 4.00. Fluorine is more electronegative and its hunger is just 3. So electronegativity is hunger. This is hunger means electronegativity. Electronegativity is hunger, starving. Now kids, who will eat more pizza? Just to let me know. Elephant has done breakfast right now in the morning. Ant is hungry for the last 4 days. Who will eat more pizza? Just to let me know. Who is going to eat more pizza? Kids, do let me know. Who is going to eat more pizza? Oh my God, Hassan Abbas. Tell me, who is going to eat more pizza? Just to let me know. Kids, everyone, just to let me know who is going to eat more pizza. The fluorine ant or the chlorine elephant? Elephant, yes. Size matters a lot. The point comes into the rule, size matters a lot. Size matters a lot. The point which comes into the picture, size matters a lot. Now eating pizza means electron affinity. Once somebody is going to eat electron, whatever the amount of energy is getting released. So now the point comes, although the electronegativity of fluorine is more, but the electron affinity of chlorine will be more. Now let me take another page and let me write down this line. Let me write down these golden words. Although, what golden words Baba is going to write? What golden words Baba is going to write? Although what? Although electronegativity of fluorine is more, $1 million question, fluorine is more than that of chlorine, but then also electron affinity of chlorine is more. Right, kids? Am I right? Now what's the reason? Let me write down the values also. I don't know whether the values are right or wrong. You have to search for this. The fluorine and chlorine's electron affinity. Baba is trying his best. Chlorine, I am sure. Chlorine is minus 349 kilojoule per mole. I am damn sure. This one though I know very well. So fluorine, hey, same. How much is for fluorine? Same. Where are you, Champa? Champa, what's the electron affinity of fluorine? 325. Are you sure? Yes, sir. Okay, Champa is saying, so let me write down. Fluorine is minus 325 approximately kilojoule per mole. Anyone? You are going to check it? Just do chat GPT. Am I right? Anyone? Please do chat GPT. My values are right or wrong? Just do let me know. Do chat GPT and do let me know. Am I wrong, right or wrong? Do let me know. Am I right or wrong? I have written the values. Whether Baba is right or wrong. Do let me know, kids. Chat GPT, Wikipedia, whatever you want to do, you do it and just do let me know. Yeah, I'm trying, Shibam, but I cannot move like this. The values means a lot. Then only Baba can write anything. Hassan Abbas is saying right. Yeah. Now see. Why this? Yeah, wow, very good. Thank you. Now see to it. In fluorine cannot take extra electron easily. Fluorine can't take extra electron easily because of inter-electronic repulsion. Assertion and reasoning question will come. Inter-electronic repulsion, whereas chlorine will take, and this is the reason, kids, this is the reason. Now let me tell you, my dear friends, one point very clearly, that if I talk about nitrogen, oxygen, fluorine, these are the second period elements. My dear friends. These are the second period. I am talking about period. Second period elements. And if I draw the third period elements, just below them, the third period elements just below them, nitrogen, phosphorus, oxygen, sulfur, fluorine, chlorine, then remember that the size of third period element size is too much. I can say this is bigger and they are very small. Even whatever their expected size, they are even smaller than that. Very small in size. Very small in size. So due to very small in size, whose electron affinity will be more? Electron gain enthalpy, phosphorus, then sulfur will have more, then chlorine will have more than this. Remember that this will be the order. Am I right, kids? Am I making sense? These are the order for what? Electron gain enthalpy. Now, my dear students, let me tell you, let me compare these two and this I would like to say that these values will be approximately 0. Why these values are approximately 0? Approximately 0 electron gain enthalpy. Now question arises, why? I will tell you. And there they will be negative. In these cases, electron gain enthalpy is being negative. For these elements, electron gain enthalpy is negative. Now the reason, once again, same kids, remember that the one who is having fully filled configuration or half filled configuration, such type of elements, they don't want to gain electron. Note to be noted, my lord, brilliant note, will change your life. Elements with fully filled configuration, like noble gases, 18th group elements, and second group elements with fully filled configuration and half filled configuration. Do not want to accept. Electrons easily. So their electron gain enthalpy is positive. So I would like to say delta H will be positive, endothermic. Delta H is positive, and that is endothermic reaction. Endothermic. It's being endothermic. Now, if anyone is going to ask what's the relation between electron affinity and electron gain enthalpy, just try to find it out. It's given in NCERT, the relation between electron gain enthalpy and electron affinity. Who is going to tell me? Just find it out, kids. I want to write down the relation in between electron gain enthalpy and electron affinity. So everyone, let's see whether you are having that much of energy or not. Everyone, just to let me know what is the relation between electron gain. Find it out. I want to see that who is going to search for it. And fast kids. Everyone fast, we fast. Fast kids. I want to see the relation. Who is going to tell me, kids? Don't say bye. Write it down. Baba will tell you. Kids. Don't say bye. Just wait. Electron gain enthalpy, my dear friends. Electron gain enthalpy. It is written like this: delta H. It is written like this is equal to minus of electron affinity. It is written like this: minus 5/2 RT. If anyone is going to ask the relation, remember that this is the relation, kids. It's given in NCERT. I'm not telling you that I'm telling you very hi-fi something. This data has been already given in the NCERT. This data is given in NCERT. I'm talking about this data of NCERT. Now, my dear students, if you're able to understand this much, now I will give you one question, and that question will definitely allow your mind to think about it. See, kids. Baba is going to talk about one question, and definitely that question will say, oh my God, such a great question. See, kids. If I say that if we go down like this: lithium, sodium, potassium, rubidium, and cesium. we will say that the ionization energy is in this order. So who is having least ionization energy? Definitely the answer is cesium will be having least ionization energy. Now if I ask you who is the best reducing agent, the thing is that who is the best reducing agent? My question is, who is the best reducing agent? Do you understand reducing agent, kids? A reducing agent, the one who is having maximum standard oxidation potential, having more standard oxidation potential, am I right? Having more standard oxidation potential. Am I right, kids? Am I right or not? SRP value, this we call it SOP value, standard oxidation potential, means who can easily lose electrons. So these two things are contradicting or not? Reducing agent means the power of undergoing oxidation. The one who is reducing agent will undergo oxidation, oxidation only, and oxidation means loss of electron. This means loss of electron. One side we are saying that lithium is the best reducing agent. We call that, everyone knows very well that lithium is best reducing agent. You must have studied in the electrochemistry also. And second side we are saying cesium is having least ionization energy. Least ionization energy means can easily donate electron, maximum metallic, can easily lose electron. Now my dear students, there is fight in between lithium and cesium, am I right? This is big fight in between lithium and cesium. Which one is correct, which one is wrong? Do let me know in the chat section so that I can explain. This is good question or not? Do let me know, kids. Is this good question or not? I want to ask you, kids, is this really a good question or not? This question means a lot or not? Okay, everyone, just to let me know. This question is really down the group ionization enthalpy decrease is wrong. Down the group ionization energy decreases or increases? Decreases. You are right. Hasan Abbas, you are right. It is right. Boss, just try, kids. Only some more time, kids. Just I'm reaching towards Born-Haber cycle, the preparation of NaCl, and there I will stop, kids. There definitely Baba will stop. I was thinking of reaching up to NaCl so that I can make it crystal clear. This only I'm reaching towards that only, reducing agent, oxidizing agent, so that I can tell you Born-Haber cycle. That is going to be the last. Now, let me tell you that who is going to be the best reducing agent. First of all, let me tell you what do you mean by reducing agent. Remember that Let me write down over here reducing agent and oxidizing agent. Let me write down over here reducing agent and oxidizing agent. How many of you are getting confused? Maximum time you are confused. So let me write down that oil libra. Everyone say oil libra. Oil libra. And here rigiboa. 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 Oil libra. Rigiboa. Everyone say along with me. Oil libra. Rigiboa. Rigiboa. Now what is the meaning of this oil libra and rigiboa? Just see. Just see to it. O for oil. Oil means O for oxidation. Is loss of electron. Loss of electron. By reducing agent. By reducing agent known as reductant. Known as reductant. And the best reducing agent in this world is lithium. Is best reducing agent. Now rigiboa. Rigiboa stands for kids. Reduction is gain of electrons by oxidizing agent known as oxidant. Known as oxidant. Now my dear friends, fluorine is best. Fluorine is best oxidizing agent. Now don't you think it's a little bit tough, confusing? So Baba is here to make it simple. Baba is here to make these 2 points simple. Then you can understand Hess law. Then you can understand Born-Haber cycle, lattice energy and hydration energy. Just I need 15 minutes. Definitely you will be able to understand each and everything. Now see kids. Some questions are simple and some questions come through like this, step by step. Just see. If I compare fluorine, if I compare lithium and if I compare cesium, just see. Lithium and cesium both are being solid. Sublimation energy. What is that sublimation energy, kids? The energy required to convert solid into gaseous form. Am I right, kids? Am I right, kids, or not? So it is endothermic. It is being endothermic. Both means we have to supply energy. So endothermic. So delta H is positive. Delta H is positive. Now once they have converted into gaseous form, this has become gaseous. This also has become gaseous. Cesium gaseous. Now we have to eliminate out their electron. Once again we are supposed to supply energy known as ionization energy. Here also ionization energy. Now this will become lithium positive gas and this will become cesium positive gas. Once again, the delta H is positive. We have supplied energy. Now, my dear students, they will go inside the water. Now they will go inside the water, and water loves whom maximum? Once they are going inside the water to become aqueous. Lithium positive, aqueous. You must have seen aqueous. This will also go inside the water, and this will become cesium positive, aqueous. So this is three-step process, and here the delta H is negative. Energy will get released. Now here the thing lies, my dear students, water is like mother. Remember that water is like mother, and mother loves the smaller ones. Let me tell you, here water is like mother. Remember my word gets, water is like mother, and mother loves whom more? Mother loves smaller ones more. Mother is loving everyone, but mother loves smaller ones more because they need more care, because they are smaller. Am I right? This slogan, if you are able to understand this slogan, you can understand each and everything. All the answers will be yours if you are able to understand this point. Now tell me, who's smaller? Definitely definitely who is smaller? I have told you in the previous page, lithium is smaller in size and cesium is bigger in size. So mother loves whom? This is smaller in size. This is bigger in size, my dear students, bigger. So water will love this cation more. So this is known as hydration energy, and this hydration energy will be maximum. So if you add all these three energies, one energy, second energy, and third energy, these three energies, so delta H negative, because delta G is equal to delta H minus T delta S, gives Helmholtz equation. So maximum delta H negative will come for this. Delta H negative will be maximum for this, the upper one will be maximum, and he is winner because of hydration energy. Hydration energy has given maximum support. You are getting my point? And same thing is the case with fluorine, chlorine. So after this, Baba is going to tell you. If you are able to understand, do let me know in the chat section. Everyone, do let me know in the chat section you are able to understand. So Baba is going to tell you the size and the ionic mobility also, then you can understand what I am going to tell you. See, if I say lithium, sodium, potassium, rubidium, cesium, and leave the francium because that is being radioactive, leave that, the size increases in this order. This is the size of these elements in molten state. If I say lithium plus sodium plus iron size, this is the size in molten state or gaseous state. Molten or gaseous state, this is the size. Who is saying my size is maximum? Cesium is saying my size is maximum size, and that is saying I am the smallest one, least size. But my dear students, once they are going inside the water, once they all are going inside the water, then what water will do? Water loves maximum to whom? The smaller one, and the water will surround this lithium from all these sides. Water will surround this lithium from all these sides like this plus. So the oxygen will come over here and it will surround it from all these sides. From all these sides it will put such type of thing that maximum solvation, that hydration will happen. So its size now will become this much. Now this much size will become, my dear students, I would like to say, now the size of water, not the water, lithium size will be this much. Just see, lithium size will become this much due to maximum solvation. Here is maximum size because of maximum solvation, because of maximum solvation. Now I would like to tell you one thing very clearly, that more the solvation, more the bonding. Solvation means bonding, so its hydration energy will be maximum hydration energy, that is negative exothermic maximum. So if I say that cesium was bigger one, earlier the lithium was having this size and the cesium was bigger, it was having this much of size, but once they have gone inside the water, water said, hey cesium, I don't want you, I don't love you. So the cesium will be surrounded by only few water molecules, only few water molecules are going to surround it. So the size will not increase that much. After hydration, its size is only this much. So is bigger in size in the aqueous solution, the order got changed. So this is aqueous smaller, the one who was bigger, water made it smaller, and the one who was smaller in water, that has become bigger in size. So it is having maximum hydration energy, kids. So if anyone is going to ask, compare the size. If anyone is going to ask, compare the size, and it is written like this, it's hidden something written like this, what to say, that it's written lithium plus aqueous means inside the water. So remember that sodium plus aqueous, K plus aqueous, rubidium plus aqueous, then this is the size, my dear students, because aqueous written, so it is written inside the water, and the size inside the water will be governed by the mother, and mother will make smaller to be the biggest one. This is having maximum size, very good, maximum size. You will say, sir, are you right? Yes, I'm right. This is hydrated form, and this is being the least size. The least size, who will run fast? This smaller one will move fast, because the ionic mobility, if I talk about ionic mobility, then the ionic mobility you must have studied in this chapter, predictable. Once again it will come in the electrochemistry, and once again it will come solution. Ionic mobility is inversely proportional to solvated size of ion. Solvated, it will even come in the organic chemistry, nucleophilicity also. Solvated size of ion, solvated size of ion. So definitely this is maximum in size, so will move slowly, and that will definitely move speedily. It will move speedily, and that's why I always say that who you are doesn't matter, where you are, that matters a lot, because it all depends the medium. If the shark and you are having fight, then definitely if you are on land, you are the winner, and if you are inside the water, the shark will be the winner one, because it all depends on the medium. So that is having more ionic mobility. Its ionic mobility will be more ionic mobility. Now if I talk about whose conductivity will be more, conductance will be more, its conductivity and conductance will be more. Now only one thing is left, Born-Haber cycle. It will take maximum 10 to 12 minutes. Now, are you ready? This is going to be the last topic, Von Haber cycle, kids. Last topic, 15 or 10 minutes, maximum 10 to 15 minutes, kids, not more than that. Kids, not more than that. 10 to 12 minutes, just 10 to 12 minutes, kids. Are you ready? I will take your just 10 to 12 minutes. Just 10 to 12 minutes. Okay, thank you, Medico. Guys, everyone, I want to see green hearts if you are able to understand. I'm sitting in front of the chat. Those who have not smashed the like button, smash it out. Now the Baba is in need of likes, kids. What to say, even I'm in need of likes. Now, just see. Now you have to help me. You have to help me. Okay? You have to help me that I'm going to reach to this lattice energy. Do you know what is lattice energy? Have you ever thought of lattice energy? This lattice energy, people say, is directly proportional to charge and inversely proportional to size of ions. But how will you define what is being lattice energy? Is there anyone who can define what is lattice energy? So, Baba is going to define whenever one cation from the infinity in gaseous form and one anion in gaseous form, from the infinity you bring it together. When the molecules, they are coming closer, just like vapors, they are coming closer, they will release energy, they will form water. Once water molecules are coming close together, they will form ice, they will release energy. Once they are releasing energy, their energy is getting decreased and their stability is increasing. This is the water cycle. In Hindi there is one saying, kabhi kisi ko mukambal jahan nahi milta, kabhi zameen to kabhi aasman nahi milta. That no one is getting the best possible position. Sometimes we are getting freedom, we are losing our stability, and just in need of stability we are losing our freedom. The whole world is moving like this. Sometimes we are losing freedom, we are getting stability. Some other time we are losing stability, we are getting freedom. But never we are able to get both the two things. So, my dear students, just see. They are coming from infinity and they are forming salt, NaCl, salt, and this is crystal lattice. So, my dear students, they were having more freedom when they were alone. One hero, one heroine, they were alone, they were having freedom. Now their freedom has been lost. Now their stability is more. Suppose if I say this is being sodium, this is being sodium when he was alone, this is Champa when she was alone. They were having more freedom, but now they got married. Their freedom, I don't know, but they are more stable. They have lost energy. Delta H negative, that is crystal lattice energy. I will say I don't know the value. Anyone going to tell me what is the lattice energy value when Na plus Cl negative is coming together? They are forming crystal lattice solid lattice energy. Hey, sim. What is the lattice energy of these molecules, everyone? What? How much? 786. Sure. They are saying near about 800. So, minus 786 kilojoule per mole. I don't know whether it is right or wrong. Anyone, can you let me know how much is the lattice energy? You have to help me, kids. Minus 786 kilojoule per mole. Let me see in the chat. Just to let me know how much it is given. How much it's being given. Wow, 787 only. Minus. Oh my God, Baba's memory is really awesome. Now kids, if you go to thermodynamics, there is one there is one thing. बाबा बात कर रहे थे चंपा से. There is one thing. If you go to thermodynamics, that thermodynamics says enthalpy of formation. Have you heard this word? Enthalpy of formation. This is given in thermodynamics, but it is in this chapter also. Enthalpy of formation of NaCl. If I want to talk about enthalpy of formation of NaCl, then how I will prepare? Then I will say it's Na solid half Cl2 gas. In their natural form, they will form 1 mole of NaCl solid, and whatever the energy is released, that will be the enthalpy of formation. Now, Champa, how much is the enthalpy of formation of NaCl? Any idea about it? Champa is my assistant. What are you talking about? 411. I will ask to these students. I don't know you are right or wrong. Champa, I can't have faith on you. Kilojoule per mole. Now, my dear student, Champa is saying this much kilojoule per mole. You do let me know. Let me see in the chat section. Champa is saying like this. Everyone just do let me know. How much is the enthalpy of formation of NaCl? This is the last topic. Just 5 minutes more. No, it's wrong. Can't be 787. That was the lattice energy. That was the lattice energy. Arey, just get it from somewhere. Get it from somewhere. The chat GPT, the what to say, number of system are there. You can get it from there. You can get it from there. No idea. Okay. No one. Okay, let's go with Champa. People are very intelligent. They are saying, hey, let's go with Champa only. Okay. So see, Champa is always right. Now see, my dear students, thermodynamics says it will get prepared from this by this. This is according to thermodynamics. Now, what is the actual thing, kids? What is the actual thing that we should understand? And that is going to be the Born-Haber cycle. Is there any relation in between enthalpy of formation and the lattice energy? And that is the thing. See, kids, everyone just see to it. 411 only. Wow, thank you, thank you. Now see. One is that we have prepared Na. We have taken Na solid. Now Baba is going to tell you Born-Haber cycle. This is the last one. Born-Haber's cycle. Na solid plus half of Cl2 gas is forming NaCl solid. Crystal lattice, the energy enthalpy of formation is minus 411 kilojoule per mole approximately. I don't know the exact value, but approximately. Now there is one Hess law. Hess law says whether you carry out any process in single step or multiple step, the sum of energy will come equal. Now if I do one thing, if I convert it into, see what the conversion Baba is going to do, and let me convert it into what the conversion Baba is going to do. Just focus on this. This is going to require just 4 minutes. Now if I say that solid cannot react, let me make it gas. So what I'm supposed to do, I will supply energy that will be known as sublimation energy. Let me come to the actuality. Sublimation energy. Now kids, sublimation energy is required energy, endothermic process. So delta H will be some amount positive. Let's say 1 to 1 kilojoule per mole. Approximately it will be like this. And gas to Na positive gas, this is the ionization energy, and its ionization energy is Champa. Any idea about the ionization energy of sodium? What? 496 minus, okay, minus 496. I have faith on Champa. Minus 496 kilojoule per mole. Now dissociation energy, Champa, how much is the dissociation energy? So half of that I have to take, so near about it's 100. Half of dissociation energy is 100 approx. Exactly I don't know, Champa is unable to tell me. So it will become Cl gaseous, and Cl gas to Cl negative gas, this one though I know very well. This is electron gain enthalpy minus 349 kilojoule per mole. Now my dear student, you see this has become Na positive gas, and this has become Cl negative gas. Now two gas they are combining, then definitely what they are going to do, they will form the same NaCl solid, and the energy released will be known as lattice energy, and that amount we know very well, minus 787 kilojoule per mole. Now Hess law says whether the process is carried out in single step or the process is carried out in multiple steps, that amount of energy should be same. Now let's check it out whether Hess law is right or wrong. Whether Hess law is right or wrong. Everyone, are you ready? Just see, add it. Add these energies. Help me kids, help me. This is the last episode. 121 plus 100. 121 plus 100 approximately. And these are the, this is the required energy. This is also required kids, it can't be negative, required na, so positive, required, endothermic, so positive, it will be positive. Champa, you have given wrong data, 496, so add it, approximately 6 plus 1, 7, 2, 9, 11, 4, 2, 6, 7, 7, 1, 7, and this much is released, 341, and this much is also released. So let me add these two. Now minus 787 and minus 349, 9 7 16 6 यहाँ से लिए गए, 4 12 13 की 13 यहाँ से लिए गए, 1 7 3 10 11 minus this, and this is plus, this is minus, subtract it from it, how much it is going to come, see kids. Let me check it out. Minus 1136 plus 717, 16 में से 7 गया 9, और 2 में से 1 गया 1, और 11 में से 7 गया 4, minus 419. See kids, approximately it is correct, minus 419 and minus 411. So it is about, because I don't know exact data, but it is 419 and that is minus 411, only 8 is difference. Kids, you got it. Baba has completed each and everything kids, each and everything kids. Vignesh Patel, you can give me red hearts, whatever the green means, green to go, and each and everything Baba has explained kids, nothing is left. Session is over kids, session is over kids. Really thanks a lot. Baba will say, Baba is giving a lot of love to you. Pranam, namaskaram, dil se salute from the internal core of my heart kids. God bless you, love you kids. Each and everything you have completed, nothing is left kids. And now Baba is taking this class not from his home. Baba is at the studio. Now I will go back to home. I don't know whether what to say, anyone is going to open the gate or not, kids. But kids, how was the session? I've completed each and everything. Whenever you get time, you can comment. Not right now, not after the class, because take your healthy sleep. What to say, how to get healthy sleep. Definitely no one is going to get that sleep, but try to get it, kids. Let's see to it. God bless you, kids. God bless you. God bless you. Namaskaram. Namaskaram. Kids, bye to each and everyone. Bye bye, kids. Lot of love from Baba's side. Lot of love, kids. Lot of love. Bye, kids. Love you, kids. God bless you, kids. Yes, Sahana, sure. Bignesh Patil, good morning. Sarha, Shivam Mishra, bye. Kirti, bye. Naufal, Chandrika, KSP, Sagar Meher, Sahana, Haricharan, Sai Pravalika, bye. Medico, Niranjan, oh my God, Gayatri, Basundra Boss, B. Praveen, bye. Sairia Sausi, Baba pose. Okay. Hey kids. Bye to all of you. Yes. Yeah. Okay. Bye to all of you kids. Bye bye. Yes, kids. Bye. Yes. Okay, Sausi. Sausi, now it's okay. Dikshita, bye. Pramila, bye. Wow, kids. Thank you, Haricharan. Monica, Priyadashni, bye. Manas, bye. Dikshita, bye. Yes, sure. Tell anything. People must be thinking chemistry pedicure adu customer, but I would like to say LL, it's Romba Sulvam. And in the starting it was looking idiyappam, muruku, but now it's nalla iriku, Romba Sulbham. Everyone is a disco dancer. Virat Kohli adicha 6. Sharma pedicha catch out. Tell any Tamil dialogue. Tamil dialogue, I don't know, but whatever I know, I told you. I will learn it. Masundra Bose, bye. Kids, दुआओं में याद रखना. Bye, Bignesh, Angeline, Haribala. Bye, kids. Bye. Really, bye. Nishita Mahato. Baba's English, Baba's Hindi. You liking or not liking? Nishita? Thank you, Shivam. Thank you. Really, thank you. Tamil, these kids told me, these kids in the special classes or Phoenix classes, they always tell me, that's why Baba is learning a bit of Tamil, so Baba knows. Sarha, Angeline, bye Gayatri, bye kids, bye to all of you. Nishita liked everything, thank you. I was thinking what happened. These kids, always they are speaking Tamil, so I got it a little bit. Sing a song, so I don't know how to sing. रुक जाना नहीं तू कहीं हार के. Thank you, Raju MU. Sahana, bye. Gayatri, bye. Bye now, kids. Baba is going. Okay, take care, kids. Telugu I learned one, but I have forgotten. I have forgotten one sentence I was having in my brain, but no, it's not there. Anyways, kids, take care. You are really awesome, kids. You are special. You are really special. Your presence is more than any other gift. Bye, kids. Bye. Bye.